Hello everyone. In this video, I'm going to discuss about what is infrastructure as a code. Understanding the basics. There are two ways in which you can create and manage your infrastructure. The first one is using manual approach. The second one is through automation. Let's take an example. We have to create a 10 virtual machine in Azure. So in manual process implementation, firstly, we are going to log in inside the portal. We're going to create a virtual machine and the same process we are going to repeat for 10 virtual machine. Automation process. We are going to write a code and that can be called multiple times as needed. So we are going to write a code to create a virtual machine and this code can be called for 10 times or 100 times according to our requirement. What is infrastructure as code? Infrastructure as code is the managing and provisioning of infrastructure through code instead through manual process. So what is the exact meaning of it? In the last slide, what we do have discussed, to create a infra, we do have two options. One, it is using manual process and the another one using code. So if we are going to write a code for your deployment of infrastructure, then it is called as infrastructure as a code tool. Okay. So what are the benefits of using infrastructure as code? The first benefit is speed of infrastructure management. As we do have discussed in the last slide, if you are going to create 10 virtual machine using manual process, you're going to repeat the same things for 10 times. While in case of infrastructure as code, we do not need to repeat the code 10 times. We are going to write a code for once and good to call for n number of time. Low risk of human errors. Exactly. If you're going to deploy the infra using manual process, there would be some chances of the human error. While in the case of code, there are chances are very less. Version control. In the upcoming videos, we are going to discuss about the version control. Easy collaboration between teams. In the upcoming videos, we are going to discuss about the CI/CD for the infrastructure as a code, and the second one is Terraform Cloud for the deployment of infrastructure as a code tool. IaC tools provided by cloud. If you see in AWS, we do have CloudFormation. In Azure, we do have ARM template, and there is one more tool called Bicep. In Google Cloud, we do have a tool called Deployment Manager. So all these tools are basically infrastructure as a code tool provided by a specific vendor. Why should you choose Terraform? If you see in this diagram, AWS can also be implemented in Terraform, Azure can also be implemented in Terraform, and Google Cloud can also be implemented in Terraform. In the last slide, if you are working on AWS, you need to learn what? CloudFormation. While in the case of Azure, you need to learn Bicep. And for Google Cloud, you need to learn Deployment Manager. While in the case of Terraform, it is not dedicated to a specific tool. It, the Terraform is compatible with all these cloud vendors. What is Terraform? Terraform is an open source infrastructure as a code tool provided by HashiCorp. It is used to define and provision the complete infrastructure using an easy to learn declarative language. So, what is the exact meaning of it? Open source tool means it would be free. We don't need to pay any kind of charges to use this Terraform. The second thing is it is easy to learn and declarative language. The code which we are going to write for Terraform, it is very easy to understand. Terraform official documentation link is Terraform has a very good documentation. You can go through this link to explore the Terraform documentation. It is an infrastructure provisioning tool where you can store your cloud infrastructure setup as code. As we do have discussed in infrastructure as a code, we do have n options and one of the options is Terraform. Prerequisite to learn Terraform. Basic understanding of cloud platform. Eventually, if you are learning Terraform, what we need to do, we need to create an infrastructure. To create an infrastructure, you should be aware about any one of the cloud platforms. It can be Azure, it can be AWS, it can be Google Cloud, it can be Alibaba, or it can be Oracle Cloud. No programming skills is required. So to learn the Terraform, you don't need to have a programming background. I would say C++, Java, Python. Golang. Benefits of Terraform supports multiple platforms, has hundred of providers. As we do have discussed in the last slide, like Terraform support n number of vendors, and these vendors are basically called as providers. Okay, it support Alibaba Cloud, it support Oracle Cloud, it supports, I would say, Azure, AWS, Kubernetes, Datadog. There are n number of providers which are supported by Terraform. Simple configuration language and faster learning curve. As we do have discussed in the last slide, the way the Terraform code is written, it is a very simple language, and parallelly, we do not need to have a prerequisite from the programming background. Easy integration with configuration management tool like Ansible. In the upcoming videos, we are going to have a very detailed discussion between the Ansible and the Terraform. Easily extensible with the help of plugin. Terraform supports n number of plugins which really helps while writing or implementing our infra code. Free. The Terraform is an open source tool, that's why it is free. So we do not need to pay any kind of license to learn or to implement the Terraform. Hello everyone. In this video, I'm going to discuss about the categories of infrastructure as code. Categories of infrastructure as a code. So one category is orchestration tools, and the second category is configuration management tools. Terraform, CloudFormation, Bicep, Deployment Manager are the infrastructure orchestration tools, which basically means they can provision the server and infrastructure by themselves. So if you want to create any kind of infra, then we need to use orchestration tools, and there are n numbers of tools which are provided, and one of the tool is Terraform. Ansible Safe and Puppet are configuration management tools, which means they are primarily designed to install and manage software on existing servers. So once we create an infra, I would say, let's take an example. We have created a virtual machine. Okay. And once it is created, we want to install some set of software or to do some configuration part. In that case, we are good to use the configuration management tool called Ansible. So the orchestration tools are basically responsible to create your infrastructure, and configuration management tools are basically responsible once your infrastructure is created to do some configuration changes. Ansible versus Terraform. So Terraform is orchestration tool while Ansible is configuration management tool. What is the use case of Terraform? Terraform is focused on infrastructure provisioning, while the use case of Ansible is deploy and configure the application that run on top of infrastructure. Terraform is well suited for orchestration cloud services and set up cloud infrastructure from scratch, while Ansible is well suited for configuring servers with the right software and update on already provisioned cloud. So if you want to create a virtual machine, then Terraform is the best choice. And once this virtual machine is created, you want to install some set of software, then Ansible is a good choice. Apart from that, in Terraform, we do have one concept called provisioners, using which we are good to use the configuration part also for the virtual machine. In the upcoming videos, we are going to have a very detailed discussion for the provisioners. IaC and configuration management tools is equal to friends. So if you are going to write any Terraform code, we need to save the file with the extension of TF. So we are going to write our Terraform file. It would be the first step. Then the second step, it would be to run some set of Terraform command to create the infrastructure, and the new infrastructure will be created inside our Azure. Once the infrastructure is created, it is up and running. The fourth stage, it would be our configuration management tool, and the configuration management tool, it would be responsible for installation and configure our application. Hi everyone, in this video we are going to discuss about setting up environment. So what does it exactly mean? It means like what are the tools required to run the Terraform. So the first tool that would be required called Terraform CLI. The second tool that would be required our Visual Studio, and the third tool that would be required is Azure CLI installation part. So why we need these three tools? So the first tool is like a Terraform to do the commands, or I would say to implement the commands of the Terraform. So we need to install this one. The second one is using I would say we need to use one IDE for our writing our code, although we are good to use the notepad also, but it is not a user friendly and there would be n number of challenges while writing a code in the note. So for the IDE implementation, I'm going to use the Visual Studio. Third and the most important thing, we are going to use the Azure CLI. Azure CLI for what? For the authentication part. So the whole diagram, it would look like this. We do have our cloud in which we are going to, I would say, Azure cloud, in which we are going to create our resources, and this one, it would be our local machine. So in the local machine, we need to have the Terraform to run our Terraform code. The second one, we need to have, as I do have mentioned, the Visual Studio to write our code. And the third one is like to provide the bridge. What is the meaning of the bridge? Authenticate ourselves from a local machine to Azure. That's why we are using an Azure CLI to log in from our local machine to the Azure platform. So the upcoming videos will provide you an detailed explanation how are we going to install the Terraform, Visual Studio and the Azure CLI. Hi everyone, in this video I'm going to download Visual Studio Code. So I'm going to open Microsoft Edge, and here I'm going to mention Visual Studio Code for Windows. So let me click on the official documentation. Here we are having multiple options, one for Windows, then another one for Linux and Mac. So in this demo, I'm going to use the Windows virtual machine. So I'm going to download on Windows one. So the downloading process has been started. So it has been downloaded. I'm going to click on Open File. I'll click on OK. I'll accept the agreement. I'll click on Next. I want to create a desktop icon. Then I will click on Install. The installation process will take around a minute. So we have downloaded Visual Studio Code. So once the Visual Studio Code is downloaded, the next thing which we have to do to install some extension. So I will write here Terraform. So and this extension will help us while writing our Terraform code. This one, and this is the official one from hasicop.com. So we are good to install it. So we have installed our Visual Studio Code and parallelly installed the Terraform extension also. So in the next video, we are going to install Terraform inside our local virtual machine. Hi everyone, in the last video we have downloaded Visual Studio Code. In this video we are going to download Terraform CLI for Windows. So I'm going to open again the Microsoft Edge, and then I'm going to write Terraform CLI for Windows. So I'm going to click on this official documentation, install Terraform. And here if you see, we are having multiple options. One, it is for Mac, then for Windows and for Linux. So we are using a Windows virtual machine. So I'm going to click on download option. So it has been downloaded. Let me click on the folder. So this is the Terraform file which we have downloaded. Let me click on this PC. The first thing which we have to do, we have to create a dedicated folder for it. I would say Terraform. And then in this Terraform folder, I'm going to paste the application which we do have downloaded. And if I'm going to open my CMD, and write Terraform hyphen version. So it is giving an error. So it is mentioned Terraform is not recognized. So what we have to do, we have to set up a environment variable for it. So I'm going to search for environment variable. Then I'm going to click on OK. Then select the option for environment variables. Then I need to select for path. Then click on edit. I need to create a new environment variable. I will copy paste the path which I have copied. I'll click on OK. Again OK. Again OK. Again I'm going to type a command called Terraform hyphen version. So still we are getting an error. Whenever we set up an environment variable, the first thing which we have to do is to have a new session. Let me open a new CMD, click on open, and I'm going to, if you see here, Terraform has been installed in our local machine. Okay. In the next video, we are going to install Azure CLI in this virtual machine. In this video, I'm going to do a quick demo on Azure CLI installation. So the first thing which I'm going to do to open my Microsoft Edge, once it is opened, I'm going to mention Azure CLI installation. So this is the official page of Microsoft. And then I'm going to select the install on Windows. Here we do have multiple options to download the Azure CLI. I'm going to select on 64-bit using MSI. So Azure CLI has been downloaded. I'm going to click on open file and the installation process has started. I will accept the terms in the license agreement, then click on install. So Azure CLI has been installed in this machine. I'm going to click on finish. Let me open the CMD. We'll mention is it hyphen version. So it is showing the Azure CLI version and the other dependency file also. Hello everyone. In this video, we are going to discuss about the providers in Terraform. What is Terraform providers? Terraform supports multiple vendors and each vendor is represented by its own provider. Depending on what type of infrastructure we want to launch, we have to use appropriate providers. Example, Azure Task use Azure providers, AWS Task use AWS providers. So if you're going to use AWS, we have to use AWS provider. Then for Azure, we are going to use Azure providers and same for other vendors also. It is good to say there is one-to-one mapping between the vendor and provider. How does Terraform provider works? Terraform creates and manages resources on cloud platforms and other services through their application program interface. Providers enable Terraform to work with virtually any platform or service with an accessible API. If you see here, left hand side, this is our local machine where we are going to write our Terraform configuration file to create the resources or to delete the resources. In the right hand side, I would say is our target API. I would mention Azure. So from our local machine, we are writing a code to create the storage account. And eventually we want to create our storage account in Azure cloud. So there should be someone who is going to fetch a request from our local machine and send it to the target API. So for this case, we need to use Terraform provider. Here I have mentioned the Azure one. So the target provider, it would be Azure RM. If the target API is AWS, we need to use AWS provider. Okay, so it is good to say the providers is a middleman who is responsible to fetch the request from our Terraform configuration and send it to target API. Important question. Today I'm working in Azure and learning Terraform through Azure. If in the future I start working in AWS, will I need to learn Terraform again? Question is, today I'm working in Azure. I'm learning Terraform through Azure implementation. To be very precise, learn Terraform using Azure RM provider. Okay. Tomorrow, if I'm going to start working on AWS, do I need to learn Terraform again? So the answer is no. The core concept and standard syntax remain similar across all providers. If you learn Terraform on one provider, you will be able to work with all providers easily. I have implemented Terraform using Azure RM provider. Tomorrow I would be able to implement the same thing in AWS. The core concept, it would be same. I would say 90% of the things it would be same. Only 10% I would say in terms of authentication and the other part will change. The official website of Terraform is registry.terraform.io. And if you see here, around 4,679 providers are supported by Terraform. Provider maintenance. Type of provider tiers in Terraform. So the whole providers tier is divided into three types. The first one is official, owned and maintained by HashiCorp and technology company. The second one is partner, owned and maintained by technology company that maintains direct partnership with HashiCorp. And the third one is community based, owned and maintained by individual contributors. If you see here, the Azure RM is the official provider, while OCI is a partner provider, and the last one is community based provider. If you go through this explanation, lifecycle management of Microsoft Azure using the Azure Resource Manager API maintained by Azure team at Microsoft and the Terraform team at HashiCorp. It means Azure RM provider is maintained by HashiCorp and Microsoft team. While in the case of OCI, it is a partner providers. Interact with many resources supported by the Oracle Cloud Infrastructure via the OCI Providers API. If you see, it is maintained by Oracle only. And finally, this one is a community-based provider. So it is maintained by the individual users only. So the important question is how to use provider. To use provider, we need to mention this set of codes. Okay. And it is not about the Azure RM. In every provider at the right corner, an option how to use this one. And this code you have to mention in your .terraform configuration. In our upcoming video, we are going to have a very detailed discussion about the implementation and the uses of this provider. If you see here in OCI also, the same thing is there at the right corner. There is one option called use provider, and here it has the provider configuration, which you have to mention inside your Terraform configuration. Difference, if you see, the Oracle is a partner one, so it is having Oracle / OCI, while Azure RM is the official partner, so the source code is present inside HashiCorp / Azure RM. Hello everyone, in this video I'm going to do a quick demo on Terraform providers. So the official site is registry.terraform.io. If you see here, we are having around 4,680 providers. As we do have discussed in the last video, the Terraform provider tiers are divided into three parts. The first is official, second is partner, and third is community one. So let me firstly explore the official one. The official, if you see, AWS, Azure, Google Cloud, around 35 are the official Terraform providers. If you're going to click on the partner one, I would say Alibaba Cloud, Oracle Cloud, and around 371 is a partner based provider. And if you're going to click on community based, so it is having around 4,274 community based Terraform providers. So the second question comes, how are we going to use this provider? Let me open this one. If you see in Azure RM at the right corner, it is mentioned use provider. In the AWS also, it is mentioned the same thing. If we are going to mention any partner based providers, or I would say the company based provider, in this one is official one, this one is a partner one, and this one is a community based. In each and every provider, it is at the right corner, it is clearly mentioned how to use the provider. So they do have mentioned the Terraform configuration, which you have to copy paste, inside your Terraform configuration. And when we are going to run Terraform in it, it will download the Terraform providers, which will be responsible to interact with the API. We are going to have a very detailed discussion in our upcoming video. Hello everyone. In this video, I'm going to discuss about the authentication with Terraform. Authentication with Terraform. Before diving into managing environments or creating resources with Terraform, the crucial initial step involves authentication and authorization. If you see in the left hand side, we are having our local machine. And the right hand side, we are having our Microsoft Azure, to be very precise, our dedicated subscription in which we are going to work. And in the local machine, what we have done, we have created a file name called as storage.tf. And in this file, we have mentioned all the resources which are required to create the storage account. But the first thing comes, we need to create a bridge between our local machine and subscription. So we are going to do the authentication part. Once we are going to do the authentication, then we are good to create the resources, or I would say update the resource, create the resource, or destroy the resource. Authentication with Terraform. First step, open a CMD and type a command azlogin. Once you are going to type a command called azlogin, a web browser will be opened to enter the username and password. Once you are going to mention the username and password, the authentication part will be completed. You will see the details about your subscription name, ID, and the tenant. Okay. Hello everyone. In this video, I'm going to do a demo on Terraform authentication. So what we have discussed till now. In our local machine, we are creating a file name called as storage.tf. The end goal is to create storage account. Okay. And this storage account will be created inside my Azure cloud. But the first step which we have to do is our authentication. And once this authentication is done, we are good to run the Terraform command to create our storage account. So to initiate the authentication process, what we have discussed in the last video is a command called IaC login. Okay, so let me open my CMD and run this command. It is IaC login. Automatically a web browser has opened. It is asking for my email ID. I'll mention my email ID, akashkumar9750@outlook.com. And then I need to click on next. So it is going to send a sign in request on my app. I will click on send notification. For authentication completed, let me open my CMD. See our subscription name, subscription ID, and default directory. And it is mentioned here, select a subscription and tenant, type a number or enter for no changes. So currently I will enter for no changes. Okay. Apart from IaC login, we do have one more command called IaC account. So it will provide a detailed information about my account. Okay. And if you are having a multiple subscription, then in this case, what you have to do, you have to mention IaC account set -s and my subscription ID. Hello everyone. In this video, I'm going to do a demo on Terraform authentication. So what we have discussed till now. In our local machine, we are creating a file name called as storage.tf. The end goal is to create storage account. Okay. And this storage account will be created inside my Azure cloud. But the first step which we have to do is our authentication. And once this authentication is done, we are good to run the Terraform command to create our storage account. So to initiate the authentication process, what we have discussed in the last video is a command called IaC login. Okay, so let me open my CMD and run this command. It is IaC login. Automatically a web browser has opened. It is asking for my email ID. I'll mention my email ID, akashkumar9750@outlook.com. And then I need to click on next. So it is going to send a sign in request on my app. I will click on send notification. For authentication completed, let me open my CMD. See our subscription name, subscription ID, and default directory. And it is mentioned here, select a subscription and tenant, type a number or enter for no changes. So currently I will enter for no changes. Okay. Apart from IaC login, we do have one more command called IaC account. So it will provide a detailed information about my account. Okay. And if you are having a multiple subscription, then in this case, what you have to do, you have to mention IaC account set-s and my subscription ID. Okay, so with this, we have completed this demo. Hello everyone, in this video, we are going to discuss about the resources in Terraform. What are resources in Terraform? In Terraform, resources are the fundamental building blocks that represent components of your infrastructure. These can be anything you manage and provision, such as resource group, storage account, virtual machine, etc. A resource is defined by a block in your Terraform configuration file, and each resource block describes a single piece of infrastructure and its configuration. So, what is the exact meaning of it? If you want to create a storage account in Terraform, then you need to write a resource block for it. If you are planning to create a virtual machine, then you need to write a resource block for it. The exact syntax of resource block is the first thing which you need to mention is resource, then the provider name, then whatever the resource type is, and then the resource underscore name. This is called resource name and this is called local name. Sometimes this is also called global resource name and this is called local name. And then you need to mention the configurations parameter. If you see this example, here we are creating a resource group. So the first one is resource, then our provider name, then our resource name, and this is the local name. And these are the arguments I would say which are required to create the Azure RM resource group. Okay. Let's do a quick demo to understand this thing in detail. I have already opened official documentation of Terraform. We'll click on Browse Providers. We'll explore firstly the Azure RM provider. Till now, we did a very detailed discussion about the official partners. Then we have discussed about the use provider. So to create any resource block, we need to go to the documentation tab. Okay, so I'm going to click on documentation. And Terraform has very good documentation about each and every resource. If I'm planning to create a resource group, I will mention here resource underscore group. We are getting two options. One it is resources and the next one is data sources. Data sources we are going to discuss in our upcoming videos. In this video, we are going to discuss about the resource block. In resource block, we do have two options, Azure RM underscore resource underscore group, while the second one is Azure RM underscore resource underscore provider underscore registration. We will focus on Azure RM resource group. So the resource block documentation is divided into example uses, argument reference, attribute reference, timeouts, and import. So the first thing which you are going to see is the example uses. Here it is clearly mentioned what are the values we need to pass to create the resource group. The arguments are divided into two parts. I would say required and optional. Okay. The location and name is a required argument. That's why it is mentioned required, while manage by and tags are optional one. If we are going to miss the required argument inside the resource block, we are going to get the error. While the case of optional, it is not mandatory to pass the values. Attribute reference. In addition to the argument listed above, the following attributes are exported. We are going to have a very detailed discussion about the attribute reference in our output block. And for timeouts and import, we are going to have a dedicated session. Okay. Hi everyone, in this video we are going to discuss Terraform commands. So basically we do have 6 commands in Terraform. So Terraform init, the first command to run. Then we do have Terraform format, Terraform validate, Terraform plan, Terraform apply, Terraform destroy. Each and every command has its own functionality. Some of the commands are mandatory to run and some of the commands are optional. In this video, I'm going to provide you an overview about each and every command. And in the upcoming video, we are going to have a detailed discussion. What are the options we do have for running a Terraform plan? What are the options we do have for apply and for destroy? Okay. So the first command Terraform init. In the last video, we had a very detailed discussion. What is the main functionality of the Terraform init? So the Terraform init initialize a new or existing Terraform configuration. It downloads the necessary providers and module is specified in the configuration. The modules part we are good to ignore. We are going to discuss in our third and the most important, it creates a .terraform directory to store configuration and provider information locally.
What is the main functionality of the Terraform format command? The Terraform format command is used to rewrite Terraform configuration file to take care of the overall formatting. So the Terraform format command is basically responsible for the formatting. What is the exactly meaning of it? If you see the first diagram here, the name and the location are not aligned, but after running the Terraform format, the name and the location are aligned with each other. So this is the basic functionality of the Terraform format command to format the overall configuration in our Terraform file. The third command is Terraform validate. So the Terraform validate primarily checks whether a configuration is syntactically valid or not. It can check various aspects including unsupported arguments, undeclared variables and other. In the first diagram, what we have done, we have written a resource for resource group creation. We have mentioned an argument, name and locations. When we are going to run a Terraform validate command, we are getting an error. What is the error? The argument location is required, but no definition was found. And the error name is unsupported argument. What we have done wrong? We have mentioned locations instead of location. If you see the last line, it is mentioned like location is not expected here and the location is required. So whenever we are going to run the Terraform validate, it will list out the error which we do have in terms of unsupported arguments, undeclared variables, and I would say the syntax also. What is the main functionality of Terraform plan? So the main functionality of Terraform plan, it analyzes and evaluates the Terraform configuration, display a preview of changes to be applied, identify a new resource modification and deletion. In our upcoming videos, we are going to have a detailed discussion what are the options we do have while running a Terraform command. But in this video, I want to discuss what is the main functionality of Terraform plan. So Terraform plan, you are good to say it is basically responsible for dry run. What is the meaning of the dry run? Before running the configuration, I will say Terraform apply. It is always recommended to run the Terraform plan. We do have the three options. Either it is going to add a new resource, or if you are going to change any configuration, it will say like, hey, whatever the resources we are going to change, it will mention one or two to change. And if any resources, if you want to recreate, then it will mention for the destroy configuration. It executes the plan changes after confirmation. It applies modification to the infrastructure. It creates, update or delete resources as per the configuration. So once we do have our Terraform plan ready, we are up to the mark. The next command is Terraform apply. So Terraform apply is basically responsible for what? To create the infrastructure. When we are going to run a command Terraform apply, it will ask for the confirmation, and after the confirmation, it will create the infra. The functionality of the Terraform plan and the apply is same. The only difference is Terraform plan is a dry run and Terraform apply is responsible for creating the infrastructure in target place. So the last command which we do have, destroying infrastructure with Terraform. So what is the exact meaning of Terraform destroy? So Terraform destroy, it means like, let's take an example. We have created a one resource group and we want to delete this resource group. What we have to do, we have to run a command called Terraform destroy. Terraform destroy will delete the resources from the target place. When I'm mentioning target place, it can be your Azure, it can be your AWS, it can be your OCI, whatever the configuration in which you are working. So basically, to run the Terraform destroy, we do have the two approach. The one approach which I have already mentioned, Terraform destroy, whatever the configuration we are having, it will be deleted. The second approach we are going to discuss in the next slide. Let's take an example. We have written a two configuration, one resource group creation and the second resource group creation. But we want to delete a second resource group only, not the first one. So in this case, what we have to do, we have to run the Terraform destroy command. If you see, using a target option, and in the target option, we have to mention the global resource name and the local resource name. Then in that case, the second resource group will be deleted and the first resource group will not be deleted. So in our upcoming videos, we are going to have a demo and a detailed discussion about all the Terraform command. So thanks a lot for watching the video.
Hi everyone, in this video we are going to do a demo on Terraform command. So in the last video we discussed about the Terraform init command, Then we discuss about the Terraform validate command. Then we discuss about Terraform format command. And then we discuss about Terraform plan command, Terraform apply command, and we discuss about finally the Terraform destroy command. Okay, so we are going to do a quick demo on all this Terraform command. So the first thing which I have done, I have created a dedicated folder name as commands underscore demo. I'm going to create a file name called as rg.tf. And the second thing which I'm going to create, I would say providers.tf. Tab called use provider, I'm going to click on it. We'll copy this configuration. I'll paste it inside providers.tf. If you see on line number 11, we're getting an error. So what we have to mention here, features block. And regarding this feature block, we are going to have detailed discussion in our upcoming video. Paste it here. And we are planning to create what? Resource group. I'm going to mention Azure rm underscore resource underscore group. See here, I've copied the path. I've copied the resource detail. We'll paste it here and we'll update the resource group name as demo-rg. Okay. So the first thing which I'm going to do, I'm going to copy the path. We'll open a CMD. We'll go to this dedicated path. So the first command which we have discussed, it is Terraform init. Okay, we are having only two files inside the commands underscore demo. So let me start a Terraform init and see the differences. If you see here, .terraform folder has been created and a file .terraform log.scl. As we do have discussed, we are going to have a dedicated video regarding this one. So this is my local machine. This is my Azure account. In this Azure account, I'm having my dedicated subscription. So the first thing which we need to do is to authenticate. So the authentication part. So it has been already completed. What we have done, we have connected my local machine to a dedicated Azure subscription. Apart from that, what I have done, I have created a dedicated file name called as rg.tf and providers.tf. Okay. So once we have initiated .terraform init folder, it has downloaded the providers. Which provider? Which we do have mentioned. Here it has downloaded Azure RM provider. And this Azure RM provider, it would be responsible to connect to the Azure API, and whatever the request we are going to send it from my local machine in terms of updating a resource or destroying a resource, it will be done through my Azure RM provider. The main responsibility of my Azure RM provider is to paste the details from my local machine and send it to or connect with the Azure API and do the changes as per our requirement. Okay. So let me quickly show you inside .terraform folder what we have. I'm going to click on .terraform folder, then reveal in File Explorer. In .terraform folder, we are having a folder called providers. In providers, we are having registry.terraform.io, then HashiCorp, then Azure RM we do have. Inside this one, what was the version we do have mentioned? Azure RM version 4.12. This is the 4.12 version we have. We are running in Windows operating system. And this is the Terraform provider Azure RM version we are having. And this one, it would be responsible, as I do have mentioned, to connect between my local machine to the Azure API provider. Okay, so the main responsibility of the Terraform init to download the providers, and this provider, it would be responsible for connecting it to the target API. Okay. So the second command which we do have discussed, it is regarding the format. So intentionally, if you see what I have done, I have pressed tab and name and the location, both of them are not aligned. Okay. And then I'm going to run a command called Terraform. If you see here with Terraform format, what has happened? The name and the location, both of them are aligned. Let me do it again for you. So if you see the name and the location are not aligned, I'm going to run the Terraform format again. And if you see here, the name and the location, both of them are aligned. So the main responsibility of the Terraform format command is to formatting the code, or I would say to align the code in a proper way. So the next command which we do have discussed, it is called Terraform validate. Terraform validate if there is any kind of error present inside our code in terms of syntax or the argument which we do have passed. So on line number 3, what I'm going to do, I'm going to add s in location, and I'm going to run Terraform validate. If you see here, we are getting an error. What is the exact error? The first one is missing required argument. So it is looking for location, but no definition was found. This is one of the thing. The second thing is unsupported argument. We have mentioned locations, but what is the value we need to pass? We need to pass location. Okay. So whenever we are going to run Terraform validate, it will check if there is any kind of error present inside the code or not. Okay. If I'm going to run again the Terraform validate after rectifying the location typo, see, it is showing the configuration is valid. So till now we have discussed about the Terraform init, Terraform format, Terraform validate. Okay. So Terraform format and Terraform validate is an optional command. It is not mandatory to run it, Terraform format or Terraform validate, although it is good practice to always run both the commands. Apart from that, the Terraform init is a one-time command. One-time command, it means whenever the first time you're going to run your code, you have to run a command called Terraform init, because as we do have discussed, its main responsibility is to download the provider plugin inside our local machine. If you're going to do any changes in provider details, then again you have to run the Terraform init. Okay. Like I would say, if you're going to change the version from 4.12 to version 4, in that case, you have to run the Terraform init again. Or I would say, if you're going to update with one more providers, I would say called AWS, in that case also, you have to run the providers again. Okay. So the next set of command which I'm going to discuss is Terraform plan. We'll clear the screen. As we do have discussed in the last video, like Terraform plan is not going to create any resources for us or destroy any resources or update any resources, but it will provide the detailed information what is going to happen if we are going to run Terraform apply command. Let's run the Terraform plan to see its implementation. If you see here, the Terraform plan has given us plus create. It means it is going to create the resource, and the resource details are, it is our resource group name. It is Azure RM underscore resource dot example will be created, and then eventually it is showing 1 to add, 0 to change, 0 to destroy. If you see here, we are getting an error, duplicate resource. So what is the exact meaning of it? What we are doing, we are creating two resource group. One name called demo-rg, the second name called demo-rg1. Okay, but the resource name, but the resource local name is same. If you are creating two or more resource, okay, and both the resource are same, in this case the local name should be unique. Okay. If you see here what we have done, we have created a two resource block, but the local name is same. If what we have to do, we have to update the local name in this case, the Terraform will not give us the error. It will treat this resource block separate and this resource block as separate. To make it unique, it is going to use our local name. Let me run again the Terraform plan to check whether we are getting any error or not. Okay, so if you see here, what we are getting, we're planning to create two of the resources, and two of the resources, how it would be unique, the global name for the resource, and then it is having a different local name. Okay, so after the Terraform plan, what is the second command we have discussed? The Terraform apply. And what is the main responsibility of Terraform apply command? The main responsibility of Terraform apply command is to create the resources in our Azure cloud. Okay, so I'm going to run Terraform apply command. It is asking for a confirmation. Again, if you see, whatever the things we do have received in Terraform plan, the two of the resources are going to be created. The same thing we are getting in Terraform apply also. But in Terraform apply, we have to do the changes. So it is asking for the confirmation. If you're going to mention no, it will stop the process. If you see here, the two of the resources has been created. Okay, let me quickly check inside our portal. We are having a two resource group name called as demo-rg and demo-rg1. Okay, so till now we discussed the Terraform init command. And what is the main functionality of Terraform init command? To initialize the provider, to create a dedicated folder called .terraform where we are going to download the providers plugin. Then Terraform validate and Terraform format command. Both of them were optional. Terraform validate to check the configuration, Terraform format to set up the formatting. Then we had the Terraform plan command. The Terraform plan command is just provide an update. What are the changes is going to happen if you are going to run Terraform apply? And it was giving us three things. One, it is add. The second one was change, and the third one it was destroy. Okay, and finally the Terraform apply command. Terraform apply command is basically responsible to make the changes in our target place. And again, the Terraform plan is an optional command, but it is always good practice to run the Terraform plan command before the Terraform apply. Okay, so we are left with the last command, which is called as Terraform destroy. Okay, so I'm going to run a command called Terraform destroy and see. If you see, the Terraform destroy command is basically responsible for deleting the resource. We Here we are getting an option to destroy, and both the resources are going to be deleted. When I'm mentioning deleted, what it is going to do, in our portal we are having a two resource group, both of them will be deleted. So this is the main functionality of Terraform destroy. But apart from that, we do have one more option in Terraform destroy. Let me type no and enter. It will cancel the process. Let's take an example. We only want to delete a resource group name called as demo-rg. So right now what we have done, we have passed a command called Terraform destroy, and it was destroying both the rg. It was deleting both the rg. If you want to delete any specific resource, as we do have discussed in the last video, the command is Terraform destroy -target, then Azure RM resource group, the resource name, or I will say global name, then the local name, it is example 1. So there is one typo after the resource group. Let me rectify it. If you see here, it is going to delete only one resource group name called as demo-rg. So this is the benefit of using -target with the destroy option. It will delete only one rg. I'm going to type yes, and the deletion process will be started. Okay, so it has been deleted. And if I'm going to run Terraform destroy demo-rg, because demo-rg1 has been already deleted. If I want to give auto approve, it won't ask for any confirmation while deleting the resource. I'll mention hyphen auto hyphen approve. If you see here, our resource group has been deleted. So it has not asked for any confirmation before deleting the resource. Why? Because we have mentioned auto hyphen approve. If you're going to mention the same thing in Terraform apply, then in Terraform apply also, it is not going to ask for any confirmation. Automatically, it will do the changes. Okay. So we have completed all the Terraform commands. In our upcoming videos, we are going to discuss more in detail about the Terraform plan and Terraform apply. What are the other values we are good to pass at the runtime? Okay. So with this, we have completed this demo. So thanks a lot. Hello everyone. In this video, I'm going to do a quick demo on Terraform providers. Provider architecture. If you see in this diagram, what we want to create a new server in Azure. We already have a very detailed discussion regarding this one in Terraform commands video. Let's do a quick recall. We have created a file name called as file.tf. In this file.tf, I have created two blocks. One, it is for provider and the next one is for resource block. The provider block which I have mentioned, it is Azure RM, and the resource block which I have mentioned, it is for virtual machine. Then we are going to run a command called terraform init. As we have discussed, the terraform init is going to download the Azure RM provider in my local machine in a dedicated folder name called as .terraform. And then this Azure RM provider is responsible to connect to my Azure API. And then I'm going to run terraform apply to create the virtual machine inside my Azure subscription. Let's firstly understand the semantic versioning. A semantic versioning is a versioning scheme used to convey meaningful information about the changes in a software release. It follows a standard format of x.y.z. X stands for measure, Y stands for minor, and Z stands for patch, making it easier for developers and users to understand the scope and impact of updates. Major version represent breaking changes that are not backward compatible, incremented when old features are removed, major architectural or functional changes are made. Example, changing from 1.0.0 to 2.0.0. In this version, what we are doing a major change from version 1 to version 2. Okay, which means it is not backward compatible. Minor version represent the addition of new features that are backward compatible, incremented when new functionality is introduced, existing features are enhanced without breaking existing use case. Example, updating from version 1.1.0 to version 1.2.0. So what is the exact meaning? Here we have updated this minor from 1 to 2. So this is a minor version case and it is backward compatible. Patch version represents bug fixes, security patches, or minor improvements that do not add any new feature or introduce breaking changes. Incremented when a defect or issue is resolved, a small backward compatible changes are made. If you see, moving from version 1.1.1 to version 1.1.2, here we are doing changes on patch and it is bug fix only. So if you see any software, if it is mentioned 1.1.0, then you're good to say this first one is major version, the second one is minor version, and this 0 is for patching. If any software is moving from version 8.0.0 to version 9.0.0, then we are good to say it is a major version upgrade and it is not backward compatible. So this is a versioning scheme used to convey meaningful information about the changes in a software release. Why Terraform providers like Azure RM have so many versions? If you see in this diagram, The latest version is 4.14.0. Around 4 months back, what they have done, they have released a major version. Then they have done one patching. And from last 4 months, they are doing minor release. So why they are releasing so many versions of Azure RM? The Terraform providers like Azure RM have so many versions because they need to keep up with fast-paced evolution of cloud services, user requirements, and bug fixes. Example: suppose Azure introduces a new service like Azure OpenAI and Terraform user want to provision it using Terraform. A new version of Azure RM example 3.116.0 would be released to include support for this service. If a bug is found in the resource implementation, a patch version, I would say 3.116.1 will follow shortly. When Terraform core makes significant changes like a new SDK, the provider might release a new major version 4 to include the breaking changes. So what is the exact meaning of it? Let's take example. If we are using this version name as 3.115.0, okay? Then Azure has released a new service called Azure OpenAI. Okay, do you think this service will be included inside this version 3.11.5.0? The answer is no. So the Terraform is going to release a new version, and the new version, I would say, it has released 3.116.0. Okay, and this version will include the OpenAI. If you want to use OpenAI using Terraform, then you need to move your provider version from 3.115.0 to version 3.116.0. That's why if you see there are so many versions present for Azure RM providers. Why? Because Azure is, I would say, Azure is continuously adding some features or removing some features. So our providers should be our Azure RM provider should be updated to track all these Azure changes. That's why our Terraform Azure RM providers has so many versions. And it is not specific to Azure RM. If you see any version of Terraform, they would have n number of releases. This is one of the major reason of having n number of version of Terraform providers. Hello everyone. In this video, I'm going to continue my discussion for Terraform provider versioning. Best practices for setting provider versions in Terraform. During Terraform init, if version argument is not specified, the most recent provider will be downloaded during initialization. If you see in this diagram, what we have done, we have mentioned Azure RM provider, but we have not mentioned anything in version. So when we are going to run Terraform init, it is going to automatically download the Azure RM latest version. Okay. If you do not specify a provider versions in Terraform, it will use the latest available version, which can lead to unexpected behavior such as API changes or new features that may break your infrastructure. I would say today I have initiated a command and it has downloaded a latest version called 4.14.0. Okay. After 6 months, I'm going to run this code again and it is going to download a latest version called 5.14.0. Okay. Do you think our source code it would be 100% compatible with a new version? The answer is no. So in this case, if you're going to run your source code with new Azure RM provider version will get the error. To ensure stability, it is best practice to explicitly define the provider version using the required underscore providers block in your configuration. If you see in this example, what we have done, we have mentioned the version also in our Azure RM provider. So when we are going to run Terraform in it, it will download this 4. 2.14.0 version. If after 6 months also, if I'm running the same code, again the same time it is going to download this version. Okay, so let's do a quick demo to understand both these things in detail. I'm going to create a folder name called as demo1, and the second folder I would say demo2. In demo1, I'm going to create a file main.tf. In demo2 also, I'm going to create a file name called as main.tf. In this one, I'm going to copy the provider configuration from the official documentation. See, I'm going to click on use provider and will copy this. So in demo 1, what I'm going to do, I'm going to remove this version and then I will see the Terraform init behavior. And in demo 2, I will not remove this version. Then I will check the Terraform init behavior. Okay, let me copy the path. See, currently I'm in demo 1 folder. So I'm going to run Terraform init. In demo 2 also, I'm going to run Terraform init. If you see here, demo 1 initialization completed. The first message we are getting initializing the backend. We are going to have very detailed discussion regarding this one in our remote state management video. Okay, so we are good to ignore it. The second line it is mentioned initializing provider plugins. Then it is mentioned finding latest version of HashiCorp / Azure RM, and it has installed version 4.14.0. Okay. Why it is looking for the latest version? Because in Azure RM we have not mentioned anything related to version. That's why it is looking for the latest version. If we are going to run the same code after 6 months, again it would look for the latest version. Right now I would say it is version 4.14.0. Maybe after 6 months we are going to have version 5.14.0. Okay. If we want the provider versions to be consistent, what we have to do, we have to implement the demo 2 things. What we have mentioned in demo 2, in demo 2 we have mentioned version is equal to 4.14.0. So let's check in our Terraform init. If you see here, we have initiated Terraform init. This one we are good to ignore. And the first line which we are getting, finding HashiCorp Azure RM version matching to this condition, which is 4.14.0. Okay. And it has installed this version, which means in our .terraform folder we have downloaded this version. Okay, if we are going to run the same code after 6 months, it is not going to check for the latest version. After 6 months, again it is going to download the same Azure RM version. So this is the benefit of mentioning the provider version. Arguments for specifying provider. There are multiple ways for specifying the version of a provider. Okay, so what we have done in the last example, we have mentioned version is equal to 4.14.0. So when we initiated a Terraform init, it has downloaded this version inside our .terraform folder. But in real time scenario, we do have some other option also. The first option is if we are going to mention greater than equal to 3.0 version. So in this case, Terraform provider version, which is greater than 3.0, it would be downloaded inside our .terraform folder. If 6 is the latest version, 6 version will be downloaded. After 3 months, if you are going to run again, if new version is 7, then the 7 version is going to be downloaded. In second example, it is less than equal to 3.0 version. So when we are going to run Terraform init in .tf folder, any version, I would say the 3 version is available, the 3 version will be downloaded. Okay. If there is, if 3 version is not available, then any version which is lesser than 3 and is available as a provider, it will be downloaded. And the third one is tilt 2.0. Any version in 2.x range will be downloaded. So it will go maximum to 2.99.99, but it will not move to 3.0. Okay, in real time scenario, we generally mention this version configuration. And the fourth example is any version greater than or equal to 3.0 and less than equal to 3.100.0 will be downloaded. Okay, so let's do a quick demo to understand all these example in detail. The first thing I'm going to do, I'm going to create a dedicated folder for it, which is demo 3 in this one. And the file name I will mention main.tf, and then I will copy the provider configuration. Right now the version is 4.14.0, but what is our first example? Our first example is greater than equal to 3.0. So I'm going to paste this value. Let me copy the path and I will run Terraform init. If you see here, the Terraform initialization completed for our demo 3. We are good to ignore this one. The first line which we are getting, finding HashiCorp / Azure RM versions matching with this condition. The same condition which we have passed in our provider version. Obviously, it is going to download the latest version, and the latest version is version 4.14.0. In real time scenario, we are not going to mention this one because whenever we are going to run Terraform init, it will download the latest version. So what is the next option we have? Next option we have less than equal to 3.0 version. So in this case, firstly we'll try to download 3.0.0. Okay, if this version is not available, then it will look for the another version, but it would be less than this value. Again, the first command I'm going to run, terraform init. If you see here, we are getting an error reusing previous version of HashiCorp / Azure RM from the dependency log file, but the 4.14.0 does not match configured version constraint. The constraint value is less than equal to 3.0. Must use Terraform init -upgrade to allow selection of new version. So it is suggesting a command to run which is called Terraform init -upgrade. So till now what we have discussed, whenever we are going to run Terraform init command, we are going to have our .terraform folder. In the .terraform folder, our provider plugins will be downloaded, and then in the provider plugins are going to interact with our target API. Okay, this is the part we have discussed. But with .terraform folder, one more file will be created which is called as .terraform.log.scl. Okay, let me explore it. So in this file, the first thing is it is mentioned regarding our provider, which is Azure RM, then the version and the constraint. In the last example, what we have mentioned greater than equal to 3. That's why the constraint is greater than equal to 3. And which version it has downloaded? It has downloaded version 4.14.0. Okay. So what is our new requirement? We want to download Azure RM any version which is less than equal to 3.0.0. That's why we initiated a command called terraform init. Terraform firstly tried to use this version, but this version does not match with our new constraint. So we are getting an error. If you want to use a new version inside your provider, then what you have to do, you have to run a command called terraform init hyphen upgrade. when we are going to initiate this command terraform init hyphen upgrade, two of the things are going to be changed. The first thing, it would be our constraint is going to be changed. With greater than 3.0.0, it will move to less than is equal to 3.0.0 and the version number, and it is going to download new provider versions inside this .terraform folder. And then going forward, whenever we are going to run our Terraform plan or Terraform apply, whatever the version number mentioned in .terraform.log.scl, the Terraform plan and Terraform apply is going to use it. Okay. If we are going to change again the Terraform provider version, then again we need to run a command called terraform init hyphen upgrade. Then automatically our .terraform.log.scl file will be updated and the new provider version will be downloaded inside .terraform. So let's run the command. Okay, I'm going to run terraform init hyphen upgrade. There's one typo. I'll run terraform init hyphen upgrade. See, the initialization process has started. So Terraform initialization completed. The first thing which we are able to see, finding HashiCorp / Azure RM version matching to this condition and installing HashiCorp Azure RM version 3. So as I have mentioned, the two of the things are going to be changed. The first thing is our .terraform.log.scl. It has updated the constraint from greater than 3.0.02 less than is equal to 3.0.0. Okay. And with this condition, it has version 3. And the second thing which we have discussed, it is going to download this version inside our .terraform folder. Let me click on it. See, see, currently we are having version 3 and version 4. And whenever we are going to run Terraform plan apply, it is going to use version 3 to connect with our target API. Okay. And in future, if you want to use version 4, what we have to do? We have to update in Terraform provider version, and then again we need to run a command called terraform init hyphen upgrade. In this hyphen upgrade part, again our version will be updated and constrained, and it is going to use this one for all our Terraform plan and apply. Okay. So our third example is to use till 2.0. Let me copy this one and paste this one inside. So in this case, what we are going to see, it will only update the minor version or patching. It is not going to upgrade the major version, which means it will download any Terraform provider version within a range of 2 only. Okay, but it is not going to download any Terraform provider version from version 3. It will only download within a 2 range. If I'm going to mention here as 3, so any version which is within a range of 3 only, it is going to download. It is not going to download 4. This one is generally used in real time scenario. If you are going to mention this one, it is going to upgrade only my minor and patching. It is not going to upgrade my major versions. Okay, let me run terraform init hyphen upgrade to check the new provider version. That's it, terraform init hyphen. If you see here, Terraform init hyphen upgrade completed, and it has downloaded the version 2.99.0, but it has not moved to the major upgrade, which is version 3. Okay, this is a benefit of using till 2. See, in our .terraform folder, the new version is also downloaded. So when we are going to run Terraform plan or Terraform apply, so this version will be used to connect to our target API. Okay, let me quickly change this one 2 to 1 and let's see. See what I have done? I have changed the condition from 2 to 1. So the constraint is this one, and so the last version of 1 is 1.44.0, which means after 1.44 they move to version 2. Okay, that's why it has downloaded version 1.44.0. And let me check in .terraform folder. See, it has downloaded this one. Again, the same thing. Going forward, whenever we are going to run Terraform plan and apply, it is going to use this. And our last example is greater than 3.0.0 and less than 3.100.0. Okay, let me paste the value. Again, if I'm going to run Terraform init, we'll get the error. Let run. So let's run Terraform init hyphen upgrade. Again, the same thing will happen. Firstly, it is going to update our .terraform log.scl file, and then it is going to download the provider version in .terraform. Okay, see, finding hashing of Azure RM version matching greater than 3.0.0 and less than 3.100.0, and the version is 3.100.0. And see, and let's check in our .terraform folder. This version has been downloaded. Okay, so with this we have completed this. Hi everyone, in this video we are going to discuss about Terraform state file. So what is Terraform state file? Terraform state is essential for managing your infrastructure. It acts as a kind of database for your Terraform project configuration. When it is created, the terraform.tf state file is automatically created by Terraform when you run Terraform apply for the first time. It is stored in the same directory as your Terraform configuration files. Next time, if you run the Terraform apply, every subsequent Terraform apply will update this state file with the latest information about your infrastructure. So let's take example. We are working on project A and we have created a dedicated folder with a name called A. In this project, we are creating one resource group, the storage account, and the virtual machine. What is our end goal? Our end goal is to create the resources in Azure. So once we are going to run our Terraform apply command, two things are going to be happen. One, it would be like creation of the resource. Second thing, it would happen like our state file will be created. This state file is a kind of database. What is the exact meaning of database? It will has all the information about all the resources which we do have created in our Azure account. Next time, if we are going to update, I would say with in our storage account and virtual machine, if we miss to update the tags, and next run what we are doing, we are updating the tags in the storage account and virtual machine, and we are running a Terraform apply, it will be created, and parallelly our state file will also be updated. Okay, and when we are going to destroy all these resources, the resources will be destroyed and the state file will also be updated. So state file, I would say, it is a kind of database which is store the information about the project A, what are the resources we are creating, and the other configuration. We are going to have a very detailed discussion in the next video about the state file requirement in terms of current state and the desired state. Contents. It contains information about the resource managed by Terraform, including their attributes, dependencies, and metadata. As I do have mentioned, this state file will have all the information regarding our resource group, storage account, and virtual machine details. Storage. The state file can be stored locally or remotely, depending on the configuration. Common remote state backends include Amazon S3, Azure Blob Stores, HashiCorp Console. By default, where the state file is going to be stored, it would be stored in our local machine from where we are running our code. But apart from that, we do have other options. I would say remote state management option where we are good to store our state file in a remote storage. We do have a dedicated video to discuss about this one. Locking. Terraform state file support locking mechanism to prevent concurrent modification, ensuring only one user can apply changes at a time. Yeah. So by default, Terraform provides us the locking behavior. Right now, we are managing the things from our local machine, so it is not required. But in real-time scenario, when we are going to work in a team, at that time, the locking behaviors plays a very important role. I would say we have put our state file inside the Azure storage account, okay, and we are having a team A member and team B member. Both of them try to do the changes. If the Terraform is not going to support the locking behavior, the user A and user B is going to update the state file can be corrupted. So in that case, what Terraform is providing, if the user A has initiated the thing for his operation, the state file will be locked. And once his task completed, then the lock will be removed and then the user B is good to do the changes. Okay. With this, we do have completed the Terraform state file discussion. In the next video, we are going to do a quick demo about when the state file is going to be created, what would be the impact if we are going to do any changes, and the other configuration. We are going to do a quick demo on a state file. So what I have done till now, I have created two file name called as providers.tf for my provider configuration, and then I'm having a storage.tf. If you see in storage.tf, the first resource which I'm going to create, it is my resource group, and the second resource which I'm going to create, it is for my storage account. So what we are going to do, the first thing, we will apply the resource, means create the resource in Azure. Once this resource is created, we will check the status of the state file. Is it created or not? The second thing which I'm going to do, I'm going to update the things in terms of, I would say, tags in our RG, and we'll check the state file status. And the third thing which I'm going to do, I'm going to delete the resources, and then I will check what is the status of the RG. So we are going to do three cases: case 1, case 2, and case 3. Okay, so let me start the demo. So I'm going to run Terraform init. Then I'm going to run Terraform plan. Plan has generated a two of the resources is going to be created. One it would be my resource group and the second it would be my storage account. Still we are not having a state file. Let me run Terraform apply, and I'm going to type yes. So if you see here, two of the resources has been created. Let me quickly check inside the portal. The resource group name is example-resources 234. If you click on resource groups, see the resource group has been created and our storage account is also created. Parallelly, we do have one file name called terraform.tf state. Let me maximize it. So in this terraform.tf state, it has all the information regarding the Terraform version which we do have used. Is there any output blocks? We are going to discuss in our upcoming videos what is the output blocks. and detailed information regarding the resources. It has the subscription detail, then it is name of my resource group. The tags we have not updated, so that's why the value it is coming here as null. Okay, so we do have created our storage account also. See, it is mentioning Azure RM storage account with the other configuration details. Okay, so once, so for the first time when we are going to run Terraform apply, it will create the terraform.tf state. So the second thing what we are going to do, we are going to update our TF configuration and then see what it is going to happen. So right now in the tag it is mentioned as null. Okay, so what we are going to do, we are going to update the values in our Terraform configuration and see whether the state file is updated or not. So I'm going to mention here as tags is equal to environment and created underscore by is equal to, I will say, a comma. So I've saved this Terraform configuration and see Terraform apply. I'm going to mention. So the Terraform apply command has started. And if you see here at the right, we are having a file name called as .terraform.tfstate.log.information. In this file, we are having a metadata about the user who has initiated this request. And due to this file, our Terraform state file will be logged. And if any other user wants to do any changes on this resource, they would not be able to do it. Okay, they'll get an error. If you see here, what it is showing, it is showing like we need to do some changes. If I'm going to parallelly copy the path, and I'm going to run Terraform plan, see what we have done. We have initiated Terraform apply. Okay, and we have not passed the value here. So right now what the Terraform has done, it has created a file name called as .terraform.tfstate.log.information, and this is my user detail only. Okay, and parallelly what I have done, I have opened one more CMD, and in this CMD what I'm doing, I'm running Terraform plan command, and when I'm running the Terraform plan command, I'm getting an error acquiring the state log. So whenever any user is going to run a command called terraform apply, or I would say terraform plan, if the terraform.tf state is locked, then he will get this error. Okay, and this lock is coming from due to this one. This file has detailed information from the user end who has initiated it. So this is an overview about what is the purpose of .terraform.tf state.log file. So I'm going to type yes. So what we are doing, we are updating the resource group tags, and it has initiated the process, and our tags has been updated. I'm going to click on, let me refresh it. If you see here, the tag has been updated for our resource group, and parallelly let me check my state file also. The state file, see, initially it was coming null, but right now the tag has been updated. Terraform apply operation has been completed and we have made the changes. If you see, we are not able to see any file with a name called .terraform.tfstate log.information. It has been released. If I'm going to run Terraform plan again, I will not get the error. See, we are able to fetch the information. It is clearly mentioned no changes. Your infrastructure matches the configuration. Why? Because why we are able to do so? Because this task has been completed. If, as I do have mentioned, a command called terraform apply and it is in progress, and then from the parallel cmd if I'm going to open it, then I'm going to get this error. Okay, so what we have discussed till now, the first thing we discussed, like creating of resource group and storage account. Okay, this has been completed and it is a first time run. So our tf state file created. The second time what we have done, we have updated the tags. So once we update our tag, then the state file is also updated. The third thing which I'm going to do, the third thing I'm going to destroy the resource. So once we are going to destroy the resource, definitely it is going to delete the resource from our Azure subscription. And once it is deleted, it is going to update my Terraform state file also. Let me show it quickly to you. Again, we have initiated some command. You see the .terraform.tfstate.log file has been created and it will have all the details regarding the user who has initiated it. I'm going to type yes. What it is going to do? It is going to delete both of my resources. And once this resource is going to be deleted, what we are going to see? We are going to see the details about the Terraform state file. So meanwhile, we are good to discuss about this one also. As I do have mentioned, once the Terraform state file is created, it is going to create one more file with the extension of .backup. It will has all the details of terraform.tf state. But if any case, if Terraform state file is corrupted or any issue happen, in that case, we are good to update this backup file. We just need to remove .backup configuration from it. If you see here, both the resources has been destroyed. See, inside the Azure portal, we are not able to find any resource group with the name of example resources 234. Parallelly, let me check with the Terraform state file. The Terraform state file will also not have any details. Okay, because we have deleted the resource. I would say I'm having a project name called Terraform project. Okay, folder. And in this Terraform project folder, I'm going to create multiple project. I would say project A, project B, and project C. In each and every project, I would say project A, project B, and project C, I'm going to create n number of resources. Okay. So whenever I'm going to run Terraform init, plan, apply, whatever the things I would say .terraform log.scl, terraform.tf state, it will be created inside this folder only. The same thing it would happen for project B. If I'm going to run terraform init, plan and apply, whatever the add-on I would say file, it would be created inside this B folder. And the same thing it would happen for C folder also. Okay. So in each of the folder, we are going to have our dedicated state file, or I would say dedicated .terraform file, .terraform log.scl file. Okay. If inside this one, if this is the file folder which I do have created with a name called state file underscore demo, inside this one, if I'm going to create more folder called project underscore A, and inside this project A, I'm going to create a file name called as providers.tf and storage.tf, and I will copy this one. Okay, I'm going to run terraform init. So if you see in this case, what it is doing, it is creating a new folder called .terraform. It is not fetching the value from its parent folder state file demo. F1. Approve. So in the same way, we are going to have our dedicated TF state file present inside project A. It is not going to use the state file which is present inside the parent folder. Let's wait to complete it, then I will show you. If you see here, our resource group and the storage account has been created. Let me quickly refresh it and see the storage account and the resource group created. But the it is it has not used the terraform.tf state or .terraform folder or .terraform log.scl from the parent one. Instead of it, it has created a new folder for our .terraform, .terraform log.scl and .terraform.tf state. Let me show you inside the folder. If you see here, we are having I have opened a state file demo. Here we are having .terraform and .terraform log.scl, .tf state and .terraform.tf state.backup. While in this folder, I do have created one more folder called name as project underscore A. And in this project A, it has its own .terraform .logcl, .terraform log.scl and tf state. So what is the exact meaning of it? It means if you are going to create a folder name called as project folder underscore folder, and in this one, if you are going to have multiple folder A, B, and C, when when you're going to run Terraform init, plan, and apply, the dedicated file will be created inside this one. And inside this A, if I'm going to create one more folder, a child folder, I would say double A. And if you're going to run Terraform init, plan, and apply, it will not use this uh, Terraform file. It is going to create a new .terraform file or tf state or log.scl. With this, we do have completed. Hello everyone. In this video, I'm going to discuss about the desired state and the current state. So what is the exact meaning of desired state? Terraform primary function is to create, modify and destroy infrastructure resources to match the desired state described in the Terraform configuration. So whatever the things we do have mentioned in our .tf file, it is called as desired state. Okay. What are the operation we are good to do? Create, modify and destroy. So, what is the exact meaning of current state? Current state is the actual state of a resources that is currently deployed. So, what is the exact meaning of it? Whatever the resources we do have created inside portal.azure.com, it is called our current state. Important point. Terraform tries to ensure that the deployed infrastructure is based on the desired state. If there is a difference between the two, Terraform plan presents a description of the changes necessary to achieve the desired state. So as we do have discussed in the last two slides, desired state is the thing which we do have mentioned inside our .tf file, and the current state is the resources which are created inside our portal.azure.com. Cases for desired state and the current state. What would be the impact on plan and apply? Resource group creation initiated through Terraform. So what we have done in our Terraform configuration, we do have mentioned like, hey, one of the resource group is going to be created. So what would be the plan? One resource group creation it will show. On apply, one resource group will be created. While in the second case, resource group already created manually, then run Terraform with the same name and location. So what is the exact meaning of it? Like we do have created the resource group inside portal.azure.com using manual approach, I would say, or PowerShell approach or ARM template. So what will be the impact on plan? One RG creation. Apply. At apply time, it will give us the error. Why? Because the resource group is already present inside our portal.azure.com. In the third case, resource group created through Terraform and a tag manually added from the Azure portal. What we have done, we have created a resource group using Terraform and we have added a tag manually from the Azure portal. So in the plan, it is asking to null the tag's value as it is not mentioned in the desired state. While apply, it will remove whatever the things we do have mentioned. It means whatever the tag we do have added, through manual approach, it will be removed, and then the desired state and the current state will be matched. Resource group created through Terraform and then deleted from the Azure portal. So in this case, what we have done, we have created a resource group through Terraform and deleted from the Azure portal. So in the next time, whenever I'm going to run a Terraform plan, it will asking us to create a new RG, means whatever the RG has been deleted, and the new RG will be created. So in the next video, I'm going to do a quick demo on all these 4 test cases. Okay. Hi everyone, in this video we are going to do a quick demo on the cases which we have discussed in the last video. So the first case is we are going to create one resource group and we are going to implement the plan and the apply and see what is going to happen inside our portal.azure.com. Okay, so let's start. So what I have done, I have created a one file name called as main.tf and parallelly a providers.tf. This main.tf is responsible to create a resource group name as example in the location called West Europe. Let me copy the path, Terraform init. Initialization completed. I will run Terraform plan and then Terraform apply hyphen auto approve to save the time. As mentioned, this plan is basically responsible to create the resource group name as example in the location called West Europe. If you see here, our resource group has been created successfully. Let me quickly check inside our portal.azure.com. So what is the name of the resource group? The name is example. So this is the resource group which has been created in the location, I would say, West Europe. So that case 1 has been completed. So what is the case 2 we do have discussed? In the case 2, what we are going to do, we are going to create one resource group using manual approach. It can be anything, I would say PowerShell, or I would say using ARM template, or using Terraform also, but in a different folder, like in a different state file. Terraform using a different state file. Okay. And then once this first part completed, what we are going to do, we are going to write a resource group creation task using Terraform, and then we will run plan and apply to check what are the configuration we are going to have in the plan stage and the apply stage. So let's check the case 2 condition. If you see main.tf, what we do have mentioned, the resource group name is example-resources. I will create it. I'll mention example-resources, and the location I'm going to mention is West Europe. And I'm directly going to mention review and create. So our resource group has been created example-resources, and it has been created manually. So what is the second stage which we are going to do? I'm going to copy the path. I'm going to run Terraform init. The next step, it is all about Terraform plan. If you see here in the Terraform plan, what is showing, it is going to create one RG for you. What are the challenges we are going to have in Terraform apply? Because this resource group is already present inside the portal.azure.com. You see here, we are getting an error. So what is the exact meaning of this error? This a resource with ID, which is mentioned here, example hyphen resource already exists. To be managed by Terraform, this resource need to be imported into this state. Please see the resource documentation for Azure RM underscore resource underscore group. Regarding this import command, we are going to discuss in detail in our upcoming videos. But what is the main challenge we are seeing right now? The resource group name as example hyphen resources is already present inside the portal. And again, we are trying to create the same resource group using Terraform. We are getting an error. In terms of plan, it was okay. Okay. But when we implemented Terraform apply, at that time we are getting an error. So what is the exact meaning of it? If the resource is already present or created inside portal.azure.com, and when we are going to run Terraform init plan and apply, at the plan time we are going to get the error. Okay. So let's discuss the third use case. So in the third use case, what we do have discussed, we have created the RG, okay? And in this RG, we have not added any tag. And this thing was created using Terraform, okay? So the next thing what we are going to do, manually, we are going to update the tag here. And then we are going to run Terraform plan and apply to check whether it is matching to the desired state or not, okay? So let's do it. Here we do have the resource group name as case-3 and the location is West Europe. Let me copy the path. I have initiated a command called Terraform init and then Terraform plan. If you see here, it is showing what? To create a resource group name as case-3 and the location is West Europe. Let me run Terraform apply hyphen auto hyphen approve. Okay, there's one typo. If you see here, our resource group has been created successfully. Let me quickly check inside the portal and our resource group name called case-3 has been created. But in this code, we haven't mentioned anything related to tags. So what we are going to do, I'm going to manually update the tags. I would say environment name as dev created underscore by, I would say A Kumar and let me save it. Okay, our tag has been updated. So what would be the next step? The next step it would be I'm going to run again the Terraform plan to check it. If you see here, we are getting a message. What? To move this created underscore pi is equal to A Kumar value to null, environment is equal to dev to null. Why it is happening? Because in our desired state, we have not mentioned anything regarding the tags. While in the current state, we have updated the tag using a manual approach. So in the last video, what we have discussed, at any time desired state is going to get a preference in comparison to the current state and it should be always equal to the current state. So to match the desired state and the current state, it is asking to remove all the tags whatever we do have updated manually. Okay. So let me run Terraform apply here and see what is going to happen. If you see here, one of the things has been changed, which is our tags. And let me quickly refresh and see is it the tags are still present or not. Let me refresh from the top and see. The tags are not present. It has been deleted. Okay. So what is the exact meaning of it? So desired state should match to the current state. If in the current state we are going to do any changes in the next run of Terraform plan or apply, it is going to undo it. Whatever the things we do have mentioned in our desired state. What I'm going to do, I'm going to update the tags here. If you see here what is showing, it is showing to two of the tags are going to be updated, which is created by and the environment. See, it has been completed. Let me quickly check inside the portal.azure.com. Let me refresh from the top and see the two of the tags has been updated, created by and the environment. Okay. So what is the exact meaning of it? At any time, desired state should is equal to the current state. If we are going to do any changes, I would say in current state, in in the next run of Terraform plan and apply, it will be equal to the desired state. If we are going to do any changes in desired state, so in the Terraform plan and apply, it will try to implement it. Okay. If I'm going to delete both the tags and save, so in the next run, I'm implemented Terraform apply hyphen auto hyphen approve. So in the desired state, we do have mentioned A Kumar created by is equal to A Kumar and environment is equal to dev, and we have deleted both the tags. So in the next run, what it is going to do, it will update both the tags. Okay, let me refresh it and show to you. See, both the tags has been updated. So what we do have discussed in case number 4. In case number 4, we are going to create this name resource group name called as case hyphen 4, and I'm going to delete this one from the portal.azure.com. Then I'm going to run Terraform plan, Terraform apply. Okay, let me run Terraform apply hyphen auto hyphen approve. So it is going to create a resource group name as case hyphen 4 in a location West Europe. So our resource group has been created. Let me quickly check inside the portal. Let me refresh it. If you see here, the case hyphen 4 has been created. So what we are going to do, we are going to delete this resource group. So resource group case hyphen 4 has been deleted. So what we are going to do, I'm going to run Terraform apply. So in this case, what it is going to happen, we do have our desired state, which you do have mentioned, and then what we are having our current state. In desired state, we have created, I would say, case hyphen 4 resource group, and in the current state, which is inside our portal.azure.com, we have deleted this one. So when we are going to run the next Terraform plan or apply, it will check whatever the things we are having inside our terraform.tf state, is it matching or not. So currently it is not matching, the desired state is not matching to the current state, so it will ask like, hey, we need to create this resource group. So that's why it is showing here we need to add one rg. Let me type yes. So our resource group again has been created inside our resource group. Okay. So with this, we have completed all the 4 cases which we do have discussed in the last video for the current state and the desired state. Everyone, in this video, we are going to do a quick demo on output values. Understanding output values. Terraform has capability to output the attribute of a resource with the output values. Let's take example. We want a public IP address as an output when we create a public IP. So what is the exact meaning of it? So we have written a resource and the main task of this resource is to create a public IP. So once this public IP is created, we want to check the public IP address. To check the public IP address, we need to log in inside the Azure. Instead of login inside the Azure, we want a public IP address on our terminal. Okay, if we want the IP address on our terminal, what we have to do at the end, we have to mention the output block, the name of the output block, and we're good to take anything. Then we have to mention value is equal to, then the resource name, then the resource local name, and what we want an IP address. If we are not going to mention the IP address and then you are going to mention the value, so what it is going to have, it will have all the attributes which public IP is having. Okay. Second thing, an output attribute can not only be used for the reference, but it also act as an input to other module being created by Terraform. So we haven't discussed about the Terraform module. We are going to have very detailed discussion in our upcoming videos, but let's take an example to understand it. We have created a storage account module. Okay. A storage account module. Okay. And then one more module named as function app. Okay. In this function app, we need to use the name of storage account. If you are going to use output block in this storage module and just mention the name, then you would be able to use the storage account name module inside the function app. Otherwise, it would not be possible. Regarding this one, we are going to have a detailed discussion in our upcoming video, but this is one more functionality. That's why we need to use output block while creating our module. So let's do a quick demo to understand this thing in detail. So in this demo, we are going to create a public IP. And once this public IP is created, to fetch the address on terminal, what we are going to do, we are going to use output block. Okay. So let's firstly create our two file name called as providers.tf and main.tf. So I'm going to click on use provider. And here I'm going to mention, as we do have discussed, we need to mention features block. And then currently we are using, I would say, the version 4. So we need to use subscription ID also. To fetch the subscription ID, I mentioned my subscription. I have mentioned my subscription ID, and here I do have mentioned what we need to create. We need to create public IP. Official documentation for Azure RM public IP. So this is my official documentation for Azure RM public IP. I'm going to copy it, and here I do have mentioned. I'll mention output hyphen demo hyphen RG. If you see here, first resource is basically responsible for creating my resource group, and the second one is basically responsible for creating my public IP. So what I'm going to do, I'm going to run a Terraform command to create the resources. Okay. I have initiated a command called Terraform init. I'm going to run a command called Terraform apply. See here, two of the resources has been created. If I check inside the portal, the resource group name is output-demo-rg, and here we are having our public IP created. But what we want on terminal, we want a public IP address. So if you want now, what we have to do, we have to select the public IP and then need to check the IP address. But we want these things in terminal. So what we have discussed, we need to mention output block, and I would say IP and underscore address. We are good to mention anything, and then we need to mention value is equal to my resource name, or I'll say global name dot local name is example. Okay, as we do have discussed, the output block is generally responsible to output all the arguments. So what is the exact meaning of arguments? Let me show you inside the official documentation. If you see here, all these values are called argument, like name, resource group name, location, and the other values. Apart from arguments, we do have attribute reference. As it is mentioned, in addition to the argument listed above, the following attributes are exported. It would be ID and IP address. So the output block is responsible to put the arguments plus attribute reference on our terminal. If we are going to mention the resource underscore name dot local underscore name, in this case, what we are going to have, it will list all the arguments and attribute reference on our terminal. If you want to narrow it down, what we have to mention after the local name, we have to mention the attribute or argument. If I'm going to mention resource name dot local name dot IP address, it will show the value of the IP address. Let me show you in Visual Studio Code. If you see here, what I have done till now, I have mentioned the resource name and the local name. Okay, so let me run Terraform apply to show the output. If you see here, we are able to see all the arguments and attribute reference. Okay. If you want to see any specific attribute or argument reference, what we need to mention, I would say I need IP underscore address. I'll mention this one and let me run quickly. Let me run Terraform auto hyphen approve. If you see here, we are only having IP address. If you want one more value, then what we have to do, we have to mention one more time this output block, and this time what would be the attributes I want name. Okay, so I'm going to mention at the end name, and this one I'll mention name underscore public IP. I will run it again. If you see here, we are able to see both the values, the IP address and name underscore PIP. So we do have one more option. What is the exact option? Rather than mentioning the output block two times, we are good to mention the output block single time only. Output, I would say IP underscore values. And here I'm going to mention value is equal to, I'm going to create a map. The key it would be my IP address is equal to, and the name of the public IP I'm going to mention here. If you see here what we have done, we have mentioned the output block, and the name of the output block we have mentioned IP underscore values. Then we have created a map. In the left hand side we have mentioned the name of the value which we want to fetch, and the right hand side we have mentioned about name, global name, and the local name, and the specific argument. Okay, there's one typo, let me fix it. Let's run it again. If you see here, We are able to see the IP address and the name of the public IP. And here we have created a single output block. We do have mentioned the IP address and the name of the public IP. In real time scenario, when we want a multiple values in output block, we don't need to follow this approach. Instead of it, we need to follow this one where we are good to pass n number of argument or reference. Okay. So hi everyone, in this video, we are going to discuss about the Terraform variables. So firstly, we need to understand the challenge. Repeated static values in the code can create more work in the future. So in the last demo, what we have done, we have created two resources. The one, it is our resource group, and the second one is our public IP address. If you see here, in terms of name, we have done the hard coding of the value. In terms of location, we have still done the hard coding value. And in the location also, the name of the public IP is hard coded and the tags. So the better solution would be to define repeated static value using variable. So what is the meaning of variable? If you see here in this code, we have implemented the same thing. The first one is our resource group, one is public IP. But what we have done, we have not done any kind of hard coding here. In terms of name, we have used variable. In terms of location also, in terms of the name of the public IP. So let's discuss how we are good to define the variable. So the first keyword to define any variable is variable, which we have to define. Then the second one is the variable name. It is recommended whatever the key we are having, the variable name should be same. So we are good to compare it or to good to understand it, what it is all about. And the description is optional in variable. It generally provide a metadata. What do you mean by the metadata? Sometimes we are not able to find a clear idea about the variable. So we can go through the description and get the detailed information. And the default value is the place where we are going to pass our value. We are going to discuss in next video what are the various options we have to pass the values. But for now, we are passing the values using a default. If you see here, this one we have created and calling this value, what we have done, the first one is our variable and second one is our the variable name. So we have mentioned var.rg underscore name. So whenever we are going to run Terraform plan, automatically whatever the default value is present output underscore demo, it will be mentioned here. I would say output underscore demo. In the case of location also, we have done the same thing. We have mentioned a keyword called as variable, and then we have mentioned the variable name as location. And here we have a detailed description, I would say, the location where all the resources will be created. We have mentioned the default value as East US. So when we are going to run here, the value it would become East US. And in the case of the IP name also, we have done the same thing. We have mentioned the variable and the variable name is IP underscore name. We have mentioned description, the public IP name, it is optional one, but to use it for the metadata purpose. And here we have passed the virtual machine IP of the IP name. And here again, the value it would be virtual machine IP whenever we are going to run Terraform plan. So what are the benefits of variables? The first benefit is update important values in one central place instead of searching and replacing them throughout your code, saving time and potential mistake. What is the exact meaning of it? In the first approach, what we have done while creating the resources, we have passed the values. Okay. And in the second approach, what we have done while creating the resource, we have created the variables, and in the variables, we have passed the value. In future, if I want to change my IP name from BMIP to, I would say, test IP, what we need to do, we only need to update the default values and good to run the Terraform and the value will be updated for us. No need to touch the core Terraform configuration file. This can avoid human mistake while editing. So what is the meaning of core Terraform configuration?
I would say whatever we are having our resource block. So what we have to do, we have to only change the value in our variable. So in real time scenario, what we have to do, we do not need to create our resource and variables in a single file. We have to create a multiple file. The way I do have mentioned main.tf, it would be for our resources. Whatever the resources we are going to create, it would be mentioned inside the main.tf, and whatever the variables we are creating, we are good to mention in variables.tf. So in future, whenever we need to do any kind of changes, what we will do, we will update the values for it. Okay, let's do a quick demo to understand all this topic in detail, called variables underscore demo. And I will mention main.tf where all the resources will be created, and then good to mention providers.tf. So in the last demo, what we have done, we have created the public IP. So let me open the official documentation, and I will mention it as public underscore IP. Let me copy it and will mention the provider details from our documentation. So what we have to do, we have to create firstly variable, and the variable name, it would be good to mention it as rg underscore name. Then we are going to mention the description, the resource group name. I would mention the resource group name as public IP underscore RG. And again, to call this value, what we have to do, we have to mention it here as var dot rg underscore name. So whenever we are going to run our variable name, and automatically the value will come as pip underscore rg. Let me do it quickly for our other values also. So I'll mention it here as, let me copy paste to save our time, variable. I'll mention here at location, and I will mention here it as East US. Let me provide a detailed description. All the resources created. Again, I need to mention the same thing. Var is a keyword which we have to mention. Then our variable name, and automatically the same thing it would happen when we are going to run the Terraform plan. It will update the value as East US. I'll mention the name as public IP underscore name, the public IP name, and I will mention it as VM underscore IP. Okay. And again, what we have to do, we are good to mention it as PIP underscore name. So we have created our, I would say, the variable. As discussed, the best practice is to create a dedicated file name. We are good to mention any other file name, but it is recommended to mention it as variables.tf so we can easily understand like what are the values we are going to update in this file. I'll update it here. Let me copy the path. So the first command, I'm going to run terraform init. Then let me quickly do the Terraform plan. So if you see here, in terms of resource group name, what we are saying, public IP underscore RG. So from where we are fetching this value, we are fetching this value var.rg underscore name, and we have passed the value pip underscore rg. If I'm going to mention it here as pip underscore rg1, and let's run the Terraform plan again. What would happen? Let's see. See, our resource group name has been updated from pip underscore rg to pip underscore rg1. Let me do quick Terraform apply hyphen auto hyphen approve. And the public IP name is VM underscore IP. Change the value from VM underscore IP to demo underscore IP rather than going in main.tf or any other file. As the name we have mentioned of our TF file variables.tf, we only need to update this value. There's one typo. We only need to update this value. Let me run Terraform apply auto approve. What it will do, it will destroy the resources and it will recreate with a demo underscore IP. Okay, and if you want to update, I would say our output block. So let me quickly do it for our public IP address. So what we are going to do, we are going to mention Azure RM public IP dot example dot IP underscore address. And as discussed, it is always recommended to create a dedicated file outputs.tf, and I will mention it here. Okay, and let me run it again. In the terminal, we will get our IP address, the public IP. And let me parallelly check like what is the name of our public IP. Is it VM underscore IP it is showing? Let me refresh it. So it has been updated to demo underscore IP. And here we are able to see our public IP. Hi everyone, in this video we are going to discuss about the variable assignment approaches. So, variables in Terraform can be assigned values in multiple ways. So what is the exact meaning of the variable assignment approaches? In the last video, we have a very detailed discussion regarding the variable implementation. What we have done, we have created one resource group, and the other one which we do have created is a public IP. And we have created a two variable for our resource group name and the location, and the third variable for our IP name. If you see here, in each of the variable, we have passed the default value. Whenever we are running Terraform plan, automatically the default values are coming out. Apart from this, there are multiple ways to pass the values to a variable. So one is, which we do have discussed, variable defaults. The another one is input from user. What is the exact meaning of input from user? If I'm going to remove this default value and I'm going to run Terraform plan, so automatically at the runtime, it will ask me to pass the values of resource group name, and the location value will come from the default. Okay, command line flags. So whenever we are going to run our Terraform plan, we do have one option by using -var to pass the value of resource group name and the location, and it will overwrite the value of default. So we do have an options to create a dedicated file name called terraform.tfvars file, and whatever the variable value we are having, we are good to update inside the terraform.tfvars, and whenever we are going to run Terraform plan, automatically the value will be fetched from the terraform.tfvars. And the last option which we do have using environment variables. So what is the meaning of this approach? In this approach, we are going to create an environment variable. So let's take an example. We are going to create an environment variable name called rg underscore name. Whenever we are going to save the environment variables, we have to append a value called tf underscore var and then the variable I would say variable name. So in this case, we are good to pass rg underscore name. If we are creating a environment variable for location, we will pass tf underscore for underscore location, or the same approach we are going to do it for IP name also. So these are the options we do have to pass the value for a variable. In the upcoming videos, we are going to discuss in detail about each and every options. Hi everyone, in this video we are going to discuss about the input from the command prompt. Okay, so let me firstly create a dedicated folder for it. I would mention input underscore cmd, and I'm going to create a two file name as main.tf and providers.tf. And here I'm going to copy paste the main.tf configuration and the providers.tf. Okay, so in this example, what we have done, we do have our resource group name. We have created a two variable group. Let me mention the default value. I would say east US. I have mentioned the default value east US, and the for the resource group name, I haven't mentioned anything. I'm going to run Terraform init. So what we have to do at the runtime, I'm going to run Terraform plan. Then I have to mention where as an argument. And what is our variable name? The variable name is rg underscore name is equal to, I would say, this underscore rg1, and I will mention it as hyphen out to mention it as test plan. So if you see here, what we have done, we have mentioned our command name called Terraform plan. Then we are having one argument called hyphen var is equal to what is the variable name rg underscore name we have passed, and what is the value of it is underscore rg1, and the whole value is getting output into test plan. Let me press on enter. If you see here, what has happened, the value which we have passed for test underscore rg1, it is coming here, and the default value which we do have passed for the location, it is coming out using HTS. If we are going to mention, I would say default value of the resource group name as test underscore rg, let us run the same command and see what is going to happen. So here in this case, what has happened? We have mentioned the default values test underscore rg and ESTS, but at the runtime we have passed the value name called test underscore rg1, so it has been updated. It means at the runtime, if we are going to pass the value, it will have the highest priority in comparison to the default value. Okay. If I'm not going to mention anything at the runtime, so the value will come the default one. See, in this case, we are having the same default value which we do have passed. Okay. So this is one of the way to pass the value to a variable. Okay. If we want to pass multiple values, so what is the exact meaning of multiple value? Till now, what we have done, we have passed only one value for a variable. It is like rg underscore name. If we want to pass the value for rg underscore name and the location, so what would be the syntax? Let me update here. It would be the same thing. Again, what we have to do, we have to mention hyphen var
is equal to, then inverted comma, and inside the inverted comma we have to mention location is equal to, I would say, waste US, and I'm going to press enter. What we have done in this command, we have mentioned Terraform plan as usual, and we do have mentioned hyphen var two time, hyphen var here, and we have mentioned the variable name rg underscore name here also, and the location, and we have passed the value for our variable, and the whole configuration is saved into test plan, and we are good to run test apply test plan. Then the configuration, I would say the resource group will be created. Let me do it quickly for you. So a resource group has been created. So in the next video, we are going to discuss about passing the value of a variable using an environment variable. So thanks a lot for everyone. In this video, I'm going to implement input from user demo. Let me firstly create a dedicated folder for it. Input underscore user demo. And I'm going to create a file name called main.tf. And the second file, it would be providers.tf. So in the main.tf, I'm going to create a resource group. Let me quickly look into the Azure RM provider documentation, copy the provider part. Then I'm going to copy the resource group. So I'm going to create a two variable name. It would be like, rg underscore name. And the second variable, it would be rg, or I would say location only. And to call this value, I will mention var dot location. In the first place, I'm going to mention var dot rg underscore name. And let me update the default value. It would be rg, and the default value, it would be east US. And copy the path and open a CMD terminal. So what we have done, we have created a variable for our rg name and the location, and we have created a dedicated file name called providers.tf for our provider configuration. I would mention here Terraform init to initialize. Okay, and I'm going to run Terraform plan. So in Terraform plan, if you see, we have passed the value test underscore rg, and the location, it is east US. So we are able to see both the values has been updated. So what would be the next plan? The next, it would be, I'm going to remove this one, the resource group name, from default value and from location also. So if you see here, it is asking us to pass the value, the location. I will pass the location as East US, and then it is then it is asking for resource group name, because we haven't passed any default value for our resource group. Let me update the value. I would say check underscore rg. As we have passed the value, both the thing has been updated, the location and the name. Okay, if you see here, there is one note is present. You did not use the hyphen out option to save this plan, so Terraform cannot guarantee to take exactly this action if you run Terraform apply now. So what is the meaning of it? Let me run Terraform apply. If you see in this Terraform apply, again it is asking for the location and the resource group name. So what would be the best approach? The best approach it would be whenever we are going to run our Terraform plan, we need to in Terraform plan, we need to mention hyphen out option and with the plan name. If I would mention it as test plan. We are good to mention anything, whatever we wish. Like if you are working in dev environment, you'll mention dev plan. If you are working in for production environment, you're good to mention in the production plan. And the next time when we are going to run Terraform apply, it won't ask us to pass the value again. Whatever the values we have passed while running the Terraform plan, automatically it will be saved inside the test plan. And while running the Terraform apply, it will fetch the value from the test plan option. Let me do it quickly for you. Terraform plan hyphen out. I will say test plan. It will ask for the location. I will mention it as East US and I will say check underscore RG. If you see here, we are not getting any note here option. We are getting an option to run Terraform apply test plan to get the value. Let me run it quickly. See, it has created the resource group in the EastUS location and the resource group name is check underscore RG. And at the runtime, which means while running a Terraform apply, it hasn't asked for any values because all the values was fetched from the Terraform plan output name called test plan. Okay. Thanks a lot for watching everyone. In this video, we are going to discuss about the input from the environment variable. Let me create a dedicated folder for it. Okay. Again, I'm going to do the same thing. I'll create a main.tf and providers.tf. What we are going to do? We are going to copy paste the thing from our last. So in this example, if you see, we are going to do the same thing. We are going to create one resource group. We have mentioned the name of resource group name as test underscore RG and the location as EastUS. Instead of passing the value as default, we want to set up the environment variable for this variable name as location. What we have to do? We have to search for the environment variable. Okay. Then we need to click on environment variables. Then we need to click on new. What would be the variable name we have to mention? To create any environment variable, the first thing which we have to mention tf underscore var underscore our variable name. So our variable name is location. So we'll mention it as location. And here we need to mention the value. I will mention the value as waste US. And I'm going to click on OK. OK. Again, click on OK. I'm going to copy the path. Okay. And then I'm going to go in this. Then I'm going to redirect to this folder. We'll do the Terraform in it. So in this example, we have only passed the default value of RG underscore name and the location we haven't passed it. If we are going to run the Terraform plan, let's see, is it going to ask us to pass the value for location or it is going to fetch the value from the environment variable. If you see here, we have only passed the RG underscore name, which is test underscore RG. The value is getting fetched from the default one and it is updated here. While in the case of location, we haven't passed anything. What is the exact meaning of it? We haven't passed any default value. And at the runtime also Terraform plan, it is not asking for the value, the first thing. And the second thing, we haven't passed the value using a hyphen var option. Okay. Still the value is coming as waste year. So from where it is able to fetch the value? Again, let's have a quick look inside our environment variable, which we mentioned.
See, in the environment variable, I mentioned east US. Let me edit it to, sorry, in the environment variable, we have mentioned west US. Let me update it to east US. Click on OK. Okay. If I'm going to run it again, let's see what is going to happen. The environment variable as east US, but the value which we are getting as west US. So whenever we are updating anything in our environment variable, we have to open a new tab to reflect the changes. So I'm going to open on a new tab, and again I will copy the path. I'm going to run Terraform plan. Let's see. Here we are, which value we are getting? We are getting a value of east US because it is taking the updated value I mentioned in our environment variables. If we are going to click again on this terminal, the Terraform plan, it will come the west US only. So whenever we are doing any changes in our environment variable, we have to open a new tab. Okay, see, it is getting a value of west US. Okay, so in the next video, we are going to discuss about the terraform.tf pass. Hi everyone, in this video, we are going to discuss the variable definition file tf So firstly, we need to understanding the challenge. Managing variable in production environment is one of the very important aspect to keep code clean and reusable. So what is the meaning of it? Right now, what we are creating our resource group. Okay. And in this one, we are having, I would say, a location variable. We are having rg underscore name variable. Okay, but in real time scenario, we are going to create n number of resources in a single code. It would be like key vault creation also. It would be like regarding virtual machine creation also, storage account creation also. So if you are going to create all the four resource in a single go, you can imagine how many variables we need to create and parallelly how many values we need to pass. To overcome this kind of issue, what Terraform is recommending us to create a separate file with a name of start.tf was to define all variable value in project. So let's have a quick look what we have discussed till now. We have created main.tf file in which we have created the resources. Okay, all the resource will be created inside main.tf file. We have created a file name called variables.tf. In the variables.tf, we are going to declare all the variable. Okay, then we do have one dedicated file name called providers.tf that define all the providers. I would say in this providers.tf, we are defining a value for Azure RM, random, and Helm provider. In the same way, we are good to define terraform.tf vars file that define value to all the variables. What is the exact meaning of it? In variables.tf, we are going to declare the variable, and in terraform.tf var, we are going to define the value for variable. Here, we haven't mentioned any value for rg underscore name. Here, we are defining the value for our variable. In the same way, for location, for our mi name, here we have defined the values for our variable. Selecting TF bars file. Organization can have wide set of environment, dev, stage, and prod. Yeah, exactly. In any of the real-time scenario, we are going to have a multiple environment like dev, staging, and production. If you have multiple variable definitions file like .tf file, you can manually define the file to use during command line. So what is the exact meaning of it? I do have mentioned we are having a different environment, dev, stage, and prod. We are going to one-to-one mapping between the dev, stage, and prod with name called, I would say, dev.tf. In the same way, we are going to have stage.tf and we are going to have prod.tf bars. So in dev.tfvars, whatever the variable value which is related to dev environment, we are going to pass. For a stage environment, we are going to pass the stage related value for a variable, and the same way we are going to do for the prod.tfvars. So whenever we are going to run our Terraform plan, we have to use the hyphen var with hyphen file option, and then we have to mention our tfvars name. So whatever the output we are going to have here, it would be related to prod.tfvar. The same way we are good to replicate for our dev environment and for our staging environment. If file name is terraform.tfvars, Terraform will automatically load values from it. If file name is different like prod.tfvars, you have to define the file during plan and apply operation. So here what we have done, we have mentioned our tfvars file name as terraform.tfvar. So in this case, when we are going to run Terraform plan, we do not need to mention this var hyphen file. Automatically, whatever the value we do have mentioned in terraform.tfvars, the plan will be created. While in the case of having prod.tfvars, dev.tfvars, or stage.tfvars, whenever we are going to run Terraform plan, we have to mention our variable file name. Let's do a quick demo to understand these things in detail. I'm going to create one dedicated folder name as input underscore tfvars. In this one, I'm going to create a two file quickly, main.tf and providers.tf. Okay, and let me copy the file from our last demo. I'm going to create the copy for our providers.tf. So we are having main.tf and we are having providers.tf. I'm going to remove the value. I'm going to remove the default value. And let me remove it and create a, and let me quickly create a dedicated file for our variables also. Call name variables.tf. Okay. So what we are going to do, we are going to create a dedicated folder name as terraform.tfvars, and in this one, what is our rg underscore name is our variable name. I'm going to pass variable name as tf underscore var underscore rg, and the same thing I'm going to do for the location is equal to a file name called main.tf where I have defined the resource block, then providers.tf where I'm going to where in providers.tf I have mentioned all the provider detail, then I'm having variables.tf. I have mentioned here all the variable which we do have declared, and parallelly in terraform.tf vars file I have mentioned the value for our variable. Let me quickly do our Terraform init and plan. Let's see from where it is able to fetch the values. I've initiated I have initiated the command called Terraform init. Then I'm going to run Terraform plan. Let's see from where it is going to fetch the value for RG name and the location. So whatever the value we do have mentioned in our tfvars file, terraform.tfvars file, it is able to fetch it. The location is east US. So here we are having east US. The location is tfvars underscore RG. The value is tf underscore RG. Okay. And let me quickly update the default value also. And let me run the Terraform plan. If you see here, I have mentioned the default value for our RG name as default underscore RG. Still, it is fetching the value from TF vars file only. So it means terraform.tf vars has high priority in comparison to the default value. Okay. Real time scenario, what we are going to have dev environment, we are going to have the staging environment, and we are going to have the production environment. And in this case, we are going to have a dedicated TF file, one for stage dev, one for, I would say, for our staging, and the same it would be for our production environment. So let me quickly create a file name called dev.tfvars and let's run the Terraform plan. I'm going to rename this file name with a name called, I would say, dev.tfvars, and I will mention here RG name as dev underscore RG, and I will quickly remove the default value and let's see what is going to happen. So it is asking me to pass the value for our resource group name. It is not able to fetch the value from the dev.tf file, dev.tf, the way it was able to do so for our terraform.tf file. So in this case, at the runtime, we have to mention our dev.tf file. So what would be the syntax? As we do have discussed, it would be terraform plan hyphen var hyphen file is equal to dev.tf and I would say hyphen out to dev plan. So if you see, we do have mentioned our resource group name dev underscore rg. The same value is reflecting here. In the same way, we do have mentioned the location as east US. The value is coming as east US. So file is present. We do not need to mention anything while running our Terraform plan. But if we are having a tf file with a different name, so at the runtime, we have to mention the tf file. So in the next video, we are going to discuss about the precedence of the variable declaration. Hi everyone, in this video, we are going to discuss about the variable precedence. When variables are declared in your configuration, they can be set in number of ways. We have discussed we are good to pass the value of a variable using default option. With the next option which we do have discussed using a tfvars file, it can be your terraform tfvars file or according to our environment dev prod or staging one. And the third one which we do have discussed using an environment variables, like what we were doing, whatever the variable name we are having, initially we are updating tf underscore var and then our variable name. Okay. And setting variable in command line. In setting variable command lines, what does it mean? Like at the runtime, whenever we were doing our Terraform plan or Terraform apply, what we were doing, we were passing the values using a option called hyphen var with the variable name and its value. So these are the options which we do have discussed in detail to pass the value for a variable. So Terraform loads variables in the following order, with later source taking precedence over earlier ones. So the first one is environment variables. The second one is terraform.tfvars file if present. The third one is terraform.tfvars.json file if present. And the fourth one is star.auto.tfvars or star.auto.tfvars.json file precedence in lexical order of their file name. And the fifth one is any hyphen var and hyphen var hyphen file options on the command line. So we do have very detailed discussion about all the possible way to pass the values to a variable. So in terms of precedence, the fifth option will have the highest precedence. So it will be like this to from low to high. So if we are going to use -var option, it will get the highest precedence, while if you are going to declare the same value for a variable using environment variables, it will have the least precedence. Okay, let's do a quick demo to understand these things in detail. I'm going to create a dedicated folder name as input underscore precedence. And here I'm going to mention our main.tf. Then I'm going to mention our variables.tf and the same thing using, I would say, providers.tf. And I will quickly copy the values from our last lab. So here I'm going to do a hard coding for our location value. I would mention here as east-US. Okay, and I will copy this value inside variables.tf, and I will mention the value for this variable name as default underscore rg. Then I'm going to copy the providers.tf here. Okay, so what we have done, we have created the three file. One is main.tf where we do have mention our resource block, and here what we, in terms of location, we have hard coded the value east-US, and we have declared one variable name as var.rg underscore name. In case of variables, we have defined the value for rg underscore name as default underscore rg. I'm going to copy the path. I'm going to do Terraform plan. And as we have discussed multiple times, it is going to fetch the value of the resource group name from variables.tf and name as default underscore rg. See, whatever the value we do have mentioned in default one, it is able to fetch the value. So what is the first thing we are going to do? We are going to create an environment variable with a name called, I would say, for our rg underscore name. Let me do it quickly. I would say tf underscore var underscore rg underscore name. I will mention it env underscore rg. Let me click on OK. 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 And let me open a new terminal to reflect the changes. Copy path. CD. And I'm going to run Terraform. If you see here, we are not getting a value default underscore rg for our resource group name. We are getting a value name called as env underscore rg. What does it mean? If we do have declared the default value and then you do have declared using an environment variable, then this one will have high precedence in comparison to the default value. So what is the next second thing which we are going to do? We are going to create a file name called as terraform.tfvars, and here dot so in terraform.tfvars file we have declared the rg name as tf underscore rg, and let me run the Terraform plan again and see. Name as tf underscore rg. What does it mean? It means like if you're going to pass a default value, it will get the value. If we are not having the environment variable, I have passed the value as environment variable. Then the environment variable RG resource group name will be present. If I'm going to mention terraform.tf vars file, terraform.tf vars file, it will get the precedence. And the fourth one, which we are going to discuss, to pass the value using hyphen var option. And let's see. So at the runtime, I'm going to run terraform plan hyphen var is equal to rg underscore name is equal to cmd underscore rg. You see here, it is not able to fetch the value from our terraform.tf vars file or the value which we have declared inside variables.tf. Whatever the value we have passed at the runtime using cmd, the same value we are able to fetch. This video we have discussed the precedence of the variables value. So thanks a lot for watching the video. Hi everyone, in this video we are going to discuss about the data sources. Data sources in Terraform provide a way to fetch information about existing infrastructure or resources from external system. Let's take an example to understand this thing in detail. Fetching information about existing resource group to create a storage account. What does it mean? It means like we are already having one resource group present inside our portal.azure.com and we are planning to create a storage account. Okay. As you already know, while creating a storage account, it is mandatory to have one resource group. But in this case, we do not want to create a new resource group. The resource group is already present inside our portal.azure.com and we are not sure, is it manually created? Is it created through PowerShell? Or is it created, I would say, using Ansible script? Or is it created using Terraform only? But we want to use this resource group inside our storage account. Okay, so what we are going to do to fetch the information of our resource group from the portal.azure.com, we are going to write a data block. Okay, and what is the main functionality of the data block? The main functionality of the data block is to fetch the information of an existing infrastructure and it will be only in read only mode. Okay, so while defining our storage account, what we are going to do, we are going to use the data block attribute to fetch the information for the resource group. Example 2, fetching information about an existing virtual network to create a virtual machine. In this example, what we are trying to achieve, we are already having our virtual network present inside the portal.azure.com, and what we want to achieve, we want to create a virtual machine. Okay, so in this case, we already know to create a NIC, we need one IP and this IP will be fetched from the subnet. Okay, so what we are going to do, we are already having our virtual network. We are going to write a data block for to fetch the information for our subnet. Okay, and then we are good to mention this information inside our resource block of virtual machine creation. In example 3, fetching information about existing app service plan to create a function app. So we are already having our app service plan present inside our portal.azure.com and we are creating a new, I would say, function app. Okay, so while creating a function app, it is mandatory to have app service plan and it is, as I do have mentioned, it is already present inside our portal.azure.com. So we are going to write what, a data block for app service plan, and then we are good to use this data block information inside our resource block of function app. Documentation references. List of available data sources are associated with each resource of a provider. As we do have discussed initially, like each of the provider is having
two things. One, it is resources, and the another one is data sources. Regarding the resources, we already have discussed in detail in terms of what is the capability of resources. While in the case of data sources, is basically responsible to fetch the information about an existing resource. So if we are going to mention about the Azure RM resource underscore group of data sources, we will be able to fetch the information from portal.azure.com. In the same way, if you are going to mention subnet in Azure RM documentation, you will get two things. One, it is regarding the resource block, and the second one is regarding the data sources block. The resource block is generally responsible for creating a new Azure RM subnet, while in the case of data source, it will be responsible to fetch the information of existing subnet. Let me open official documentation to discuss this thing in detail. I have opened the Azure RM official documentation. Let me click on subnet. If you see here, we are having this Azure RM subnet to create a new subnet. While in the data source, we are having one more Azure RM subnet. If you see here, use this data source to access information about an existing subnet within a virtual network. So it is the same thing which we do have discussed. It is generally responsible to fetch the information of the existing subnet, and it will be in read only mode. The syntax will be data, then it would be the name of the resource, then it would be local name, and these are the three attributes which we have to pass to fetch the information. And if you see here, these are the argument reference, the name, virtual network, resource group name, and these are the values which we are good to fetch from this data block. Like if you need to get the information regarding the route table ID or service endpoint, or I would say address prefix, we are good to mention it using data block. The same thing I'm going to search for resource group also. This resource group will be responsible to create a resource group, while in the case of data sources, this resource group will be responsible to fetch the information of the existing resource group. In this, again, we have to mention the data block, then the resource name, then the local name, and this is one of the attribute which is mandatory to pass. It would be the name of the resource group, and these are the value like ID, location, and tags. We are good to fetch it from this data block. So what would be the data sources format? As we do have discussed, like we want to create one storage account, but the resource group is already present inside the portal.azure.com, and we want to fetch the information regarding the resource group inside our storage account. So what we are going to do, we are going to write a resource block, and this resource block will be responsible for creating the storage account. And we do have mentioned the name and the account year, the account replication type, and the tax. But we want to use the resource group which is already present. So we are going to mention the data and the global name and the local name, and what is the name of the resource group which is already present inside the portal.azure.com. We do have mention, and once this thing is updated, to fetch the information, what we are going to mention, the first one, it would be our data block, then the global name, then the local name, and what we want to fetch, we want to fetch the name. Here again we want to fetch the location, so we have mentioned data dot global name, the local name, and the location. If we want to fetch any other details like ID, the same syntax it would be fine. So in the next video, I'm going to do a quick demo on Azure RM storage account creation where the resource group is already present. Okay. Hello everyone, in this video we are going to do a quick demo on data block. So in this demo what we are going to do, we are going to create a storage account. Okay, to create the storage account we are going to use resource block. Okay, in this case we have already created a resource group in our portal, and this already created resource group we need to use for our storage account creation. So in this case what we are going to use, we are going to use a data block. Okay, and this data block value we are going to update inside the resource block of storage. Okay, so let's create a Terraform file for this configuration. I'm going to create a file name called as main.tf, and the second file name called as providers.tf. We'll copy the values, update the features block, And then I'm using version 4, so I need to update the subscription ID. Well, copy paste the things. In main.tf, what we need to create? We need to create a storage account. I will mention here as storage underscore account. Let me copy the configuration. We'll paste it here. Okay. So in this case, we only need to create Azure RM storage account. We don't need to create Azure RM resource group. It is already created. So instead of resource block, what we need to use? We need to use data block. Okay. So in the documentation, I'm going to mention resource group. And if you see here, we're getting a two option for resource group. For one is resources, another one is data sources. We don't need to focus on resources. We only need to focus on data sources because our resource group is already created inside our portal. So I'm going to copy this configuration. We don't need output blocks. I'm going to remove it. So if you see here, the resource group name and location. If you want to call any resource, you don't need to mention the resource block. But in the case of data block, what we need to mention? We need to mention data dot resource name dot local name and the attributes. The same thing we are going to do for data block. So this one will fetch the whatever the resource group name we are going to pass, and this one will fetch the location. But in data block, we only need to pass the RG name. The other values like location, ID, and the tags, automatically it is going to paste it. For more details, let me explore the official documentation. Name is a required argument, while the ID, location, and tags are the following attributes are exported, which means we do not need to pass this value while mentioning the data block. But if you want to fetch this ID, location, and tags, we are good to fetch it using data.azure rm resource group name dot example dot ID, location, or tags. Okay. So I have already created a resource group name called as demo-data-rg. I'm going to mention it here. I will create a two variable, one entity for my storage underscore account underscore name, and the default value I'm going to pass demo storage, and will update some random value, demo storage, and will update some random number. And for my resource group, what I'm going to do, I'm going to create a variable rg underscore name, and default value it would be demo hyphen data hyphen rg. Let me cross check. It is demo hyphen data hyphen rg. And here, what we need to mention, we need to mention var dot my rg name. And here I need to mention var dot storage account name. Okay. And it is always a good practice to create a dedicated file about each and every type of resources. So here I'm going to create a file name called as data.tf, and the second one it would be variables.tf. Data.tf value, I'm going to paste it here. Variables value, I'm going to paste it here. Okay. The one more thing which I need to update, my subscription ID. We'll click on this one and we'll copy it. So our providers.tf looks good. Variables.tf looks good. Main.tf looks good. And we have mentioned a data block to paste the values, and parallelly the data block also. Let me copy the path. So the first command I'm going to run, Terraform init. The next command I'm going to run, Terraform validate to check the configuration. It looks good. We'll clear the screen. The first thing I'm going to run, The next command I'm going to run, the Terraform plan. So it is going to create one resource, which is our storage account. And if you see here, it is fetching a value using a data block. That's why it is mentioned as reading and reading complete after 0 seconds. So what it has done, from our local machine, it has connected to my Azure account, or I would say Azure subscription, and it has checked about this demo-data-rg, and it said okay. Then it has started creating the storage account. Okay, let me do one thing. Let me update demo-data-rg123, which is not present inside our resource group. So in this case, let's check, are we getting any error or not? If you see here, we are getting an error. What is the error? Initially, it started for reading the data block or fetching the details from our Azure account. Terraform encountered an error while generating this plan. Why? Because resource group was not found. And this resource group is not present inside our Azure account. That's why it is failed. Okay. So let me update the resource group name and run this configuration again. See, the one resource is going to be created, and in which resource group it is going to create it inside demo-data-rg. From apply-auto-approve. So finally, our storage account has been created. Let me quickly check inside the portal. If you see here, our storage account has been created. Okay. So with this, we have completed data block. Hello everyone. In this video, we are going to discuss about the conditional expression. Overview of conditional expression. A conditional expression uses the value of a Boolean expression to select one of two values. Syntax of conditional expression. The first one is condition, question mark, true underscore value, colon, false underscore value. If condition is true, then the result is true underscore value. If condition is false, then the result is false underscore value. If this condition is going to return us true, then this first value is going to run. Okay, the first value will run. Okay, and if the condition is giving an output of false, then in this case false value will run, which means second value is going to run. I'll say the second value will run. Okay, conditional expression example. If you see here, we are creating one resource group with a name called example-resources, and the second resource which we are creating, the storage account. The resource group name and location, we are fetching it from our resource group block. And in terms of account replication type, we have mentioned here one variable. The variable name is var.env. And in this var.env, at the runtime, if user is going to pass, I would say dev, so the condition it would be true. So in this case, the value it is going to mention for account replication type, it would be LRS. Okay. If user is going to mention apart from dev anything, let's take example, if user is mentioning production, so the output of this one, it would be false. Okay. So it is going to run the second value and it would be GRS. Okay. So the first condition, whatever the condition we are having here, if it is true, the first value is going to run. If, if the condition is going to pass the false, the second value is going to run. Okay. So with this, we have completed the conditional expression discussion. In the next video, we are going to do a demo on this topic. Hi everyone, in this video, we are going to discuss about the data types for variables. Overview of data types. In Terraform, if you do not explicitly define the data type for a variable, Terraform will try to infer the type from the value assigned to it. What does it exactly means? Till now, whenever we have declared any variable, we haven't passed the data type for it. If you see in this example also, we have only declared the variable and the default value, but we haven't passed the data type for it. So as it is mentioned, Terraform will try to infer the type from the value assigned to it. So here the value pass is a string, so data type is a string. Here it is number, so data type is number. Here it is boolean, so data type is boolean. Here it is list, so the data type is list. And here it is map, so the data type is map. The best practice is to define the data type for a variable, which helps ensure that configurations are clear, predictable, and robust. If you see in the right hand side diagram, whatever the variable we do have created, okay, we have declared the data type also apart from the default. Okay. So in the next slide, we are going to have a detailed discussion. What are the different kinds of data types we do have? So basically we do have one string data type, list data type, map data type, and the number data type. If you see the sequence of Unicode characters representing some text like hello. So this one will be declared as a string. If you see list, sequential list of value identified by their position start with 0. So whenever we declare data type name called as list, we need to mention this square bracket at the starting, at the end, and whatever the values we are passing, we have to separate it using a comma. And it will start with the index value called 0, and then the next value to be 1, 2, and the list goes on. So whenever we define a map data type, a group of values identified by named labels like, so we have to mention the curly braces at the starting and at one it is called key and another one it is called as values. This one it would be name, it would be key and the value will be John and the age will be key and the value will be 53. And the last data type which we do have, which is number. So whenever we need to pass in a numeric value, we will define the data type as number and the number value should be 200. Okay. So in the upcoming videos, we are going to cover all this data type in detail. Hi everyone, in this video we are going to do a quick demo on number data type. So what I have done, I have created one folder name as number underscore demo. Then in this one I have created one file name main.tf where I mentioned my resource block. I have created providers.tf and I mentioned the providers block detail. Okay. So what we are going to do, we are going to create a variable whose value it would be number. I'm going to create a variable name as rg underscore name. In terms of I'll say data type, I would say it as number and the default value I'm going to pass it, I would say using, I would say rather than passing the number value, let me quickly pass a string value and check whether it is working or not. I'll copy the path. I'll mention here var.rg underscore name and let me run Terraform in it. There's one typo. See, we are getting an error. So what is the exact error? The default value is not compatible with the variable type constraints. A number is required. What we have done here, we have mentioned the data type as number, but the value we have passed as a string. So whenever we are mentioning any data type, the value should be same. If we are going to mismatch it, then we are going to get the error. Let me quickly update the default value to number and run this command again. Let me run Terraform apply directly and see what is the value for the name we are getting here. See, the value which we are getting here is 123. So if we are, whenever we are passing anything else, we are getting an error at the time of initialization only. So let me type yes and enter, and our resource group will be created. See, our resource group has been created with a name called 123. So in the next video, I'm going to do a demo on map data type. Hi everyone, in this video, I'm going to do a demo on map data type. So what I have done till now, I have created one folder named as main.tf where I have mentioned the resource block for creating our resource group, and in providers.df, I have updated the Azure RM provider. So we already know whenever we create a map data type, it will have the two values. One, it is key, and the second one, it would be value. To implement this value using a map data type, what is the first thing we need to do? We need to create a variable. I would say variable name as rg underscore info. And here I'm going to mention the type is equal to map. Okay. And good to mention the default value. The default value should be is equal to the name. It would be, I would say, rg underscore name is equal to, I would say, map underscore rg, and the location it would be east US. So what I have done till now, I have created a variable name called as rg underscore information, and I have mentioned the data type as map. And in the default options, what I do have mentioned the key and the value. Okay. And the key it would be rg underscore name, and the value is mp underscore rg, and the location is equal to east US. Let me set up one. Yeah, I fixed one typo. So to call this value, what I'm going to mention here, it would be var dot, what is my variable name, rg underscore information dot rg underscore the name, it would be my resource group name. So the whole flow it would be, firstly it will go to the var dot rg underscore information, this one, and then the rg underscore name, and whatever the value we do have mentioned map underscore rg, it will be fetch here. So for the location, the flow it would be var dot r rg underscore information, and what is the variable name for location, it is location. Okay, let me do terraform init and terraform plan. If you see here, the location is east US and the name is map underscore rg. So this is the default value which I have passed to my map. If I want to pass the value inside our terraform.tf vars, then what would be the syntax? The syntax it will be rg underscore information is equal to, then curly braces. What is the key name is here? rg underscore name. I will mention the value as tf vars underscore rg, and the location it would be I would mention west US. Let me Move this part to terraform.tfs file. There's one typo. Yeah. Let me run again the Terraform plan. Let's see what are the values we are getting. You see here, we are getting a value from our TFVars file in terms of location West US, and parallelly for our resource group name, we are getting a value from our TFVars file. Again, it will do the same thing in terms of the variable precedence, but this is the way to pass the map values. This will be my variable name. Then we are going to have left hand side our key, and the right hand side we are going to have the value. And in terms of calling this value, what would be our syntax? It would be var dot variable name dot our key name. Okay, let me run Terraform apply hyphen auto hyphen approve to save the time. So the resource group has been created. Hi everyone, in this video I'm going to do a demo on list data type. So what I have done till now, I have created one folder named as list underscore demo, main.tf and providers.tf. In providers.tf, I have mentioned my provider detail as usual, and in main.tf, I'm going to create one resource group. Okay. As we have discussed till now, like list data type is mentioned inside the square bracket, and it works on the level of index, and the first value it would be at 0 index and then going forward. Okay, so let me update this example according to the list variable. So the first step it would be creating a variable name as rg underscore info, and then the type I'm going to mention here as list, and then the default value it would be is equal to square bracket is equal to bracket. The first value I'm going to mention for my resource group name, it would be list underscore rg, and the location I'm going to mention here as east US. Okay, so we have created the variable name called as rg underscore information, and we have mentioned the data type as list, and this one is the first value which is about my resource group name, and the second value is regarding my location. So as we have discussed, the first value index it would be 0, and the second value the index will be 1. So in terms of calling, what I'm going to mention in name, it would be var dot rg underscore information, then the square bracket, the value I wanted from the 0 index, it would be list underscore rg, and for var dot rg information, and I want to fetch the value for location, and the index value is 1. Okay, let me run Terraform init quickly and Terraform plan. So if you see here, our list underscore rg, the value name is resource group name is list underscore rg, location name is HTS, and we have mentioned the index value as 1. So our location value is HTS. So let me quickly update it this value using a terraform.tf bars file. I've created a file name called terraform.tf bars, and I'm going to update the value. So it would be rg underscore information is whatever the value we are going to mention in list, it should be inside the square bracket, and the name it would be, I would say, tf vars list underscore rg, and the location I'm going to mention it as West US. Okay, I'll move this value inside my terraform.tf vars, and let me run Terraform plan again. So if you see here, the resource group name is tf var list underscore rg, and the location name is West US. So this value is getting fetched from where? From our tf vars file instead of default value. Let me run Terraform apply auto approve. Terraform apply hyphen auto hyphen approve. So resource group has been created. Let me quickly check with a name called tf list underscore rg. Let me refresh from the top. See, our resource group has been created and the way we have created using a list data type. Hi everyone, in this video, we are going to do a demo on Terraform meta argument. So before discussing the meta argument, let's discuss firstly how Terraform applies a configuration. Although till now we have a very detailed discussion about all this thing, but let's recall all this topic before discussing the meta argument. What is the first case? Create resources that exist in the Terraform configuration file but are not associated with a real infrastructure object in the state. Let's take example to explain it. What we do have file name called as main.tf. Okay, in main.tf I'm going to write a resource block for our creation of a storage account. So when we are going to run Terraform init, then Terraform plan and Terraform apply, eventually a storage account will be created inside our Azure account. Okay, and parallelly what we are going to have, we are going to have our state file for this configuration. So this is the basic thing which we do have discussed till now. Destroy resources that exist in the state but no longer exist in the Terraform configuration file. If we are going to remove the resource block from the main.tf and then we are going to run Terraform init, plan and apply, what it will do? It will destroy the resource. It means these resources are not required. So from the Azure account, it is going to delete my storage account. Update in place resources whose argument have changed. If you see here in the resource block, let's take example, we have not created any tag while creation of the storage account. Okay. And parallelly from Azure account, what we have done, we have created a tag for it. Okay. So in the next run of Terraform init, plan and apply, what it will do, it will remove all the tags from this storage account. And as we do have discussed in the desired state and the current state, it will come to the desired state configuration. Destroy and recreate resources whose argument have changed but which cannot be updated in place. So if you're going to create any resource group with a name called, I would say A, B, C. Okay, and then you want to rename this resource group from A, B, C to D, E, F, then what is going to happen? It will ask us to delete this one and then we are good to create with a new name. Okay, and this process is called recreate of the resources. Okay, so these are the things which we do have discussed till now. Understanding the limitations. What happen if we want to change the default behavior? So in the last slide we had a very detailed discussion about the default behavior of resource block. Some modification happened in real-time infrastructure that is not of Terraform part, but you want to ignore this change during Terraform apply. So what is the exact meaning? I would say, if you see here, the first resource block is responsible for creating my resource group, while the second resource block is responsible for creation of my storage account. And what we have done, we have updated tags for my storage account. When we are going to run Terraform init and then Terraform apply, what it is going to do, it will create the two resource inside my Azure account. Okay, let's take example. Someone has added one more tag here. I would say created underscore by is equal to A Kumar. Okay, so as we do have discussed in terms of desired state is equal to current state. So in the desired state, have we mentioned created underscore by is equal to Kumar is required? No, this one is done manually in our Azure account. So whenever we are going to run our next command Terraform apply, it will undo it and it will remove the created underscore by is equal to comma. So if you want to ignore those changes during Terraform apply, how are you going to achieve it? Okay. Solution is using meta arguments. So in this case, meta arguments is going to help us. Terraform allows us to include meta argument within the resource block, which allows some details of this standard resource behavior to be customized on a per resource basis. If you see here, the same code, creation of resource group, and the second one is for our storage account. What we have done, we have updated a life cycle block. In this life cycle block, we have mentioned one meta argument name called as ignore underscore changes is equal to tag. So in this case, if you are going to update manually, created by is equal to a Kumar manual process from Azure end. In this case also, if you are going to run the Terraform apply, what Terraform is going to do? Terraform will ignore these changes. To ignore these changes, what we need to use? We need to use meta argument. Okay. So there are four arguments available within the lifecycle block. Create before destroy, prevent underscore destroy, ignore underscore changes, replace underscore triggered underscore by. So we are going to have a very detailed discussion about all these type of arguments. Okay. Hello everyone. In this video, we are going to discuss about the create before destroy meta argument. Create before destroy argument. Create underscore before underscore destroy meta argument changes this behavior so that the new replacement object is created first and the prior object is destroyed after the replacement is created. So what is the exact meaning of it? If you see in the first diagram, we are having a resource group name called as example hyphen resources 23. What we have done in the second diagram, we have updated the name from example hyphen resources 23 to example hyphen resources 234. So in this case, when we are going to run Terraform apply, what it is going to happen? Firstly, this resource group will be deleted. Okay. And then this resource group will be created. So this is the default behavior of a resource block. But what we want firstly this resource to be created and then this resource should be deleted. So to achieve this one, what we have to do, we have to use a lifecycle meta argument named called as create underscore before underscore destroy. By default, it is false. So what we have to mention here, we have to mention true. Then we are going to change the resource group name from example hyphen resources 23 to 234. In this case, firstly, this resource group will be created, which is our new one, and then this the old resource group will be deleted. This is a benefit of using create underscore before underscore destroy. So let's do a quick demo to understand this thing in detail. So what I have done till now, I have created two file name called as providers.tf where I have mentioned the provider configuration detail, and here I have mentioned the main.tf. In main.tf, I'm going to create a resource group name called as example and the location is West Europe. So let me copy the path and create this resource group. So the first command I'm going to run terraform init. To save the time, I'm going to run directly terraform apply hyphen auto hyphen approve. So the resource group has been created. What I'm going to do, I'm going to update the name of this resource group from example to example 1. Okay. And let's see what would be the default behavior. I have updated the resource group name as example 1. Let me run again the Terraform apply and press enter. I'm going to type yes. So what it is going to do? As we are already aware about the desired state and the current state, initially it has created a resource group name called as example, and for example it has created a state file, and right now we have updated the name from example to example 1. So in this case, the firstly this resource will be deleted and this resource is going to be created. Okay, let me show you inside the configuration also. See what it is mentioned. We mentioned Terraform apply and it is saying destroy and then create replacement. It is going to update this one example to example 1. Firstly, it is destroying the resources, and once this destruction complete, then it is creating the resources. But what we want firstly my new RG should be created with a name called example1, and then the resource should be deleted. Okay, so what I'm going to do in this case, we have already created a resource group name called as example1. So I will remove one. So my new requirement is I want to create a resource group name called as example, and I will mention here lifecycle create underscore before underscore destroy. By default it is false. I'm going to mention it as true. Okay, and let me run Terraform apply. Again the same thing it would be happen. Right now what we have done from the example 1 to example we want. So in the same thing it would be happen. It will mention like, hey, I need to delete this one and to create. I will type yes. The end result is same. It has destroyed one resource group and created one. So in this case it has created this example resource group and deleted the old one. Okay, but the process is different. Why? Because we have mentioned create underscore before underscore destroy. So firstly it has created this RG. Okay, and then it has deleted this. Firstly it has created this RG and then it has deleted this example one. See, creation complete after 14 seconds for our resource group, and then it has started deleting my this RG, destroying. Okay, so this is the basic benefit of implementing lifecycle meta argument name called as create underscore before underscore. Hello everyone, in this video I'm going to discuss about the lifecycle prevent destroy meta argument. Prevent destroy argument. This meta argument, when set to true, will cause Terraform to reject with an error any plan that would destroy the infrastructure object associated with the resource, as long as the argument remain present in the configuration. So what is the exact meaning of it? If you see here in this example, we are creating one resource group. And the second thing which we are creating the key vault. And the name of the key vault is demo-kv213. Once this resource is created, okay, by implementing a Terraform apply, if we want to create the destroy, I would say Terraform destroy command will get an error. Why? Because if you see here in the life cycle block, we have mentioned prevent underscore destroy is equal to true, which means the Terraform destroy will give the error to us. Okay. So if you want to destroy this resource, you have to remove this one from the Terraform configuration file. Once this configuration is removed, at the destroy time, you will not get any kind of error. So let's do a quick demo to understand this topic in detail. So what I have done till now, I have created two files name called as providers.tf and main.tf. Providers.tf, I have mentioned the provider configuration, and in the main.tf, the first resource block is responsible for creating my resource group, and the second resource block is basically responsible for creating my key vault. Okay, so the first thing which I'm going to do, I'm going to create this key vault, and once this key vault is created, we'll update the lifecycle block prevent underscore destroy is equal to true, and then I will try to destroy this key vault. At that time we will check, are we getting any error or not. Okay, so let's start the demo. So initialization has been completed. I'm going to run Terraform apply. So here, so two of the resources are going to be created as mentioned. One it is my resource group and the second one is my key vault. Okay, let me type yes to initiate the process. If you see here, two of the resources are created. Let me quickly check inside the portal. Let me refresh it. So the resource group has been created, name called as prevent hyphen destroy hyphen demo hyphen rg, and we are having this key vault. Okay. So what is the next step we have discussed? The next step is we need to update the lifecycle block. What is the meta argument we are having? It is prevent underscore destroy. By default, it is false. We need to enable it as true. Okay. If I'm going to mention Terraform destroy, if you see here, we are getting an error. Instance cannot be destroyed. Resource Azure RM underscore key underscore vault dot example has lifecycle dot prevent underscore destroy set, which means this resource Azure RM key vault has lifecycle enabled with a meta argument called prevent underscore destroy is equal to true. To avoid this error and continue with this plan, either we need to remove this block from our resource block or else we need to update the value to false. Okay, once we update the value as false, which is the default value, we are good to delete this key vault or reduce the scope of the plan using the hyphen target option. In this case, it is not applicable, but if you are having, I would say, around 4 resource, and out of 4 resource you are having lock on only one resource. In this case, what you have to do, you have to use a hyphen target option to delete the 3 resources. Okay, so let me disable this one from true to false and let's run again the Terraform. If you see here, two of the resources are destroyed. One it is our key vault and the second one is our resource group. Okay, so in real time scenario, we generally use prevent underscore destroy lifecycle for our database configuration, or I would say the critical configuration which we not want to delete. Okay, so with this we have completed this demo. So hello everyone. In this video, I'm going to discuss about the lifecycle ignore changes meta argument. Ignore changes argument. In cases where setting of a remote object is modified by processes outside of Terraform, the Terraform would attempt to fix on next run. So what is the exact meaning of it? If you see here, we are creating one resource group and the second thing which we are creating ACR. Okay. So both the resources has been created in our Azure. Okay. If you see here, what is the tag value we have passed? We have passed environment is equal to QA. If I'm going to update one more tag, I would say my ticket underscore number is equal to 123. Okay. So, and this value is updated manually. Manually, we have updated this thing in our cloud environment, or I would say in our Azure environment. Okay. So in the next run, when we are going to do Terraform plan, what it is going to happen, as we do have discussed, the desired state will not be equal to the current state. So what the Terraform is going to give the suggestion, this configuration has been changed outside of this Terraform configuration. So we are going to remove it. Okay, and in Terraform apply, once Terraform apply is done in Azure portal, what you're going to see, you will only see environment is equal to QA. In order to change this behavior and ignore the manual applied change, we can make use of ignore underscore changes argument under lifecycle. So if we are going to mention lifecycle meta argument name called as ignore underscore changes with the value of tags. Okay. In this case, if you are going to run Terraform apply, Terraform will ignore this changes whatever we have done manually. Okay. And in Terraform apply, there would not be any kind of changes. Okay. So this is a benefit of ignore changes meta argument. It is a list of values. If you want to update any other values apart from tags, you're good to mention it like our SQ. Let's do a quick demo to understand these things in detail. If you see here, I have created two files. One is main.tf, another one is providers.tf. In providers.tf, I'm having provider configuration details. In main.tf, I'm having resource configuration detail. In main.tf, as we do have discussed, I'm going to create one resource group. And the second thing which I'm going to create, I'm going to create one ACR. Okay, let's quickly run Terraform apply to create the resources in our Azure environment. Okay, so the initialization has been completed. In the next command, I'm going to run Terraform apply hyphen auto hyphen approve. If you see here, we have created two resources. One it is our resource group and the another one is our Azure container registry. Let me quickly check this one inside our portal.azure.com. See, the example hyphen resources has been created and inside we are having our ACR. So currently what we are having one tag only. So I'm going to update one more tag. I would say created underscore by is equal to A Kumar and ticket underscore number. I would say 123 and let me save it. So as we do have discussed, we do have desired state and current state. So it should be equal. The desired state should always be equal to the current state. But we have made some changes in the tag configuration. So if you are going to run Terraform apply, it will ask to remove the both the changes. Then only desired state is equal to the current state. Okay, so let me run Terraform plan to show the changes. Let me run Terraform plan to reflect all the changes. If you see here, it is clearly saying like two of the values in our tag which is created by and ticket number should be null because both of them are not updated inside our desired state. So to overcome this kind of challenges, what we need to do, we need to use ignore changes meta argument. The first thing I'm going to mention lifecycle and ignore changes. Ignore changes contain list of values, so we're good to pass and number of values to them. So currently I'm passing tags. I'll save the configuration and run Terraform plan. See here, we are getting a message, no changes, your infrastructure matches the configuration. Let me quickly change this admin enable to true and then see are we getting any kind of change request or not. So I'm going to click on admin user enabled. See, so my admin login has been enabled with a username demo ACR 2132. But here what we have mentioned, the admin enabled is false. Let me run again the Terraform plan. Again, It will suggest, see, it is saying to change the true value which we have done manually to false. If you want to ignore these changes also, what we have to do? We have to update our ignore changes list value. So I'm going to mention here as admin enabled and let me run again. See, right now it is showing what? Your infrastructure matches the configuration because whatever the changes we have done in tags and admin enabled value using manual process, the Terraform is ignoring. Why? Because we have updated a meta argument name called as ignore underscore changes. So with this, we have completed this demo. Hello everyone. In this video, we are going to discuss about the Terraform count meta argument. General approach. Let's assume you need to create two public IPs. One of the common approach is to define two separate resource blocks for Azure RM underscore public underscore IP. If you see in this example, the first resource block is responsible for creating my RG, and the second resource block is responsible for creating my first underscore IP, and the third resource block is responsible for creating my second underscore IP. Here we are only creating two public IPs, so we are good to mention it twice. But in real time scenario, if someone asks you to create around 10 public IPs, are you going to mention this resource block 10 times? My answer it would be no. In real time scenario, we need to use count meta argument. Overview of count parameter. With count parameter, we can simply specify the count value and the resource can be scaled accordingly. Here, the first resource block is for my resource group. The second resource block, if you see, it is for my public IP. But we have mentioned count is equal to 2. So what is the exact meaning? It means this resource block is going to run for 2 times. Okay. If we are going to mention count is equal to 10, so this resource block is going to run for 10 times. So this is a benefit of using count parameter. Challenges. The below code will create the first public IP successfully, but the issue arises when Terraform attempts to create the second public IP as it results in an error. So what is the exact meaning of it? So when the first time it is going to run, I would say it is going to create a public IP with a name called my IP. But when it is going to run for the second time, it will try to create the public IP with the same name called my IP. As you already know, like in Azure, we need to have the resource name unique. In this case, we'll get the error like, hey, the public IP is already present in our subscription. So to overcome this issue, what are the options we do have? So we are good to use count index. So what is the exact meaning of count index? Count.index in Terraform is zero based index that represent the current instance position when creating multiple resources or module using the count meta argument. When count is equal to 2 in Terraform, count.index will take value of 0 and 1 for the two instance created. Each instance is assigned an index starting from 0 and incrementing by 1 up to count minus 1. So for example, PIP1 count index it would be 0, PIP2 the count index it would be 1. So if you see in the right hand side, the first block obviously it would be for my resource group. In the second one, what we are doing, we have mentioned count is equal to 2. So this one is going to run for 2 times. But what we have mentioned apart from my IP, we have mentioned count.index. So when the first time it is going to run, the index value it would be 0. So my IP 0 we are going to get. And the second time it is going to run, the index value it would be 1. So the IP name it would be my IP 1. So this is the basic functionality of using count.index. Challenges with default count index.
Having an IP name like my IP0, my IP1 might not always be suitable. So in real-time scenario, we need some relevant name. If we are going to mention my IP0 or my IP1, it would not be up to the mark. Names like dev-pip, stage-pip, prod-pip is better. So count.index can help in such scenario as well. So what is the exact meaning of it? If you mention this kind of name, my PIP0, my PIP1, it would not be relevant in real-time scenario. In real-time scenarios, we want some relevant names. So to achieve this one, I would say count.index can helps us. So what we have done in this case, we have created a PIP underscore names variable and the data type is list, and the list we have passed dev-pip, stage-pip and prod-pip. Okay. So the exact solution will look like this. The first resource block for creating resource group, the second resource block for creating my public IP. I have mentioned count is equal to 3. So the count index it would be for first run it would be 0, the second run it would be 1 and the third run it would be 2. So for the first run var.pip.names and the count index value it would be 0. var.pip means in this variable the index value of 0 dev underscore pip value it would be updated. Then we are going to have qa underscore pip at first block. So the second time when it is going to run it will update qa underscore pip, and the third time when it is going to run the index value it would be 2. So it will have prod underscore pip. So in this case, all the public IP will have the unique name and also it is going to have relevant name. So with this, we have completed our count meta argument discussion. In the next video, we are going to do a demo for it. So hello everyone, in this video, I'm going to do a demo on count meta argument. So the first thing which we are going to do is to create two public IP using two resource block. Okay. Then second thing which we are going to do, we are going to create a two public IP with a count meta argument. And then the third one which we are going to do, I would say two public IP using count dot index to make it unique. Okay. And the fourth example which we are going to do, it would be on creating a list data type and then fetching the values from it. Okay, so let's start our demo. If you see here, I've already created a folder name called as count underscore demo. I'm having a file name called providers.tf. In main.tf, what I'm going to do, I'm going to search in official documentation. It is public underscore IP we are targeting to create. So here it is, Azure RM underscore public underscore IP. Will copy it. So I will mention the resource group name as count hyphen demo hyphen RG. And the public IP name, I would say my first underscore public underscore IP. I will copy this block. For my second public IP, I'll mention here second PIP. If you see here, we have mentioned resource block 2 times. This name, the global resource name, we are good with it, but the local name should be unique. So in this case, what I'm going to do, I'm going to update some value. I'll mention here as second underscore PIP, and this one it would be first PIP. So let me run the Terraform configuration. The first command I'm going to run Terraform init, and then let me run Terraform apply hyphen auto hyphen approve. If you see here, we have created the three resources. One it is my resource group and the two of them are our public IP. Let me quickly check inside my portal. See, we are having count hyphen demo hyphen RG resource group and we are able to see two public IP.
But in real time scenario, if someone is asking you to create a 10 public IP, do you think it is a good idea to mention this resource block 10 times? The answer is no. So to overcome this kind of issue, what we have discussed in the last slide, we are good to mention the count block. Okay, so for the count block, what I'm going to do, I will create a dedicated folder for it and then we'll try to implement with underscore count. Create a two file name called as main.tf and providers.tf. Providers.tf configuration, I'm going to copy it from here. For main.tf, again the same thing we are going to do. We are going to create two public IP. So I'll copy this one and paste it here. So to create a two public IP, what we have discussed, we need to mention count is equal to 2. When we are mentioning count is equal to 2, this one it is going to run for 2 times. Okay. So I have mentioned count is equal to 2. And let me update the variable values also. PIP. And here also I will mention my PIP. We see here this resource block is going to run for 2 times. Okay. But when the first time it is going to be completed, it is going to create a IP with a name called mypip. The second time when it is going to run and create a public IP with the same name, at that time it will get an error because a public IP name should be unique throughout the subscription. So what we have discussed in the last slide, to overcome this kind of challenge, we have to use count.index. So I'll mention $sign, then count.index. So in this case, when the first time it is going to run, the count index value would be 0. My IP 0 will be created. In the second run, the count.index value to be 1. So my IP 1 will be created for us. So let's copy the path and try to implement it. So the first command, it would be Terraform init. The second command I'm going to run, Terraform plan. There's one typo. It is Terraform plan. If you see here, 3 of the resources are going to be created. One, it is my resource group. The second one, it is my IP 0, and the third one is my IP 1. As I do have mentioned, the count.index, it works on 0 and then 1. So in the first run, what it is saying, it is saying Azure RM public under Azure RM underscore public underscore IP dot PIP, and the value is 0. In the second run, it is showing Azure RM underscore public underscore IP dot PIP, the index value is 1. If you are going to mention here count is equal to 10, then in this case, let's see. The index value will come from 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. If you see here, 11 resources are going to be created. The first one, it was my RG, and then we are going to have the index value from 0, 1, 2, 3, and for each of them the public IP name is updated to make it unique. See, for 3 it is 3, for 4 it is my IP 4, for 5 it is 5, and this one it will go till 9 1. Okay, let me update it to. So I'm going to run Terraform apply hyphen auto hyphen approve to save the time. So it is going to create 3 of the resources. If you see here, the 3 of the resources has been created. Let me quickly check inside the portal. Resource group created, count hyphen demo hyphen RG. Here we are having two public IP name called as mypip0 and mypip1. As we do have discussed in the last video, like it is always good to have some relevant name. So to To do this, what we have to do, we have to create a variable, and then this variable need to be called at the public IP name. So let's start a demo for it. So what I have done till now, I have created a file name called as providers.tf, and then I'm having a file name called as main.tf. In main.tf, what I'm going to do, I'm going to create a variable with a name called pip underscore name. And the type I'm going to mention is equal to list. Okay. And then the default value which I'm going to pass, I would say this one as my dev-pip. The second value which I'm going to pass, qa-pip. And the third value which I'm going to pass, it is prod-pip. So here, how many values I have passed? I have passed 3 values. So I need to mention count is equal to 3. And then in terms of calling, I have to call this variable. So I'll mention var.pip underscore name, then a square bracket. In a square bracket, I'm going to mention count.index. So what would happen? The index value of pip names are dev-pip, it is 0, qa-pip is 1, and prod-pip is 2. Okay. And when we are going to run it for the first time, the index value should be 0. So it is going to call var.pip with the index of 0. So in this case, what would be the value it is going to fetch? The value it would be dev-pip. When the second time we are going to run it, the index value it would be 1. So the var.pip, the index it would be 1, and the value which is going to fetch it is qa-pip. And the same thing which we are going to see in our third run, the index value it would be 2. So the value which is going to be updated here, it would be 2, and the value, and we are going to have prod-pip. Okay. And one more thing I would say, count demo -var to make it unique. Let me copy the path and run this configuration. I'm going to run Terraform plan. There's one typo. So 4 of the resources will be created. One, it is my resource group. At the 0 index, the value it is dev-pip. The first index, the value is qa-pip. And for the third index, the value is prod-pip. Let me run Terraform apply-auto-approve. See, our 4 resources has been created. Let me quickly check inside our portal. Click on resource group. The name is count-demo-var-rg. And if you see here, we are having a public IP name dev-pip, prod-pip, and qa-pip. And all these 3 names are more relevant if you compare with mypip0, mypip1, and mypip2. So with this, we have completed this demo. Hello everyone, in this video I'm going to do a demo on count meta argument. So the first thing which we are going to do is to create two public IP using two resource block. Okay. Then second thing which we are going to do, we are going to create a two public IP with a count meta argument. And then the third one which we are going to do, I would say two public IP using count dot index to make it unique. Okay. And the fourth example which we are going to do, it would be on creating a list data type and then fetching the values from it. Okay, so let's start our demo. If you see here, I've already created a folder name called as count underscore demo. I'm having a file name called providers.tf. In main.tf, what I'm going to do, I'm going to search in official documentation. It is public underscore IP we are targeting to create. So here it is, Azure RM underscore public underscore IP. Will copy it. So I will mention the resource group name as count hyphen demo hyphen RG. And the public IP name, I would say my first underscore public underscore IP. I will copy this block. For my second public IP, I'll mention here second PIP. If you see here, we have mentioned resource block 2 times. This name, the global resource name, we are good with it, but the local name should be unique. So in this case, what I'm going to do, I'm going to update some value. I'll mention here as second underscore PIP, and this one it would be first PIP. So let me run the Terraform configuration. The first command I'm going to run Terraform init, and then let me run Terraform apply hyphen auto hyphen approve. If you see here, we have created the 3 resources. One it is my resource group and the 2 of them are our public IP. Let me quickly check inside my portal. See, we are having count hyphen demo hyphen RG resource group and we are able to see 2 public IP. But in real time scenario, if someone is asking you to create a 10 public IP, do you think it is a good idea to mention this resource block 10 times? The answer is no. So to overcome this kind of issue, what we have discussed in the last slide, we are good to mention the count block. Okay, so for the count block, what I'm going to do, I will create a dedicated folder for it and then we'll try to implement with underscore count. Create a 2 file name called as main.tf and providers.tf. Providers.tf configuration, I'm going to copy it from here. For main.tf, again the same thing we are going to do. We are going to create 2 public IP. So I'll copy this one and paste it here. So to create a 2 public IP, what we have discussed, we need to mention count is equal to 2. When we are mentioning count is equal to 2, this one it is going to run for 2 times. Okay. So I have mentioned count is equal to 2. And let me update the variable values also. PIP. And here also I will mention my PIP. We see here this resource block is going to run for 2 times. Okay. But when the first time it is going to be completed, it is going to create a IP with a name called myPIP. The second time when it is going to run and create a public IP with the same name, at that time it will get an error because a public IP name should be unique throughout the subscription. So what we have discussed in the last slide, to overcome this kind of challenge, we have to use count.index. So I'll mention $, then count.index. So in this case, when the first time it is going to run, the count index value would be 0. My IP 0 will be created. In the second run, the count.index value to be 1. So my IP 1 will be created for us. So let's copy the path and try to implement it. So the first command, it would be Terraform init. The second command I'm going to run Terraform plan. There's one typo. It is Terraform plan. If you see here, 3 of the resources are going to be created. One, it is my resource group. The second one, it is my IP0, and the third one is my IP1. As I do have mentioned, the count.index, it works on 0. and then 1. So in the first run, what it is saying Azure RM public under Azure RM underscore public underscore IP dot PIP, and the value is 0. In the second run, it is showing Azure RM underscore public underscore IP dot PIP, the index value is 1. If you are going to mention here count is equal to 10, then in this case, let's see. The index value will come from 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. If you see here, 11 resources are going to be created. The first one, it was my RG, and then we are going to have the index value from 0, 1, 2, 3, and for each of them, the public IP name is updated to make it unique. See, for 3 it is 3, for 4 it is my IP 4, for 5 it is 5, and this one it will go till 9 1. Okay, let me update it to. So I'm going to run Terraform apply hyphen auto hyphen approve to save the time. So it is going to create 3 of the resources. If you see here, the 3 of the resources has been created. Let me quickly check inside the portal. Resource group created count hyphen demo hyphen RG. Here we are having 2 public IP name called as mypip0 and mypip1. As we do have discussed in the last video, like it is always good to have some relevant name. So to do this, what we have to do, we have to create a variable, and then this variable need to be called at the public IP name. So let's start a demo for it. So what I have done till now, I have created a file name called as providers.tf, and then I'm having a file name called as main.tf. In main.tf, what I'm going to do, I'm going to create a variable with a name called pip underscore name. And the type I'm going to mention is equal to list. Okay. And then the default value which I'm going to pass, I would say this one as my dev hyphen pip. The second value which I'm going to pass, qa hyphen pip. And the third value which I'm going to pass, it is prod hyphen pip. So here, how many values I have passed? I have passed 3 values. So I need to mention count is equal to 3. And then in terms of calling, I have to call this variable. So I'll mention var.pip underscore name, then a square bracket, and a square bracket I'm going to mention count dot index. So what would happen? The index value of pip names are dev hyphen pip, it is 0, qa hyphen pip is 1, and prod hyphen pip is 2. Okay, and when we are going to run it for the first time, the index value it would be 0. So it is going to call var.pip with index of 0. So in this case, what would be the value it is going to fetch? The value it would be dev hyphen pip. When the second time we are going to run it, the index value it would be 1. So the var.pip, the index it would be 1, and the value which is going to fetch it is qa hyphen pip. And the same thing which we are going to see in our third run, the index value it would be 2. So the value which is going to be updated here, it would be 2, and the value, and we are going to have prod hyphen pip. Okay, and one more thing I would say, count demo hyphen var to make it unique. Let me copy the path and run this configuration. I'm going to run Terraform plan. There's one typo. This. So 4 of the resources will be created. One, it is my resource group. At the 0 index, the value it is dev hyphen pip. The first index, the value is qa hyphen pip. And for the third index, the value is prod hyphen pip. Let me run Terraform apply hyphen auto hyphen approve. See, our 4 resources has been created. Let me quickly check inside our portal. Click on resource group. The name is count-demo-var-rg. And if you see here, we are having a public IP name dev-pip, prod-pip, and qa-pip. And all these three names are more relevant if you compare with mypip0, mypip1, and mypip2. So with this, we have completed this demo. So thanks a lot. Hi everyone. In this video, we are going to discuss about the for each loop. In the last video, we had a very detailed discussion regarding the count loop and its challenges. So we are good to implement the for each loop in map data type as well as in list data type. The implementation of the map data type is straightforward, while in the case of list data type, we have to use a function named called as toSet. Okay. So the first demo it would be on map data type and the second demo it would be on list data type. So let's start. I'm going to create a dedicated folder with a name called as map underscore data underscore type underscore demo. And yeah, I'm going to create a file name called as main.tf and providers.tf and variables.tf. So in the main.tf, I'm going to copy paste regarding our resource block configuration. So in this example, what we have to use? We have to use a for each loop. So what I'm going to mention? I'm going to mention for underscore each is equal to var dot my variable name. So I'm going to create a variable name called as rg underscore details, and this variable, the type will be as map, and the value which I'm going to pass it as default is equal to, as we do have discussed, the map will have key and values. So for my dev environment, I want the resource to be created inside east-us, while in the case of prod, I want to use west-us. Okay. So what is the end goal of this resource? Like we are having rg underscore details as a variable, and we have mentioned in the left side the key and the right hand side the value. And parallelly, for each is equal to call this one, we have to mention the variable name rg underscore details, and to call the key be each dot key, and to call the value which will be our location, it would be each dot value. So when we are going to run this one, it is going to run for 2 times. The left hand side is our key and the right hand side is our value. So for the first time run, the key will be dev and the value will be east-us. And for the second time run, the key will be prod and the value will be west-us. Okay. Let me quickly update the providers block. So I have updated the provider block, and let me move this variable file to here. I'm going to run command called Terraform init. To save the time, I'm going to directly run Terraform apply. If you see here, it is going to call the value 2 times. One it is for dev and another one it would be prod. And these are keys. While in the case of count, it was using an index value. So for initial run, it was using 0. For the second run, it was using 1. But in this case, all the values are getting called by its key. Okay. and I'm going to type yes. So what we have done, we have created a two resource group name as dev, which would be created in east and the production prod resource group created in west. So let me quickly verify inside our portal.azure.com. If you see here, we are having dev, which is created inside east, and prod, which is created inside our west. So as we do have discussed initially, the first demo is regarding the map data type, and the second demo, it would be on list underscore data underscore type underscore demo. Okay. Again, I will create a file name called as main.tf. Then we are going to have our providers.tf and variables.tf. So what I will do, I will quickly copy paste the providers configuration from this project to this project. While in the case of main, I will create a resource group. So in this case, what we have to do, we have to use a list data type. So we are going to create a variable with a name called rg underscore details. There's one typo. Variable rg underscore details. I'm going to mention type is equal to list. And here in default, I'm going to pass a list which will only consist of the environment name. I would say dev, comma, prod, comma. Okay. So to call this value, what I'm going to mention here, it would be for underscore each is equal to, I'm going to mention toSet function, and inside the function, I'm going to pass var dot rg underscore details. Okay. And to call here, I'm going to mention each dot key, and the location, I'm going to make it consistent as West Europe, or if you want, you're good to mention it as East US. Okay. Let me copy the path and run Terraform init. Meanwhile, update this. Okay, I'm going to run Terraform apply. It is asking, it is mentioning a duplicate variable declaration. Let me quickly check. Okay, seems like I haven't saved it. Let me run this command again. So what it is going to do, so the main functionality of toSet function is to convert this value into a set of string. If you see here, we are having the first block with a name called dev, second one is called prod, and the third one is active, and each and every and the value of the name is updated through key. Okay, so here if you want to mention it as value also, each dot value, that also be fine. Let me run Terraform apply. See, yes, if you see here, we have mentioned the value also, but we are getting the same because we are having a list of string as an input. See, we are getting an error. So why are we getting an error? Because in the last example, we have created the resource group with the same name. So let me quickly update the variable value. I would say dev1 prod1. Okay. mention it as auto hyphen approve. So let me quickly cross check inside our portal, and it is showing our dev1, prod1 and test in the same location, east US and east US. Okay. So let me quickly conclude what we have discussed. So for each loop, we are good to use in map data type as well as in list data type. While in the case of map data type, it is a straightforward implementation. While in the case of list data type, we have to use a function which name called as toSet. So what is the main functionality of toSet function? To convert the value into a set of string. Okay. So in the next video, we are going to discuss more about the Terraform function. Hi everyone, in this video we are going to discuss about the Terraform function. So Terraform only support built-in function. So what does it mean? It means we are not good to write our own customized function. So the whole function is divided into subpart. I would say numeric function, string function, collection functions, encoding functions, file system functions, date time, hash, IP network function, type conversion function, and Terraform specific function. In the last video, we had a very detailed discussion regarding the toSet function and its functionality to convert a list value into a set of string. So in this video, we are going to discuss about the three function. One, it is called as lookup function. The second one, it is called as element function. And the third one, which we are going to discuss about the zipmap function. Okay, so let's start the demo for it. I have created a file name called as main.tf. So if you see the whole code from line number 1 to 13, it is a provider configuration. And if you see from line number 23 to 26, what we are doing, we are creating a resource group with a name called IaC. In the location, we have used a function name called as lookup function. The first value which we are passing, it is map. The second value which we are passing, it is the key. And this value which we are passing, it is a default value. So what it is going to happen if we are going to run this code, so it will check this key is present inside this map data type or not. If the key is present inside the map data type, it will fetch the value. So the value, it would be east US. Okay, and finally our location, it would be east US. While in the second case, if we are going to update it from dev to, I would say, dr, okay, again the same thing will happen. The key is going to be searched inside our variable, which is a map data type. Then it is going to say like, hey, the dr is not present here. So in that case, the value which is going to pass for the location, it would be central India. So what does it mean? It means at any cost, the location value will be passed. The first chance is to get the value from the map data type using the key. Okay. The second possibility is to get the value which is not present inside the map data type. So which value we are going to get it? We are going to get it the default value which we do have mentioned. In this case, it is a central India. Let me do a quick demo to understand this thing in detail. I have initiated Terraform in it. And what I'm going to do, I'm going to run a command called Terraform plan. If you see here, what we have mentioned in name, myrg. So the value is coming as myrg. But in the case of location, the value is coming as east US. So how the value is coming? So initially we have passed the var.rg details, which is a map data type, and we have passed the key. If you see the key dev, the value is east US. So automatically the value east US is coming. So let me quickly update the key from dev to dr.
And if you see here, the dr value is not present inside our key. So the value it would come in location, it would be Central India. Let me do a Terraform plan. If you see here, the location is Central India. Why it is happening? Because in the map data type, we do not have the key name called dr. That's why the default value is coming in location value. So what is the main functionality of lookup function? The main functionality of the lookup function is to get the value from the user. If the user is not passing the value, then in that case, automatically the default value will be assigned. And it is used in map data type. Element function. Element function is generally used with the list data type. If you see from line number 1 to 14, we have mentioned about our provider block, and in the line from line number 24 to 27, we have mentioned about our creation of the resource group. In the name, we have mentioned is equal to element var.rg underscore name comma 0, and while in the case of location, what we do have mentioned var.rg underscore location comma 0, and for rg name and the rg underscore location, we have mentioned a data type name called as list. So what the element function is going to do here, we have mentioned index value as 0, so it will fetch the value from the rg underscore name. It would be equal to test, while in the case of location, it would be East US. Okay. If you are going to update the value from 0 to 1 index here in terms of name and location, so the value which is going to fetch in name, it would be our dev, and in location, it would be our West US. Okay. Let me quickly do a quick demo to understand it. The If you see here, the location, it is coming as East US and the name is at test. So why it is coming as East US and the name is at test? Because the index value is at 0. Okay. If I'm going to update the index value from 0 to 1, let's see what will be the output. Terraform plan again. So in the output, we are getting location as West US and the name as dev, because we do have mentioned the index value as name 1 and name 1e here. Okay. So in the next video, we are going to discuss about the zip map function. So hi everyone, in this video, we are going to discuss about this splat expression. I have created a file name called as providers.tf. As I'm using the version 4, that's why I have updated the subscription ID. In main.tf, I have mentioned two resource block, one for creating my resource group and another for public IP. I'm using count is equal to 4 for my 4 public IP. So eventually what it is going to do, it is going to create a 4 public IP for me. Okay. So let me firstly run this configuration to create the 4 public IP. So the first command I'm going to run terraform init, and then I'm going to run terraform apply hyphen auto hyphen approve to save the time. If you see here, we have created the 5 resource. Let me quickly check inside the port. See, we have created a resource group name called as demo-rg, and in demo-rg, we are having our 4 public IP. So what is the next requirement? So what is the requirement? The requirement is to print the IP address of 4 public IP where on my CMT. To, to achieve this, we have discussed about the output. So I'm going to write the output block to print the IP address in terminal. Okay. It would be Azure RM public IP
dot example, and what we want in this one, we want the IP underscore address. Okay, this is what we have discussed till now. So let's run and check, are we able to see the public IP address on our terminal or not. If you see here, we are getting an error. So what is the exact error? The error is missing resource instance key, and it is giving some suggestions also. So what exactly we have done till now? We have created one resource group and four public IP, which means this resource block was uh, ran for 4 times. Okay, I can show you. If you see on the right hand side, the time it ran for the first time it ran for prod PIP, then for dev, then for I would say test, and finally for our QA PIP. So if we are mentioning here Azure RM underscore public underscore IP dot example dot IP address, then this output block is getting confused. We are calling for which index. To troubleshoot this kind of scenario, when we are using loop inside the resource block and there are n number of resources present, so to call the values for all the resources, what we have to use the splat expression. So what would be the syntax? I'm going to update here in square bracket with a star, and then I'm going to run this code again and to check, are we able to see the IP address or not in our terminal. Let's see. See, we are able to see the public IP address on our terminal. Okay, so this is the basic functionality of the splat expression to use inside the resource block where we are using loop. So with this, we do have completed the splat expression demo. Hi everyone, in this video, we are going to discuss about the zipmap function. So what is the main functionality of the zipmap function? Is to create a map. So how this map is going to be created? The map is going to be created from two things. First, it would be list of keys, and the second one, it would be list of values. Okay, let's take example. We are creating three public IP. Okay, and the name of the public IP, it would be dev public IP, QA public IP, and prod public IP. So once we are going to create three public IP, we want to see the IP address also. So in that case, what we have to do, either we have to log in inside our portal to see the public IP address of all this public IP, or else we are good to output the value of the public IP address. Okay. So whatever the public IP address we are having for dev PIP, we want to see whatever the public IP address for QA for QA PIP we want to see, and the same one for the prod. And eventually what we are going to have, we are going to have a map. So to have this kind of output, we need to use zipmap function. Let me do a quick demo to understand this thing in detail. So what I have done till now, I have created a main.tf file. If you see from line number 1 to 14, we have the provider configuration. On line number 16 to 19, we are creating a resource group. And from line number 20 to 26, we are creating a public IP. And how many public IP we are creating? We are creating 4 public IP. And each of the public IP from where we are getting a name, we have created a variable mypip with a type called list, and here we do have mentioned prod pip, dev pip, test pip, and QA pip.
Okay, let me firstly comment it out line number 32 to 35 and run the code. Terraform init, and to save the time I'm going to directly run Terraform apply hyphen auto hyphen approve. Auto hyphen approve. So it is going to create 5 of the resources. 4 it would be our public IP and 1 it would be our resource group name. So what we have done, what we have done till now, we have created our 4 public IP and plus 1 resource group. So if we want to see like what is the public IP address for prod PIP, for dev PIP, test PIP and QA PIP, we have to log in inside the portal.azure.com to see the public IP address, or else we are good to output the value using output block. Let me firstly write output block for the public IP address. So here what I'm going to mention, I'm going to mention output, the name it would be public IP underscore address, and the value it would be Azure RM dot public IP dot example. Here in a square bracket I'm going to mention a star dot what I want IP underscore address, and I'm going to run this command again, Terraform apply hyphen auto hyphen approve. We are having 4 IP address present, but we don't know which IP is allocated to prod PIP, dep PIP, test PIP and QA PIP. So let me quickly write one more output block for the IP name. What I'm going to write it here, output public IP underscore name value is equal to, I have mentioned Azure RM public underscore IP dot example and square the star dot name. And let me run the command again, Terraform apply hyphen auto hyphen approve. If you see here, we are having two output. One it is for our public IP address, and the another one is a public IP name. Still, we don't know what is QA PIP public IP, what is the test, dev, and prod PIP. So in this case, we are having list one and we are having list two. So we need to create one map which will have what, one key is equal to value format. The key, I would say our PIP underscore name, and the value it would be PIP underscore address. So to use this functionality, we have to use one function which is called as zip map. If you see in the left hand side what I have written, let me firstly uncomment it. If you see, the name of the output block is output IPs, the Azure RM pub underscore public underscore IP dot example dot name. It is this one, the public IP one, comma, the Azure RM underscore public underscore IP dot example dot IP address. Let me scroll to right to show you, is IP address. And we have passed this one inside our zipmap function. You see, we have mentioned zipmap function and we have passed both the values. So let me quickly run Terraform apply to show the output. If you see here, what we are having map this IP's name. The left hand side is having what? Our public IP name, and the right hand side we are having public IP underscore address. So using a zip map, we are good to create a map from the list of keys and list of values. Hi everyone, in this video I'm going to discuss about the dynamic block. So let's firstly implement the things without the dynamic block. So the requirement is we need to create one network security group, and in this network security group we are going to have 5 rules. Okay, in the 5 rules, 4 rules it is for inbound and 1 rule it would be for outbound. Okay, to implement this thing, what we are going to do, we are going to write one resource block, and inside the resource block we are going to write 5 times our security rule, and we are going to update each and every security rule with their inbound or outbound configuration. So I've already created a folder name called as without underscore dynamic underscore block. In this one, I do have 2 files. One it is called main.tf, another one is called providers.tf. In main.tf, if you see the first resource block we are having for creating our resource group, its name is without hyphen dynamic hyphen block hyphen rg. And the second resource block we are having for our network security group. And here we are creating a 5 security rule. So we have mentioned 5 times the security rule. So the first one is for inbound, the second one is for outbound, and all other 3 rules are for inbound only. Let me quickly implement this code. So I'm going to run Terraform init. Then the second thing which I'm going to run, Terraform apply. See, our 2 resources are going to be created. One it is my resource group, and the second one is my network security group. And inside the network security group, we are having around 5 security rules. One it is for my test 1 2 3. The second one it is for my allow HTTPS. The third one is for allow HTTP. Fourth one is for deny all, and the fifth one is for test 456. Okay, so I'm going to type yes and press enter. See, our 2 of the resources has been created. Let me quickly check inside the portal. So I'm going to click on resource group. See, our resource group has been created without hyphen dynamic hyphen block hyphen rg. We are having our NSG. Inside this NSG, if you see, we are having inbound security rules. I would say 4 security rules are there, and we are having outbound security rules. If you see here, what we have done, we have created 5 security rule. So for 5 security rule, what we have done, we have mentioned 5 security rule 5 times. In real time scenario, if you need to create 100 security rule, so is this a good idea to write the security rules for 100 times? No. So to implement this one, what we have dynamic block. So what we have implemented for dynamic block, the first one is providers.tf and the second one is main.tf. In main.tf, the first resource block is responsible for creating my resource group. The second resource block is responsible for creating my NSG. If you see here, what we have done, we have not mentioned the security rule n number of times. Instead of it, we have mentioned dynamic. And after the dynamic keyword, we have mentioned the security underscore rules. Then we have mentioned for underscore each is equal to var dot security rule. With this name security underscore rules, we have created a variable. Let me open the variables files also. So I have created a variable with a name called security underscore rules, and the type is list of object. And then if you see, we have mentioned content, and under the content we have passed all the required attributes. And here is the data type for about each and every attribute. For the first time, what we have this value. So for this value, it is going to create test 1 2 3, the name of my secure, the name of my security rule, and then it is going to run one. So one dynamic block created. Then for the second value, what we are having, the second value is test 456. So it is going to run for the whole thing for the second time.
And then I would say whatever the other values we have passed, the another block, it is going to run for this one, then for fourth time for this one, and finally the fifth time for this one. In future, if you want to add more security rule, what you have to do, you have to just update in our variables.ts. So let me run the configuration for it. I'll say run Terraform in it. Then I will run Terraform apply. See, two of the resources are going to be created. One it is for my resource group and the first one it is for my NSC. And here we are having n number of security rule. So we have mentioned the 5 security rules. So this one is going to run for the 5 times. I'm going to type yes and enter. See, our two resources has been created. Let me check in the portal. Let me refresh it. If you see here, our resource group has been created with a name called with hyphen dynamic hyphen block hyphen RG. And we are having this NSC. What we have done, we have created 4 inbound rule and 1 outbound rule. What is the end result? The end result, I would say, from the Azure end, it would be same. Code like our NSC has been created with the 5 rules. One, 4 is for inbound and one it is for outbound. But in terms of implementation, in real time scenario, if you need to manage 100 of security rules, then dynamic blocks are more efficient in comparison of writing the security rule for 100 times. That's why it is recommended to use dynamic block rather than passing the value using security rule. Okay. Hello everyone. In this video, I'm going to discuss about the Terraform import command. So the importance of Terraform import. Let's take a scenario to understand it. Let's say you have an organization that has been managing its cloud infrastructure manually. Recently, your company has decided to adopt Terraform for better management and automation of infrastructure. You have existing resources such as virtual network, a subnet, a virtual machine, and public IP in Azure, and you want to start managing these resources using Terraform. So, what is the exact scenario? I would say this is an organization name called as ABC are using Azure and they have deployed n number of resources inside the Azure. To implement the IaC, they have finally selected Terraform. As I do have mentioned, they do have n resources present inside the Azure. So how they are going to manage the existing resource which has been created manually from Terraform part. So we are good to use Terraform import command to bring manually created resource under Terraform's management without needing to recreate them. So in Terraform, we do have one functionality of import which can help us to manage all the existing resources which are created manually using Terraform import command. And in this command, we do not need to recreate the resource. What is the exact meaning of recreate? Recreate means we don't need to delete these resources and then again we need to create with Terraform. This approach is not required. Directly, we are good to create the state file of all these resources using Terraform import command. So, older approach. In older approach, Terraform import would create the state file associated with the resources running in your environment. The steps are we have to write the resource block. I would say I want to import one resource group. Okay. So for this resource group, I have to write a resource block inside my .terraform file. Okay. This is one of the requirement. Then we need to run Terraform in it. Finally, we need to run Terraform import command to create a state file. The first thing which we need to do, we need to write a resource block for all our resources. The second thing which we need to do, we need to run Terraform init command. And the third thing which we have to do, we have to run Terraform import command. The syntax is we have to write Terraform, then import the resource global name, then the local name, and finally the resource ID. So this is the older approach we need to follow for Terraform import configuration. Terraform 1.5 introduces automatic code generation for imported resources. This helps to reduce the amount of time you need to spend writing your code to match the imported. In this approach, Terraform import can automatically create the Terraform configuration file for the resources you want to import. So in the older approach, the first thing which we need to do, we need to write the resource block. Okay, I would say for around 10 resources, if you want to create a state file, you have to write the resource block for it. The second thing which you have to mention, it is our Terraform init command. Okay, and the third thing which you have to run Terraform import command with a resource block name, global name and local name, and finally the resource ID. But in the newer approach, what we have to do, we have to only run this command apart from the provider configuration. If you see, if I want to import the resource group, I have to mention the global name, which is Azure RM underscore resource underscore group, then the local name, and finally we need to mention the ID. This line, it is all about the provider configuration. We do not need to write any resource block in our newer approach. The below commands we need to run. The first command, it is Terraform init. As we do have mentioned, it is generally required for the provider configuration. Second command which we need to run, Terraform plan hyphen generate hyphen config hyphen out is equal to file name where we want to save our resource block configuration detail. Okay, so whenever we are going to run this command, it will create a .tf file with a name called demo.tf, and inside the demo.tf it will have all the details regarding the resource block. If you see here, after running this Terraform plan, it has automatically created the resource block. In resource block, whatever the local name we have mentioned into, it has created inside my .rg .tf file, and it has automatically updated location managed by name and tags value. Okay, and once we are going to run Terraform apply hyphen auto hyphen approve, it is going to create my state. So the main advantage we are having after one Terraform 1.5 version, we only need to write this two line of code to import any resource, whatever the resource global name it is, and then the resource ID. And when we are going to run Terraform plan, automatically a TF file will be created and the resource block will be updated. And when we are going to run Terraform apply hyphen auto hyphen approve, a state file will be created for us. Okay. So in the next video, we are going to do a detailed demo to understand these things in detail. So thanks a lot for watching the video. Hello everyone, in this video I'm going to do a demo on Terraform import command. So firstly we are going to discuss about the old approach, and then in the next video I'm going to discuss about the newer approach. Okay, so the first thing which we need to create is our storage account, and this storage account will be created by using manual approach. And once this storage account is created, I'm going to write a resource block for it. Okay, and once this resource block is written, the third thing which I'm going to do, I'm going to run Terraform init command. And fourth, I'm going to run Terraform import. Okay, so let's start the demo. Create a storage account, mention the resource group name as Terraform hyphen import hyphen demo hyphen rg. Then I'm going to mention tf import strg. And the location I'm going to mention here, South India. I'll mention here LRS only. It is for demo purpose. We don't need to change anything. So the storage account deployment in progress. So what is our next step? The next thing which we have to do to create a resource block. So I'm going to search for a storage account, and then I'm going to select the Azure RM underscore storage underscore account, and we'll copy this configuration. And here I have already created a dedicated folder name called as old underscore approach. Here I will mention main.tf, and we'll paste the configuration, and our storage account has been created. So let me copy the resource group name and the location which I have mentioned, South India, and our storage account name is tf import storage, and we have account replication type LRS, and we haven't updated anything with tag, so let me remove it. Okay, so we are done with the step 2. The step which we need to do is Terraform init. Let me copy the path. I'm going to type Terraform init. So Terraform init completed. And the final step is Terraform import command. So for Terraform import command, as I do have mentioned, we need to copy the resource ID. But in Terraform import command is not as usual as our Terraform plan. So in each and every documentation, if you scroll to the bottom, you will see one options of import. A storage account can be imported using resource ID. So let me copy it, and I'm going to paste it here. And then I'm going to copy the resource ID. Okay. So if you want to import any resource, what we have to do, we have to go to the Terraform documentation, and at the bottom, you will get a command for it. It is Terraform import, whatever the global name it is, and then the local name. Okay. And this is the resource ID. Here, our local name is example. So I'm going to update it here, and then I'll remove it. If you see, we are having our main.tf, which we have created for our resource group and storage account import part. Then after running Terraform init, we are having our .terraform folder and .terraform log.scl. So here I'm going to run this command, and let's see, is it the state file is created or not. So I'm going to run Terraform import command. See, we got a message import successful. The resource that were imported are shown above. These resources are now in your Terraform state and will henceforth be managed by Terraform. If you see here, finally our state file has been created, and this state file has a detailed information about both the resources, our resource group, and our storage account. Okay, so in the next video I'm going to do a demo on our newer approach. Okay, so thanks a lot for watching the video. Everyone, in this video we are going to discuss about the newer approach of Terraform import command, which is applicable after Terraform 1.5 version. Okay, so we have already created a storage account, so it is not required. The second step we have done, writing the resource block. This step is not required in the new approach. In the new approach, we are good to run Terraform init. And then in terms of import, this part is also not applicable. We need to run Terraform plan, and this Terraform plan will create the resource block for us. And then finally, the Terraform apply. Okay. So let's start our demo. So I'm going to mention a file name called as main.tf, and in main.tf, what we have to mention, we have to mention import. So what is my resource name? It is Azure RM underscore storage underscore account. I would mention example here. Okay. And then what is the ID? ID of this storage account is, okay. And finally, one block for our provider configuration. Copy the path, mention CD. And the first command we need to run Terraform init for the initialization purpose. The next command which we need to run. So in the newer approach, we have to mention Terraform, then plan and hyphen generate, then hyphen config, hyphen out is equal to the place where I want my resource block Terraform file. So I'll copy this path and I'll paste it. And what would be my file name? I'll mention here as demo dot, or I would say storage.tf. If you see here, we are currently having main.tf and providers.tf and .terraform and .terraform log.scl. We are not having any file which contains information about the resource block. Okay, let me press enter. If you see here, we are getting an error. So what is the error? Failed to create target generated file. The system cannot find the mentioned path. Okay, what is the exact issue? I have copied the path, and in the path, what is the mistake I have done? I have mentioned here providers.tf. Okay, the providers.tf should not be there. It should be inside the new approach. So let me update the path and rerun this code again. See, it is saying 1 to import, 0 to add, 0 to change, and 0 to destroy. And it has created storage.tf, and this storage.tf is generated by Terraform. Please review this resource and move them item into your main configuration file. And it is clearly mentioned generated by Terraform from whatever the resource ID we have mentioned. And it has a detailed information about each and every attributes of our storage account. So when we initiated the Terraform plan command, what it has done, it has created a resource block. But in the older approach, we used to create this resource block and it was really tedious task to do it. Okay. So let me run the Terraform apply. To save the time, I mentioned auto hyphen approve. Resources 1 imported, 0 added, 0 changed, 0 destroyed. If you see, finally we are having our state file, and this state file we have created by using the newer approach. If you compare with the older approach and the newer approach is more simplified. Here we do not need to write a resource block. We only need to use the import block, and within an import block we only need to mention the resource global name and the local name and the resource underscore id. Okay, and in terms of running a command, we do not need to run, I would say, Terraform import command, which I have showed you in official documentation with the unique ID. What we have to run, we have to run Terraform plan command with the hyphen generate hyphen config and with a path where we want to create our Terraform configuration, and then finally the Terraform apply. Terraform plan command will create a TF file which has all the resource block present, while in the case of the Terraform apply, it is going to create our state file. Okay, so with this we have completed the import functionality. So thanks a lot for watching the video. Thank you. Hi everyone, in this video I'm going to discuss about the Terraform provisioners. End-to-end infrastructure deployment with Terraform. Till now, we have been working only on creation and destruction of infrastructure scenario. So what is the exact meaning of it? So from the day one, what we have discussed is creating the resources, okay? And the second thing which we do have discussed like deleting the resources. So these are the two things which we do have discussed till now. Let's take an example. We want to create a virtual machine and install web server in it with Terraform. What is the exact problem? It is only a virtual machine. It does not have any software installed. What if we want to complete end-to-end solution? So in the last video, we discussed about the creation of virtual machine. After the creation of virtual machine, we want to install some set of software, I would say web server. Configuration management part, how we are going to achieve it. So, understanding the provisioners. Provisioners are used to execute scripts on a local or remote machine as a part of resource creation or destruction. Let's take an example. On creation of instance, execute a script which install Nginx web server. The same thing which we do have discussed in the last video, like creation of the virtual machine and then installing some set of software into it. Terraform has capability to turn provisioners both at the time of creation as well as destruction. So in this video, we are going to discuss only about the creation process. In the upcoming videos, we'll discuss about the destruction process. Basically, there are three main type of provisioners: local exec provisioners, remote exec provisioners, and the file provisioners. Local exec provisioners. Local exec provisioners allow us to invoke local executable after resource is created. What is the use case? After the VM is created, this provisioner run a command to write the virtual machine public IP address to a file name called myip.txt. So, what is the first thing we are going to mention here? The provisioner, then the type of provisioners, and then here we need to pass the command. Here we are passing the global name of Azure RM underscore public underscore IP dot local name, and what we want a IP address. So once we are going to run the Terraform plan and apply, it is going to create a file name called as myip.txt, and in this myip.txt will have our public IP configuration. So this is the basic functionality of local exec provisioners. Once the virtual machine is going to be created, it is going to fetch the data of the public IP and going to store inside the file name, I would say myip.txt. And this myip.txt will be stored in our local machine. Remote exec provisioners allow us to invoke scripts directly on the remote server. It is useful for tasks that need to be executed after the server is created. Let's take example. Once you create a virtual machine, you want to install Nginx and start the Nginx server. So this is the first thing which we do have discussed in the slide one. Like we have created a virtual machine, and once this virtual machine has been created, we want to install some set of software. To achieve this part, we are going to use remote exec provisioners. And this is also called configuration management things. Like once the infrastructure created, what we are doing, we are creating the configuration for it. So what would be the first step? The first step, it would be like provisioners we have to mention, then the type of provisioners, it is remote hyphen exec. So the whole process is divided into two steps. The first one is regarding the connection and second one is regarding the inline command. So in connection is basically responsible after the virtual machine is created, it is going to connect with my virtual machine. To achieve this thing, it is going to use SSH because we are using Linux virtual machine in this example. While in the case of Windows, we need to mention Windows 1. User, password and host. So user will consist of the admin underscore username, password will consist the admin underscore password, and the host, it would be the public IP address. And self is a keyword which is used to mention to fetch the values from the current Terraform configuration. So wherever it is mentioned admin underscore username, the value will come. Why? Because we do have mentioned self keyword. The second part, it is inline. Here, the first command, it is going to update our operating system. Once it is updated, it is going to install Nginx on it. And after the Nginx installation, it is going to start the Nginx service. Okay. The third provisioner is file provisioners. File provisioners is a tool used to copy files or directories from the local machine to a remote server. Let's take an example. Once you create a virtual machine, you want to copy the files. So we do have created virtual machine. We do not need to do any kind of configuration changes in terms of like installing some set of software. Instead, what we want, we do have some set of files which we want to copy it from our local machine to the remote machine, which is eventually our virtual machine. So for this one, we do have the file provisioners. So it consists of the two things. Again, the first part, it is regarding our connection. So it is a Linux machine. So that's why it is mentioned SSH. And then again, the username, password, and the host. And the self is a keyword which is going to fetch the value for admin username, again for password and the public IP address. And the second thing, it would be like the source and the destination. Source part to the local script file. So this is the script file which need to be copied from my local machine, while destination /tmp /script.sh. So in this location in my virtual machine, this file will be copied. Okay. So in the upcoming video, I'm going to give a demo on all these provisioners like local provisioners, remote provisioners, and file provisioners. Hi everyone, in this video I'm going to do a quick demo on local exec provisioner. So what I have done till now, I have created a file name called as providers.tf to save our provider configuration, and then we are having our main.tf. So in the main.tf, what we are going to do, we are going to create one resource group named as Kumar RG underscore local underscore demo. And in this one, we are going to have our virtual network, then subnet, and then we are going to have our public IP and then network interface card. And finally, we are going to have our Azure RM Linux virtual machine configuration. Okay. So once this virtual machine has been created, what to do the next step? It is going to call this local exec provisioners. And in this local exec provisioner, it is going to call this value name called as Azure RM underscore public underscore IP dot example dot IP address. And whatever the value, I would say the public IP, it is going to save inside the myip.txt, and the location of myip.txt, it would be in our local machine. Okay. So let me firstly copy the path and implement the changes. So the first command I'm going to run called as Terraform init. Just to save the time, I'm directly going to run Terraform apply -auto -approve. So it is going to create the 6 resources: our virtual network, subnet, resource group, public IP, and NIC card, and our Linux virtual machine. So the resource group creation process started. Created, and once my virtual machine created, then my local exec part started. So in local exec, what we do have mentioned, it is going to save this public IP in the file name called myip.txt. And if you see here, we do have our file name called as myip.txt. And let me myip, and here we are able to see our public IP. And if you're going to just, if you're going to do a quick comparison from portal, let me refresh it. And let me click on this public IP, and this is the address which we are having: 20.235.113.132. And if you see here, we are having the same IP. What we have done, so firstly, our virtual machine has been created, and once this virtual machine created, it has executed local exec provisioners, and in the local exec provisioners, it has fetched the public IP, and then it has been saved inside myip.txt. So this is the main functionality of local exec provisioners. It will save the data inside our local machine. Hi everyone, in this video we are going to do a demo on remote exec provisioner. So I have created a two file. First is called providers.tf, where we do have provider configuration, and the second one is main.tf. So in the main.tf, we are having n number of resource block. So what is the main purpose of this remote exec provisioners? Once this virtual machine is created, what we have to do, we need to add some set of software, or I would say in general, the configuration part. Okay, so this resource block is responsible for creating the RG, then our virtual network, then subnet, public IP, NIC, and the last one is for our Linux virtual machine. If you see inside this Azure RM Linux virtual machine, what we do have mentioned, we have mentioned remote exec provisioners. And for the connection part, we have mentioned the type SSH because it is a Linux virtual machine, and username, password, and host. And we have mentioned the self keyword because it is going to find the admin username, password, and public IP address within this Terraform file configuration only. Okay. Once our virtual machine is created, it is going to make this connections, and after the connection created, the second thing it would be running this set of commands. The first thing it would be update our operating system, then install the nginx, and the third one is to start the nginx server. Okay, let me quickly run the terraform init and apply to initiate the implementation. I've typed a command terraform init. There's one typo. I'm going to run command called terraform apply hyphen auto hyphen approve to save the time. So six of the resources are going to be created, which includes our virtual network, subnet, resource group, public IP, NIC card, and our Linux virtual machine configuration. If you see here, I would say the six resources created, and parallelly what we are having, the remote exec part also completed. So what does it mean? Firstly, the virtual machine created. When I'm mentioning virtual machine, it would include all the component. I would say the resource group, the virtual network, the subnet, the NIC card, the public IP, and the Linux virtual machine configuration. And once this part is completed, the second phase is all about the configuration part, or I would say the remote exec provisioner part. Then the first thing it would be in connection, and the second one it would be our running all this command. Let me show you inside the CMD. If you see here, the first thing which has been completed, our virtual machine creation part, and then our the connection happened. So the first thing it is connecting to remote host via SSH, and the first thing it is the use IP address, the username, and the password. Okay, and we have disabled this certificate, the private key configuration. That's why it is showing false. Once this connection part completed, it is showing connected. Then the next stage is all about running all this command. So throughout this step, whatever the things you are able to see on terminal, it is regarding the implementation of this inline command. The first, the update of the software, then installation, and then starting it. So what I'm going to do, I'm going to log in inside this virtual machine, and then I will check whether this software has been installed or not. So the public IP is this one. I will just click on putty, open. The username is admin user. I'm good to mention it. And here we do have mentioned the password configuration. Okay, so it has been connected to the Linux virtual machine. I'm going to run a command called system ctl status nginx and see the nginx service in active stage. So what does it mean? It means that once this virtual machine was created, then the connection happened, and once it is connected, the third thing happened. It is regarding the installation of our nginx. Once this nginx was installed, it has been active. So this is a perfect example of remote exec provisioners where we have created our virtual machine and we have done some configuration changes. Hi everyone, in this video I'm going to do a quick demo on file provisioner. So what is the main functionality of the file provisioners? Once this virtual machine is created, we need to copy the file from our local machine to again the virtual machine. So this is the configuration which we need to follow for the file provisioner. The first thing again, it would be the connection which we need to establish between our local machine to virtual machine, and the second thing it would be we need to mention the source and the destination. So in this demo I have created a three file. The first file, it is all about the main.tf. In main.tf, again the same thing I'm doing. We are going to create the six resources which includes all the configuration like our resource group, virtual network, subnet, public IP, NIC card, and our Linux virtual machine configuration. And in providers.tf, I have mentioned regarding the provider configuration, and script.sh, it is a file which is going to be copied from our local machine to the remote virtual machine. Uh, As we do have discussed in remote provisioner, the first thing which we need to do is regarding the connection and the type of connection. It depends upon what kind of operating system we are using, and the three things required: the username, password, and the host, which means the public IP. And self is a keyword which we need to mention to fetch the values from the Terraform configuration. Okay, let me quickly run the Terraform init. I'm going to run a command called Terraform apply -auto -approve to save the time. Our resource has been created, and if you see here, once the resource created, our provisioner part initiated. Let me quickly see inside here. The virtual machine creation process is started, it has been completed, then provisioning with file, and then the creation complete after 49 seconds. So it means whatever the file content we are having like script.sh, it has been copied to this path. Let me quickly log in inside this virtual machine and cross check it. So we do have this public IP. I'm going to copy it, mention in putty, then our username and the password part. Okay, and directly I'm going to cd on this specific path. And if you see here, we are having a file name called as script.sh. Let me script.sh, and here we are having and the content of the file is this is a demo for file provisioners. Okay, and if you see here also, it is the same thing. So this is the perfect example of file provisioners where we have created our virtual machine, and once the virtual machine is created, copied the file from our local machine to virtual machine. The first thing is regarding the connection, and the second thing is like copy the file from the source to destination. Okay. Hi everyone, in this video we are going to discuss about the Terraform Taint. Overview of Taint. You have created a new resource via Terraform. Let's take an example. You have created a virtual machine and user have made a lot of manual changes, both infrastructure and inside the server. So from portal, I would say they have done n number of changes in virtual machine in terms of its configurations and also from the part of NSG and the other rules. Two ways to deal with this: import the changes to Terraform and delete and recreate the resource. To import the changes into Terraform, we are going to discuss in our upcoming videos. Delete and create the resources. This one we are going to discuss in this video. Taint. So what is the exact meaning of taint? The Terraform taint command manually marks a Terraform managed resource as tainted, forcing it to be destroyed and recreated on the next apply. Let's take example. We have created one resource group, then our VNet, then our I would say subnet, then the NIC card. then the public IP, and finally our virtual machine. Okay, so out of this six resources, user have made n number of changes from virtual machine, I would say through manual approach. We want to undo it. So what are the options we do have? So in the last slide we discussed about the import option, which we are going to discuss in our upcoming videos, and the second option which we do have called Taint. So Taint will do what? Taint will firstly delete the resources and create the resources. So how to taint the resource? The, to taint a resource, the command is terraform taint resource type dot local name. So the command it would be for our virtual machine terraform taint azure rm underscore linux underscore virtual machine dot demo underscore virtual machine. This command will not modify infrastructure, but it does modify the state file in order to make the resource as tainted. So once this command is initiated, it is going to update my state file and will change the status of this resource to be as tainted. And once a resource is marked as tainted, the next plan we have tainted this resource, and next time when we are going to run terraform plan, it will show the two things. One, it would be delete, and the another one is to create the resources. And the third time when we are going to apply, it will delete the resource and create it. So in the next video we are going to do a demo on. Hello everyone, in this video I'm going to do a quick demo on Terraform Taint. So what I have created till now, I have created a file name called as providers.tf, which do have provider configuration, and then I am having main.tf. In the main.tf, the same thing I'm going to do, like to create a virtual machine, and then parallelly I'm creating the virtual network subnet, public IP, NIC, and the Linux virtual machine. Okay, let me copy the path and run the command for it. So the next thing I'm going to do, to run terraform apply hyphen auto hyphen approve. So once all these six resources created, what would be my next step? I'm going to implement the tent command. So for the tent implementation, we already discussed in detail. Like the first thing which I have to do, I have to tent the resource. Okay, and once the resource is tented, if I'm going to run terraform plan, what it is going to show? It is will firstly show to destroy the virtual machine and then create the virtual machine. Okay, and one more thing, once the resource is marked as tainted, what would happen? It is not going to do anything. Our state file will be updated. In the state file, the status of this resource, it would be as tainted one only. Okay, so let me firstly create the resource, and once the resource is created, we'll follow these steps. If you see here, our all the six resource has been created. So what will be the next step? I'm going to mark the resource as tainted. So to mark the resource, any resource tainted, the first command I have to run terraform taint, then the global name of the resource dot, what is the local name of this resource is example. So I'm going to type here as example and see the resource Azure RM Linux underscore virtual underscore machine has been marked as tainted. So the first step has been done. Let me quickly check inside our state file. What is the status of this one? It is showing as tainted. Let me maximize it. If you see, the Azure RM Linux virtual machine status is tainted. If you see, for let me run Terraform plan and see what it is showing to us. If you see here, what it is showing to us, one of the resource it would be add, and one of the resource will be destroyed. So firstly, it is going to destroy the resource, whatever the virtual machine configuration we do have, and then second, it is going to add this resource. Okay. And one more thing, if I'm going to untaint the resource, Azure RM Linux virtual machine example has been successfully untainted. If I'm going to run Terraform plan, it is showing your infrastructure matches the configuration. While in terms of Terraform state file also, the status of this is not tainted. Let me quickly taint it again and run Terraform apply and type yes. See, the firstly it is going to destroy the virtual machine and then the creation process will be started. And if you see here, the resource has been deleted firstly and then it has been created. So this is the basic functionality of the taint command. To achieve the taint, what we have done, the first thing, whatever the resource we want to taint, we have tainted it using a taint command. And once the resource is tainted, the state file will be updated. Okay. And the second run, whenever we are going to run Terraform plan, it will show the resource will be firstly deleted and then it is going to be create again. And if I'm going to run the Terraform apply, the same thing it is going to happen. It will firstly delete the resource and it will create it. Okay, and there's one difference between the Terraform destroy command and Terraform taint command. The difference between the Terraform destroy and the Terraform taint is the destroy command will delete the resources while Terraform taint will firstly destroy the resources and then it will create it again. Okay, so hi everyone, in this video we are going to discuss about the provisioners behavior. Okay, so in the last video we had to have very detailed discussion. There are two types of provisioner behavior. One, it is creation time provisioner behavior, and the second one is deletion time provisioner behavior. Okay, so if we are going to create any resource, I would say our virtual machine, and then the provisioners will run. If there is any problem with the provisioner, I would say in terms of typo or the whatever the software we have mentioned, it is not able to install it. So in this case, the resource will be marked as tainted. So what is the exact meaning of taint? If any resource is marked as tainted in the next plan, it is going to show you it will be deleted and it would be created again. So to overcome this kind of issue, we do have one options in Terraform to mention on failure is equal to continue. So in this case, what it is going to happen, it will not going to give us any error regarding the provisioner. It will skip that part and our resource will not be marked as tainted. So let me quickly do a quick demo to discuss about the creation time provisioner behavior. In the next video, we are going to do a demo on destroy time provisioner behavior. If you see here, I have created a two file name called as providers.tf where we have provider configuration, then main.tf. In main.tf, there is one typo with nginx. We have mentioned one stri. So whenever we are going to initiate this one, we are going to get an error. And due to this error, the whole resource, I would say our Linux virtual machine will be marked as tainted. And in the next run, again, it will ask us to delete the resource and to create it again. Okay, so let me do this part. I have initiated a command called terraform apply -auto -approve. So let's see what we are going to get. If you see here, we are getting an error. Why we are getting this? Because our nginx, it is not able to install it. Okay. If you see from the top, firstly, it has created all the resources, all the 6 resources. And once the resource is created, it has connected to my virtual machine. And then it has initiated the process of updating the operating system, and once the operating system is updated, it will look for this nginx, but due to typo it is not able to find any software with this name, and finally it is giving us error. So in the last video what we have discussed, if provisioners is going to fail, so in this case the resource will be marked as tainted. Okay, so let me quickly check inside the state file and see whether the Linux virtual machine is marked as tainted or not. If you see here, this resource is marked as tainted. If I'm going to run again terraform apply -auto -approve, it will give me one resource to create, one to create, and one to destroy. See, we are getting a message, one to add, one to destroy, because the resource is marked as tainted. So currently we do have the two options. The first option is to rectify whatever the error we do have in this provisional. If we are going to rectify it, then automatically the virtual machine will be created and the remote exec provisioners will be created without any error. The second option which we do have to update here on failure is equal to continue. On underscore failure is equal to continue. So what we have done, we have updated on failure is equal to continue. So in this case, what it is going to happen, if there is any error inside this provisioner, it is not going to mark the resource as tainted. It will ignore whatever the error it is coming. So this is the benefit of on failure is equal to continue. If you see here, we are getting the same thing. Right now we have updated this on failure is equal to continue. Let me run it again. Our Terraform apply -auto -approve. It will ignore the nginx typo. See, we are not getting any error because we have mentioned on failure is equal to continue, and it is not able to find any package with this name. And let me quickly check inside our state file. It is marked as tainted or not. So currently the resource also is not marked as tainted. So this is the basic benefit. If we are going to mention this on underscore failure is equal to continue, it will not mark the resource as tainted, and if there is any error it will not give us any error to our terminal. So this is the benefit of creation time provisioner. Hi everyone, in this video I'm going to discuss about destroy time provisioner behavior. So by default, if you are going to delete any virtual machine, what it is going to do, it is going to delete it. Okay, but in some cases what we want to firstly execute some command inside the virtual machine, and once this command is going to be completed, then we are good to delete the virtual machine. I would say we want to firstly uninstall the nginx server, and once this nginx has been uninstalled, then we are good to delete the virtual machine. So this, to achieve this part, what we do have the option, we do have destroy time provisioner behavior. So in this case I have created two file name called as providers.tf and main.tf. In providers.tf I do have the provider configuration, and in main.tf I do have mentioned this thing, provisioner remote exec, and when is equal to destroy, the first thing the connection will be initiated, and then this inline command will be initiated. It is going to remove the nginx, and once this nginx is going to be removed, then it is going to delete the virtual machine. Okay, so to achieve this one, what we need to use, we need to use when is equal to destroy. Okay, so let me firstly I'm going to create a virtual machine, and while creation of the virtual machine, the remote exec is going to install some set of software, I would say the nginx. Then in the second stage, what I'm going to do, I'm going to delete this virtual machine. While deleting of the virtual machine, we'll see the first thing, it is going to firstly uninstall this nginx server, then the virtual machine deletion process will be started. So the first command I'm going to run, Terraform init. Then Terraform apply -auto -approve. So what it has done, it has created the 6 resource, and once the resources has been created, it has connected it using a remote provisioners, and it has installed this Nginx and start the Nginx service. So here we do have mentioned when is equal to destroy. So the first thing, again the connection will happen, and the second thing, it will remove the Nginx from our virtual machine, and then the deletion of this all these 6 resources will be initiated. So rather than deleting all the resource, what I'm going to do, I'm going to delete only virtual machine. I would say Terraform state list is a command to list all the resources inside our state file. I would say Terraform destroy hyphen target, and we want to destroy Azure RM Linux virtual machine dot example, and press enter. If you see here, it is going to destroy my virtual machine configuration. I will type yes. So the first thing it is doing, it has connected to my virtual machine using SSH, and once the connection has been happened, the second thing it is doing, it has removed the Nginx from this virtual machine, and then it has initiated the process of deleting the virtual machine. So this is the benefit of using destroy time provisioner behavior. Whenever we are going to mention when is equal to destroy and set of command, it is going to execute it before deleting our virtual machine. Okay. Hello everyone. In this video we are going to discuss about the debugging in Terraform. Overview of debugging Terraform. Let's firstly discuss what is the exact meaning of debugging. Debugging is the process of finding the root cause of a specific issue. Let's take example. We do have any challenges while running Terraform plan, and we are not able to understand what is the exact error. In that case, we need to debug the issue. To debug the issue, what is the prerequisite? The prerequisite is to have all the logs. Okay. So in Terraform has detailed logs which can be enabled by setting the tf underscore log environment variable to any value. You can set tf underscore log to one of the log You can set tf underscore log to one of the log levels. It is trace, debug, info, warning, or error to change the verbosity of the log. So what does it exactly means? As we do have discussed, if we need to debug any issue in Terraform, we need what? Logs. By default, the logs are not generated. To generate the logs, what we have to do, we have to set up an environment variable called as tf underscore log. Okay, and we do have n number of options which are trace, debug, info, warning, and error. By default, if we are going to set up the tf underscore log value as trace, so automatically it will consist the detail about the debug, information, warning, and error. If you are going to set up the tf underscore log for debug, it will have all the values for information, warning, and error. And same thing will happen for information and warning. So whenever we run our Terraform init, this is the default. So whenever we run Terraform init, so this is the default value which we are getting. But if we want to generate the logs also, so as discussed, what we have to do, we have to set the environment variable, and it is tf underscore log. And what are the value we are mentioning? We are mentioning the value trace. So it will have the information. So trace will consist debug, info, warning, and error. So after setting the environment variable with trace, when we are going to run the Terraform init, it will have info, debug, I would say trace. So, so after setting the tf underscore log value as so, so after setting the tf underscore log value with trace and we are going to run Terraform init, it will have detailed information as we do have discussed when we are going to run Terraform init from our local machine, it is going to connect with our API and then it will fetch the details and what we are going to have, we are going to have .terraform folder which will what we will have? We will have Terraform folder. What we will have? We have .terraform folder which will have all the details for the provider and then we are going to have .terraform log.scl which will have the version value. So if you go through if you go through all the logs, you will see the detailed explanation about each and every step. And these logs can be used for debugging any kind of issue. But in real time scenario, what we do not want all the log present while running our Terraform init. Instead, we want all the logs to be saved in a dedicated file. So in that case, what we have to do, we have to run a command called setx for setting the environment variable, tf underscore log underscore path, and where we want to save the logs. So in that case, all the logs will be saved inside this file and our Terraform init will be and our Terraform init will not have the logs. Okay. So thanks a lot for watching the video. In the next video, we are going to do a quick demo on the debugging in Terraform. Hi everyone. In this video, I'm going to do a quick demo on debugging in Terraform. So the first step which I'm going to do, I will copy the path. We'll open the CMD. I will run Terraform init. If you see here, while running the Terraform init, we are not getting any logs. Let me run Terraform plan also. If you see here, we are not getting any logs in Terraform plan. What we have to do next, as discussed, we have to set up the environment variable. The command is setx, then tf underscore log, and we do have n number of option, which is trace, debug, info, warning, and error. As discussed in the last video, if you're going to enable trace, then it will have all the values. And same for debug. If you're going to mention debug, it will have information, warning, and error. So I will mention here trace. Okay. So environment variable has been set up. If I'm going to run again Terraform init, we are getting the same value. What we have to do, we have to open one more CMD and then change the path for our Terraform configuration. And then let me run Terraform init. See, we are able to see all the logs in terms of when we initiate it, what it will do from our local machine. It is going to connect with Azure RM provider, and then it will create .terraform folder, which have all the details regarding the provider, and then terraform.log.scl, which have the version detail. If you go through this log, you'll get the proper explanation about each and every step. Let me run Terraform plan also to see the log status. And finally, the output is No changes. Your infrastructure matches the configuration which we have initially seen while running the Terraform plan. Okay. But in real time scenario, we do not want these logs to be present inside our CMD. So in that case, what we have to do, we have to set up the environment variable to save all the logs inside the file. To do this configuration, what is the command? The command is setx tf underscore log underscore path, then our folder path. C colon, I would say, log test log dot log. Here, the environment variable has been saved. If I'm going to run again the Terraform init, still we are having logs in our terminal. If you see here, we are not having any logs in our CMD. In, in this case, all the logs are getting saved in our C drive under test log. And inside our C drive, if you see, we are having test log file. Let me quickly open it. It will have all the logs for our Terraform init plan and apply. Hi everyone, in this video I'm going to discuss about the Terraform modules. Example of Terraform module. Example 1. Your manager has asked you to create resources for a project. You are required to set up the following services. It is app service plan, function app, storage account, key vault, event hub. In example 2, your manager has asked you to create resources like AKS, Azure Container Service, API, and key vault. Till now, what we have discussed, if we create any resource, what we have to write? We have to create a file, I would say main.tf, and in this main.tf, we have to write our resource block configuration for each of the resources. The second thing which we are going to do, we are going to create a variable.tf, and in this variable.tf, we are going to declare all the variables. The third thing, it would be output block. The output block, it would be responsible to output the values. The third one which we are going to mention, it would be our provider block where we are going to mention the provider configuration. The same thing we are going to do here also. We are going to write main.tf, and here the resource block, it would be for AKS, ACR, API and the key vault. And the values, we are not going to do any kind of hard coding in the resource block. So we need to create a variable, then output. We are going to create output.tf to output the values, and finally we are having providers.tf. This is what we have discussed till now. So, overview of Terraform module. Terraform modules allow us to centralize the resource configuration and make it easier for multiple projects to reuse the Terraform code. Instead of writing code from scratch, we can use multiple ready-made modules available. The drive principle in Terraform, like in general software development, stand for do not repeat yourself. This principle encourages writing infrastructure code in a way that avoids duplication, promote reuse, and ensure maintainability. So what does it exactly mean? In the last example, we do have example A and example B. In both the example, what we have done from scratch, we have started writing our resource block, then our variable, then our output block, then our providers. The same thing we have done in the project B also. Resource block, then we have created variable.tf, then output, and then providers. So in real time scenario, we are not going to write our code from scratch. Instead of it, we are going to follow module approach. So what is the exact meaning of module approach? It means we can, instead of writing code from scratch, we can use multiple ready-made modules available. So we're going to have dedicated repo for modules, which means we are going to write here resource block, variable, our output and provider. Okay. And we are going to call this value from the project A, project B, project C. And in this module, I would say we are going to have all the configuration. I would say app service plan, function app, storage account, key vault, then our AKS, ACR,
APIM1. So for all these resources, we are going to write a module for it. And then we are going to store in this dedicated repo. And according to the requirement, we are going to call it in project A, project B, project C. Maybe in project A, we only need Azure Function App, App Service Plan, and a storage account. Maybe in project B, we only need, I would say, Key Vault, storage account, and AKS. And in project C, what we are going to have, we are going to have, I would say, AKS, ACR, and APIM1. So we do not need to write any code from scratch. We only need to call the value, and this is called dry principle, which means do not repeat yourself. We have to write our code and store in dedicated repo, and we are good to call this modules according to our requirement. So what is the exact best practices for creating a module? Define a clear module structure. A well-structured Terraform module should to navigate. The basic structure of Terraform module includes, we are going to have main.tf, then variables.tf, outputs.tf, readme.tf, providers.tf, and version.tf. The main.tf, I would say if I'm working on ACR module, what I'm going to do, I'm going to write the resource block for ACR. Then I'm not going to hard code any value. I'm going to create a variable for it, and all the variable will be declared in variables.tf. And I'm going to write output.tf to output the values which has been created. Readme.md to make it more user friendly. Providers.tf where we are good to mention the provider configurations, and the same for versions also. So after creating the module, a dedicated test directory is set up to validate the module functionality with configurations and test cases to ensure the module behave as expected in different scenario. So what does it mean? Here what I have done, I have created one module for virtual machine, and in this virtual machine module I have created dedicated file public ip.tf, then our providers.tf, variables.tf, virtual machine.tf, and vnet.tf. Okay, I have not hard coded any value to test the configuration. Is it up to the mark or not? I have created dedicated folder name called test inside a folder name called vm, and here I'm having main.tf. So locally I'm running my Terraform configuration to check is it up to the mark or not. Calling a module. Module source code can be present in wide variety of location including. What does it mean? In the last slide we discussed dedicated repo for a module. So this dedicated repo for a module can be in GitHub, in local path, Terraform registry, Azure repos, HTTP URLs. To reference a module, you need to make use of module block and source. So it means we do have dedicated repo. We have to call it for project A. To reference a module, you need to make use of module block and source. So it means we do have dedicated repo and we want to call it for project A. So what we have to do, we have to create one file, I would say test.tf or whatever the name you want to mention as per your naming convention. Then we need to mention module, and then whatever the module you're calling, if you're calling ACR1, you're good to mention ACR, or APIM if you're calling, you're good to mention APM1. If you're calling virtual machine, like it depends what, like which module you're calling, you're good to mention any name here. They're good to mention the source, and here it would be the path where your module has been created. If it is present in Bitbucket, you're good to mention the URL of the Bitbucket, or else wherever you have stored your module, you need to place mention the values. Terraform uses this during the module installation step of Terraform init to download the source code to a directory on local disk so that other Terraform command can use it. So what exactly means? So initially we are having our source module, I would say dedicated module where we have written our modules, and here in project A we are calling. As we do have mentioned, it is mandatory to mention module keyword, then whatever the module you are calling, you're good to mention then the source. In the source we are good to mention where our dedicated module is present. If it is inside the local path, then you have to mention the local path address. I would say like this, my source module is present inside two folders back, while here I have stored my source module inside the bit bucket, so I'm mentioning the path of the bit bucket. So when I'm going to run Terraform init, what is going to happen, it will download the source code in my local machine, and At the runtime, what we have to do, we have to pass all the values, whatever the variables we do have created, and we are good to run Terraform plan and Terraform apply. Okay. So in this case, what we have to do, we have to only pass the required values and we are good to create the resource. We don't need to write any resource block from scratch. Okay. Root versus child modules. Root module reside in the main working directory of your Terraform configuration, and this is the entry point for your infrastructure definition. A module that has been called by another module is often referred to as a child module. So the place where we are going to store our module, it would be our root module, and the place where we are going to call all this module to pass the values, it will be our child module. Hi everyone, in this video I'm going to do a demo on Terraform module. So what we have discussed till now, if we want to create any module, the first thing it would be main.tf, which will be responsible for all the resources block. Then we are going to have provider for all our provider configuration, then variable file for all our variable configuration, and the output block. Okay. In this video, I'm going to create a module for virtual machine. So the first thing which I'm going to do, I'm going to open the official documentation of Terraform and copy the details here. I'll create a file name called as main.tf. This is the official documentation of Azure RM underscore Windows underscore virtual machine. I'll click on copy. I'll paste it here. Okay. So to create any virtual machine, what are the resources it would be required? The first one, it would be private IP, then public IP, then I would say it would be our virtual machine configurations, then our NIC card, and then the public IP which we do have created, we have to connect it to NIC. And in the virtual machine, we are going to have our OS disk configurations also. So I have copied it here. We'll create a file name called as providers.tf, and here I will copy the values for providers.tf. The first thing which we want to create is private IP. So for the private IP, the value will come from the subnet, and the subnet value will come from the vnet. So in this example, we are going to create our own virtual network. So let me but let me divide it. If you see here, we are having our virtual network example. I'll create a file name called as vnet.tf and will mention it here. Okay. Then what is the second configuration we need to mention? We need to create a public IP. To create a public IP, we need a resource name called as Azure RM public IP. Let me open a tab here. I will mention public IP Azure. I'll mention public IP Azure Terraform. Here we do have the configuration. I'm going to copy it and we'll create a dedicated file name as public IP.tf. And we do not need a resource group configuration here. So this is the public IP which we do have mentioned. Our VNet configuration has been mentioned. Then the third one, it would be our virtual machine.tf. If you see here in main.tf, we are having our virtual machine configuration and NIC. I will copy and paste it. We have already copied the provider configuration, and the final, it would be our resource block. Okay. Till now, we have all the required files. Okay. for main.tf, public IP.tf, providers.tf, virtual machine.tf, and vnet.tf. As I do have mentioned, for public IP, we need to connect to the NIC card. So what would be the step? I would say come inside the virtual machine. Here we are having our virtual network. We are having our Azure RM network interface. I will mention here public IP address. What is my public IP address configuration is? It is Azure RM dot example dot I need ID here. If you come here in the official documentation, just Control F, I would say public IP address ID. So it requires reference to a public IP address to associate with this NIC. Okay. So the initial step has been completed. We have created file for each and every resources. So the next step is creation of our variables file. Variables.tf I'm going to create. In variables.tf, if you see here in Azure RM Windows Virtual Machine, the Linux virtual machine value is hard coded, the size is hard coded, admin username is hard coded, the password is hard coded, I would say OS text and the source image reference. So what we need to do, we need to create a variable for it. Basically, we do have two options while creating a variable. The first option, it would be create a variable for each and every value which we do have discussed till now. Apart from that, we do have the second option in which we are going to declare type as object, and in a single go we are good to declare n number of variable inside it. So let's follow the second approach. I will mention variable vm underscore configs. Here I'm going to mention type is equal to object. And what is the first thing I want? I want virtual machine name. I'll mention here as VM underscore name. Then the second one, what it would be? It would be my size. To make it more user friendly, I'll mention VM underscore size. The third value it would be admin underscore username. And the fourth one it would be admin underscore password. Here it is already connected to my NIC card. So in terms of caching, it would define, and storage account type I will mention here as storage account type. Then it would be my, for OS disk configuration, I'll mention here as publisher. Then I will mention here it as offer. Then our SKU, and the next last one it would be our version. Okay, we are going to mention the data type as a string. So what we need to do to call this value, the first thing it would be var dot vmconfigs dot our virtual machine name. The same thing we are going to follow for the stand size. I would say it would be var.vmconfigs dot admin username, then the admin password, and here I would mention here I would mention the storage account type, and the same thing I'm going to follow for publisher, offer, SKU, and the version. Okay, so what we have done till now, we have created variables for our virtual machine configuration. If you see, for Azure RM Windows virtual machine, all the values are variable apart from the NIC card. All the values are in a variable, and this some of the values we do not want to update, so we are good to ignore it. While in the case of NIC card, rather than taking an input from the user, we need to mention, I would say, function called format. Then the format, it would be percentage %s, I would say NIC, comma, the value it would be var.vm configuration. So in this case, what is going to happen? The format will follow as this string hyphen nick, and the string value will come from our virtual machine name. If I'm saying it is a demo virtual machine, then automatically it will name as demo hyphen nick. So this is the basic functionality of the format function. We have created variable for each and everything which are required to input from the user. So the second one which we are going to do, it would be inside our public IP. Again, for the public IP, we are going to follow the same configuration. It would be format we are going to mention, then string value it would be hyphen public PIP, and the value it would come from our virtual machine configurations only. So again, the same thing will happen. We are going to have our virtual machine name, and at the end it will have PIP, which mention it is the public IP for this virtual machine. I do not need any tag right now, so I will remove it, and other values look good. I always need a static value, so that's why I haven't created it as a variables. If you come to the VNet part, in VNet, what we need to create variables for our virtual network name and this one. So I'm going to create a variable name as vnet underscore config, and I'm going to follow the same approach rather than creating a variable for each of the values. So it would be type is equal to ob type is equal to, I would say, object. The first thing it would be our vnet underscore name. I will mention here. Then the second thing it would be vnet underscore address space. The third one it would be subnet underscore name, and it would be subnet underscore address underscore space. Okay, so the vnet name should be string. while in the case of VNet address space, it would be list of, I would say, string. And for the VNet name, again, it would be string, and VNet address space, it would be list of string. Why I have mentioned list of string instead of string? Because if you see here, the default value which we are passing in a square bracket will define about the list of string. Apart from that, you're good to look into the official documentation also. So I will update the value as here var dot vnet config dot vnet name. The same thing I'm going to copy and paste here. At the end, it would be vnet underscore address space name. Here also I'm going to do the same thing, and it would be subnet underscore name. Sorry, subnet underscore name, and then here it would be subnet underscore address space. You see, we have updated our vm.tf configuration, the vnet.tf, then our public IP, and we are left with main.tf. In main.tf, we are good to create a variable, I would say rg underscore name. Good to mention as type is equal to string, and the second variable, it would be variable is equal to location, and the type is equal to string. Okay, the same thing I'm going to do, var dot rg underscore name, and here it would be var dot location. So we have created var dot rg underscore name. So what is our next step? As we do have discussed in our module part, we are only going to mention the resource block with variable, then providers, but we are not going to hard code any values which we have achieved. But to check this module, is it up to the mark or not? What we have to do, we have to create a dedicated folder inside this module. I'll say this, and then I'm going to mention virtual machine, and then in this one I'm going to mention main.tf. So this is the block we are going to have. I will copy paste this Terraform configuration. So we do have discussed to call any module, what we have to do, we have to mention a module keyword. So I'm going to mention the same thing here as module, and we are good to mention any name. I would say demo underscore virtual machine. I'm going to mention. Then the second thing, it is our source code. In the last video, we discussed when we are going to run Terraform init command, it is going to download my source code. Okay, and we need to mention the path inside the source code. So right now our source code is present inside two folders back. So we are good to mention it as like this. Then what we have to do, we have to pass the values. So the first values which we need to pass, I would say our resource group name, and here I'm good to mention it as demo underscore virtual machine underscore rg. Location I will mention here as location is equal to east US. Then what is the other value we do have? The VM configuration and the VNet configuration. So firstly I will mention here as the vnet configuration. So it would be vnet underscore config is equal to, we have to pass the values. So it is vnet underscore name. I will mention here as virtual machine underscore vnet. Then the second value which we are having, vnet address space, I will mention here as, then it is a list of strings, so I have to mention inside the list, and then 10.0.0 /16. Then my subnet name I would mention is equal to vm underscore snet. And again, the subnet address space I will mention here it as 10.0.2.0 /24, and will mention inside the comma. Okay, so this vnet configuration has been completed. What is our next configuration? The next configuration is our VM configuration. Okay, so I will mention here as VM underscore module. I'll mention VM underscore config is equal to, I will just copy paste all this thing to save the time. So what would be my virtual machine name? I would mention as demo underscore virtual machine, and the virtual machine size I will mention as standard underscore F2, and the username I would mention as admin user, and for password I will just mention this one, and the storage account I will mention here as standard underscore LRS. For publisher offer and SQ version, will copy it from the official document which is here. See, publisher version offer and publisher offer SQ and version. If you see here what we have done till now, let me close all the file. We have created our module here, which will be our parent module, and we have passed all the required values from the main.tf. Okay, let me rename this one as desktop.tf folder. Okay, here I have mentioned the provider configuration, and here I have mentioned my module. Module is the required keyword and the source where our source module is present, and these are the variables which we do have mentioned inside our module, so we have passed the value. Click copy the path, I will mention the path, and right now I'm running the code inside from my VM folder, the Terraform init. So if you see, initializing the modules, the next command I'm going to do Terraform plan and see if you're getting any alert or not. See, we are going to add 6 resources. Let me run quickly Terraform format to align it, and let me run Terraform apply.
So it is asking for confirmation. We'll type yes. If you see here, we got an error. Unable to assume default computer name may only contain alphanumeric characters and dashes. Please adjust the name or specify the explicit computer underscore name. So what we have to do, there's some issue with the naming convention which we have followed. I'll mention it demo-vm and let me run again. Let me type yes again and see if it is up to the mark or not. Done, we have created our virtual machine. So in this video, what we have done, we have created a module and we have called this module from the local machine only. In the next video, what we are going to do, we will push this code inside the Azure repo and then we will update the source block for the Azure repo URL and then we'll run the. Hi everyone, in the last video we discussed about the virtual machine module creation part, and once the module was created we were running the module from our local machine. What we are going to discuss, I have pushed this module inside our Azure repo. So rather than calling the module from the local machine, we are going to call the modules from our Azure repo inside the local machine. So the first step which I'm going to do, I'm going to create a file name called as main.tf. Okay. First configuration which we are good to mention, it would be regarding our provider configuration. The second thing it would be the module keyword. I would say it is my Linux virtual machine. I will mention it here. Then it would be our source is equal to here. So I have pushed the code inside the Azure DevOps. In one of the branch, what I'm going to do, I'm going to click on clone. I will clone this value and I will paste it. Okay. So the next thing, as we do have discussed in the last video, we have to pass the values. So to pass the values in a real-time scenario, what we are going to have, we are going to have README file which have the proper documentation. What are the values required to run this module? But for now, I'm going to take a reference from main.tf. I will copy paste this all this value inside my local machine. If you see here, I have mentioned RG name, RG location, VM configuration, and the VNet configuration, and all the variables has been created here. Okay. So the first thing which I'm going to do, I will copy the path. I'll mention here as CD. Will run Terraform init. Again, I would repeat, if you see in this folder, we are only having main.tf. In main.tf, we are having our module, the source path, and these are the values which are required to run the module. See what it is doing. The first step, it is downloading our module. Download Git, and where it has been downloaded, let me quickly click. See .terraform folder in modules. We are having this module name called as Linux VM downloaded, and it has all the details. So when we are going to run Terraform plan, sorry, there's one typo, Terraform plan. So what it is going to do, we do have Linux VM modules present. This is the module which we do have in our local machine. And here we do have set of variables. So when we are, so in our Terraform plan, what it has done, it has passed all the values to this module. Let me quickly run Terraform apply. Let me type yes. Our virtual machine has been created. Let me quickly check from portal. If you see here, our virtual machine has been created inside demo-rg, and it has all the details like example virtual machine, NIC, public IP, disk, and the virtual network. Okay. So in this video, what we have done, we do have the module we have pushed inside the Azure repo, and then from our local machine we have called this Azure repo and passed all the required values for it. Okay, we are good to push our module inside the other remote repository. What we have to do, we have to only update this path according to our URL. Okay, so thanks a lot for watching the video. In the next video we are going to discuss about the state management. Thank you. Hi everyone. In this video, we are going to discuss about the remote state management. Basics of backends. Backends determine where Terraform stores its state. By default, Terraform implicitly uses a backend called local to store a state as a local file on disk. So what is the exactly meaning of it? So till now, our state file is creating where in our local machine. So what is the exact meaning of local machine? The place from where we are running our code. Okay. In the last example also, what we have done, we have called a module on this source path and we have passed the variable. So the state file which was created, it is present inside our local machine. Okay. Challenges with local backend. In modern infrastructure as code practices, especially when using Terraform, collaboration amongst team is key. So what is the exact meaning of it? In real-time scenario, whenever we are going to work on Terraform project, we are going to have a dedicated team for it. Okay, it should not be done by only one user. Okay, when working with Terraform, a state file holds a critical information about the infrastructure, including resources, configurations, and dependency. What is the exact meaning of it? In the initial lecture, what we have discussed, we do have concept called desired state and the current state. So the desired state, whatever we do have mentioned in our Terraform configuration, and the current state, whatever we have deployed. To balance between the desired state and the current state, what we need an state file. Okay, so for any configuration, whenever we are going to run Terraform plan or Terraform apply, each and every time the state file configuration is checked. Managing the state file properly becomes essential for teams that collaborate on same infrastructure project. So what is the exact meaning of it? Let's take example. I have built a Terraform code to create resources like AKS, ACR, API. Okay, I have dedicated module for all these resources. I'm just calling the module from another place and just passing all the values. Okay, so if I'm going to store the state file inside my local machine, tomorrow if any other user want to do any changes in AKS, ACR or APIM values, will he able to do it? No, because we have stored our state file inside the local machine. So what we need to have, we need to have a centralized place where we are good to store our state file. So anyone else from our team good to connect from his or her local machine. So what would be the ideal architecture? Following describes one of the recommended architectures. The Terraform code is stored in a Git repository, providing advantages such as collaboration, versioning, change management, and automation.
What we have discussed in the last slide, we are planning to create AKS, ACR, APIM. Okay. So for this one, what we have done, we have created a dedicated module, and this module code will be stored in a dedicated repo, I would say. And we do have data engineering project, and in the data engineering project, what we are doing, we are just calling all these modules and we are passing the values for it. Okay. So the best practice is to store all our code. It would be a central Git repo. One repo, it would be dedicated for all our modules, and the second module, it would be for all our projects. We are not good to store our state file in a local machine from the place where we are calling all this module, because today I'm working on this project. Tomorrow it would be like a different person from my team who wants to do any configuration changes in all this value. So what we have to do, we need to have a central backend where we are going to store our state file. Okay. So the whole architecture, it would be like this. We do have our central Git repo, the place where we are going to store all our Terraform configuration file. Parallelly, the Terraform state file, it would be stored inside our central backend. So the backend supported in Terraform. Terraform supports multiple backends that allows remote services related operation. Some of the popular backends include Amazon S3, Azure Blob Storage, Google Cloud Storage, HashiCorp Console, HashiCorp Terraform Cloud Enterprise. So what is the exact meaning of it? It means in the last slide, what we have mentioned, the central backend, we do have n vendor where we are good to store our state file. But in this video, we are going to store our state file inside the Azure Blob Storage. So exactly where we need to mention the configuration related to backend. If you see here, what I have mentioned a backend keyword, and inside the backend keyword, I have mentioned Azure RM, and these are the values which I have to update. The source group name of my storage account name, what would be my container name, and what would be the file name of Terraform. In key, we are good to mention the any state file name, but we have to mention extension .terraform.tf state. So in the next video, I'm going to do a demo on it. Hi everyone, in this video, we are going to do a demo on remote state management. So what we have done till now, we have called this module name called as Linux VM, and our source code is present inside our Azure repository, and these are the values which we have passed. So whenever we are running Terraform init plan apply, our state file is getting stored where? In our local machine. As we do have discussed in the last video, the best practices is to store the state file inside the remote state management rather than in local backend. Okay. Why we need to store our state file in remote state management? The first thing, it would be like, in terms of security, we should store our file in remote state management where we are good to have different kind of replication, versionings, and the other configuration. The second thing which I would say which is required for the remote state management in terms of team collaboration. Right now, I would say we are having a Terraform team, and in this team we are having member 1 and member 2. So if member 1 wants to do any changes from his local machine, then the state file will be present inside the local machine only. And parallelly, if member 2 wants to do any changes in this code, the state file will be present inside the local machine only. So the best practices is to have a dedicated remote state management where we are good to store our state file configuration. So what are the value we need to update for our Terraform state management configuration? If you see in official document, what we have to mention backend keyword, then Azure RM, then the resource group name, the storage account name, and the container name, and finally the key. As we do have discussed in the last video, if you're we have to mention the extension called .terraform.tf state for the key. Let me copy it and paste it inside our Terraform configuration. I would mention the storage account name as Terraform storage account and will mention some random value to make it unique. The TF state is fine, then the key is fine. Let me quickly create a storage account with this name. Uh, the resource group name it would be. Storage account hyphen resource group, and this storage account name which I'm going to mention TF storage account, and the container name we are going to update once our storage account it would be created. I'm going to mention it as LRS review and create. Let me click on create. So our resource group and the storage account has been created. What is the next step we need to do? We need to create a container with a name called TF state. I'm going to click on containers, create the TF state created. So uh, if you see here, what we initiated a command called Terraform init. The first thing which is happening, initializing the backend and successfully configured the backend as your RM. Terraform will automatically use this backend unless the backend configuration changes. So what does it means? Instead of local backend, which means to store our file in the local machine, it is going to use what? Azure RM provider. In the Azure RM provider, to be very precise, inside this storage account, the container name TF state, this state file will be created. Huh? Let me run Terraform apply to save the time. If you see here, our resources has been created and currently we do not have our Terraform state file. So where is our terraform.tf state file? The Terraform state file is inside this tf state container. Let me quickly check it. See, we are having our Terraform state file stored inside our tf state container. So if I'm going to run again, Terraform apply hyphen auto hyphen approve, let's see what is going to happen. See, it is showing like, hey, no resource is going to be added, changed or destroyed. So each and every time it is going to connect to the remote backend. So what we have to, so what we have discussed till now, this is from my local machine. Okay, I do have one repo where I have stored all my Terraform configuration in terms of my module. The second file is our remote backend where I have stored all my state file. Okay, and what I'm going to do after my changes, again I'm going to push my Terraform configuration inside a dedicated repo. I would say it would be dedicated for the project configuration. For the project configurations, and our state file it would be this one. Tomorrow if anyone else want to do any changes in this Terraform configuration, what they're going to do, they're going to clone this project inside their local machine, and they're going to do the changes, and parallelly our state file will be updated. So this is the basic benefit of using remote state store.
Hi everyone, in this video we are going to discuss about the Terraform deployment options. State and code file management. State file management. To manage Terraform state files securely and in collaboration, it is recommended to use remote state management. Solutions like Amazon S3, Azure Storage Accounts, or Terraform Cloud. So we already have a very detailed discussion regarding the state file management. We need to use remote state management, and for remote state management, we are having n number of options. One, it is Amazon S3, Azure Storage Account, or Terraform Cloud. Then the code management. For storing and managing our infrastructure code, it is essential to use version control systems such as Bitbucket, GitHub, or Azure repos. We discussed in the last video regarding the code management. So the options we are having: Bitbucket, GitHub, and Azure repos. Optimizing Terraform is execution and deployment. In terms of code implementation, which refer to executing the code, here is what we have done so far. So in terms of state management, we have used a storage account. In terms of version control, we have used Azure repos. In terms of execution, Terraform code has been executed manually via the command line. However, we can enhance this process by implementing CI/CD pipelines using tools like Azure DevOps, Jenkins, GitLab, or Terraform Cloud to automate and streamline code execution. So, in terms of remote state management, we have implemented Azure Storage Account. In terms of version control, we implemented Azure repos. But till now, what we have done, whatever the Terraform lifecycle we have implemented, Terraform init, Terraform plan, Terraform apply, we have executed all this command from our local machine. But in real time scenario, apart from this option, we do have two more options. One, I would say using CI/CD approach, okay, and the second one we are having using Terraform cloud option, okay. So we are going to have a dedicated video to discuss about the Terraform cloud implementation. And in terms of CI/CD implementation, we are having an options, okay. And for this part, what we are going to select, we are going to select Azure DevOps. For Azure DevOps implementation, we are going to follow the below steps. And the steps are: create a dedicated organization and install the extension. A dedicated project will be created in Azure DevOps. A service connection between the Azure DevOps and Azure will be established and provide the SP access at subscription level. A dedicated repository will be created in Azure DevOps to store the code. A storage account will be set up in Azure to store the Terraform state file. A YAML file will be created to handle CI/CD pipeline. A variable group will be configured for managing environment specific variables. So in our upcoming videos, I'm going to do a demo on each and every steps. These are the high level steps we are going to follow for the implementation of Azure DevOps. Okay. Implementation. Hi everyone, in this video we are going to start our Azure DevOps implementation. So the first thing which we need to create in Azure DevOps is organization. And once this organization is created, we are going to create a dedicated project for our Terraform implementation. I would say Terraform hyphen project. At organization level, we'll install an extension, and the extension it would be required for our Terraform implementation. At Terraform project level, we need to create a service connection which will be connected to our Azure. So let's start the demo. So I'm going to click on Open Azure DevOps. I'll mention my email ID. It is asking for verification. The code is 030815. We'll click on sign in. So I'm going to click on new organization. The organization name I will mention AK-edu -org 1. Okay, so our organization has been created. I'm going to create a project name called as Terraform-demo. We'll click on create. Okay, so as I do have mentioned, at organization level, we need to install some extension. We'll click on extensions, click on browse marketplace. So we are going to use Terraform in our IaC project. So I'm going to mention Terraform and we'll click on search. If you see here, we are having n number of options, but I'm going to select the first one because it is Microsoft certified. I'll click on get it free. So we want to install this Terraform extension in this organization. So Terraform has been installed in this organization, which means if you're going to have n number of projects, in each and every project, we are good to use the Terraform commands. Okay, this is the basic benefit of using extension. And the next step which we are pending to create a service connection. So I've clicked on project setting and then I will select the service connection option. We'll click on create service connection. I'll mention here Azure Resource Manager. Okay, I'll say Azure-SC. I click on grant access permission to all pipelines and we'll click on save. So our service connection has been created. So what we have done till now, we have created the organization and we have installed the Terraform extension because in this organization we have created Terraform-project and in this project we are going to use Terraform task. That's why we have installed Terraform extension. The second part is regarding the service connection. It is the bridge between our Terraform project and the Azure account. So we have created the service connection, but this service connection has created a entry in our Azure Active Directory. So what the next thing we need to do? We need to provide the access of this service principal to our dedicated subscription level. Then we are good to do the task. Okay, going to click manage app registration. So this is the service principal which is created inside our Azure Active Directory. I've copied the service connection name. I'll click on home and subscription. I'm going to click on pay as you go, then access control. Then I'm going to click on add role assignment. I'm going to give owner access. I'll select the member. I've already copied the value. I'll paste the value. So here it is the AK-edu organization. I'll click on select. I'll click on next. I will click on allow user to assign all roles. Then review and assign. So we have added the role to this service principal. So till now we have done all the required steps for this implementation. We have created our organization. Then we have installed the Terraform extension, then created dedicated project. And in this dedicated project, what we have done, we have created a service connection. And the service connection is a bridge between our Terraform project and the Azure account. And this service principal created an entry in our Azure Active Directory. As you are already aware, Azure Active Directory and subscription, both of them are different thing. So whatever the service principal ID was created, we have given access at subscription level. So going forward, if you want to create or to manage or to do anything in Azure account, this service principal will be responsible for it. Okay. So in the next video, I'm going to do a demo on Azure repo where we are going to store our code. Okay. Hi everyone. In this video, we are going to discuss about the Azure repo implementation. So if you say Azure repo, so by default, it creates a repository name with the same name of our project. Okay. Repository, I'm going to create a file name called as main.tf, and the configuration of main.tf, it would be the same from our state file demo. Okay. And then what we are going to do, we are going to create a storage account to save our state file configuration. Okay. So let's start. So we are inside this Terraform-demo project. I'm going to click on repo. If you see, by default, it creates a repository of the same name of our project. So I'm going to click here on three dots. Then I will click on file name called as main.tf, and in main the same code which we have used in our Terraform state file demo. If you see from line number 21 to 42, the first thing which we are doing, we are mentioning this module name as Linux VM. Then at the source, we are having the module present on this path, and then at the runtime, we are passing all these values. And here we are having our Terraform required providers. And here we have mentioned the backend Azure RM. The backend Azure RM is for remote state management where a state file is going to be stored. So we haven't created this storage account. Let me create it. In my Azure account, I'm going to click on a storage account. Then I will click on create. Then I'm going to click on create new. The storage account name is storage account hyphen resource group. And my storage account name is storage account 423. So it is already taken. So what I'm going to do, I'm going to update some random values. Okay. Let me update the same thing in my storage account name. To do for Azure Blob Storage, I want LRS because it is for demo purpose only. We'll click on review and create. Next thing which I'm going to do, I'm going to click on create. So our storage account has been created. Okay. So the first thing which we have to do, we have to change some configuration. By default, the blob access is not enabled. I will click on enabled and I will save this one. Then I'm going to click on containers, then plus container. The container name is TF state. Okay. And I will mention at container level. We'll click on create. So our storage account has been created and our container also. So I'm going to commit this code. Okay, so we are having our detailed code inside this Terraform-demo repo. So till now what we have done in Azure repo, the repository which was created by default, we have created a file name called as main.tf. Inside main.tf, I have copy pasted the same code which we have used in a state file management demo. And the second thing which I have done, I have created a storage account which is going to store our state file. Okay, so in the next video, what I'm going to do, we are going to discuss about the CI/CD process in detail. Okay, so
In this video, we are going to discuss about the CI/CD part. So firstly discuss what we have done till now. We have created an organization. In the organization, I have installed a Terraform extension. Okay. Then I have created a project, and inside this project, what I have done, I have created a service connection. Then I have copy pasted the code in Azure repo, and then I created a storage account to store my state file. Okay, so I would say all these steps we have done till now. In terms of the code implementation, what we have discussed till day 8. Okay, so in terms of code, we discussed better to use version control system, and in market we are having n number of version control system, and in this demo what we have used Azure repos. Then the second thing which we discussed about the state file. So for the state file, we discuss about the remote state management configuration, and we have implemented Azure, I would say, storage account. Okay, but in terms of running the code, what we were doing from our local machine, we were running the code. Is this clear? From a local machine, we are running Terraform init, then Terraform plan, then Terraform apply, and Terraform destroy. But we discuss in detail, apart from this, from the local machine approach, we do have one more options, I would say, for CI/CD and the Terraform cloud part. So Terraform cloud we are going to discuss in our upcoming videos, while the CI/CD part we discuss, we are going to implement Azure DevOps. Okay, and for the Azure DevOps, we have already created the organization, the project, the service connection, installing the extension, and the Azure repo part. Okay, so what are the steps it would be required at Azure DevOps level? So in CI/CD part to implement, we need to write a YAML file. Okay, so I'm going to write a YAML file where I'm going to mention each and every steps in very detail. Okay, so let's start. So I'm going to click on pipelines. I will click on create pipeline. Here it is mentioned where is your code. My code is present inside Azure repos. Okay, and this is my repo name, Terraform-demo. I'm going to click on starter pipeline because it is a new configuration. I'll remove this one. So the first thing which I need to mention is regarding trigger. I'll mention none. If I'm going to do any changes inside my repo, it will not initiate this pipeline configuration. I have to manually run this pipeline configuration. Okay. As I do have mentioned, we are not going to run this configuration in local machine, but eventually when we are going to run Terraform init, Terraform plan, Terraform apply, it will run on any virtual machine. Okay, so in this case, we are going to use Microsoft hosted virtual machine, and the virtual machine image name is Ubuntu latest. So when we are going to run our Terraform init, automatically a dedicated virtual machine will be given to us, and the operating system of this virtual machine will be Ubuntu latest. Okay, in YAML file, they do have multiple things. One is stages. Okay, in this stages we can have multiple stage. I would say stage 1, stage 2. To be more precise, we are good to say it would be my Terraform plan stage, and the second stage it would be my Terraform apply stage. Okay, in each stage we are going to have multiple jobs. Okay, and within each job we are going to have a steps. Okay, and in each steps we are going to have a, so the next thing which I need to mention, it is my stages. The next thing which I need to mention, it is stages. So in this example, I'm going to have a single stage only. So I'll mention stage, my first stage. What would be my stage name? I would say Terraform hyphen demo. Okay. And what would be my display name? I'll mention here Terraform hyphen demo. And in each stage, what we are going to have, we are going to have multiple jobs. So I'll mention jobs. In jobs, we are going to have job, and I will mention the job name as Terraform hyphen mintation. Okay, and display name it would be same only. Then inside the job, we are going to have steps. And the first task which I'm going to have, it would be my Terraform installation. Why Terraform installation it is required? Because this is, as I do have mentioned, Microsoft is going to provide this virtual machine which is having Ubuntu latest image. So before running our Terraform configuration, we need to install Terraform. Okay, so I'm going to click here on show assistant, and then I'm going to mention Terraform. If you see here, we are able to get this option of Terraform and Terraform tool installer. Why? Because at organization level, we have installed Terraform as extension. So once you install an extension at organization level, so in project level, we are good to use it. Okay. So I'm going to click on Terraform tool installer. Which version I want? I want the latest one. Okay. So we have installed the Terraform part. Then after the installation, what is the first thing which we need to do? We need to do a Terraform init one. So I have to move my cursor just below this task and then need to select Terraform one. So this time I'm going to select the first option, which is basically responsible for running the Terraform. So here it is asking for my backend configuration. So the Azure backend service connection, I'm going to click here. See the service connection which we do have created, Azure-SC, need to select it. Then this is the resource group which we have created for our storage account configuration. Then we need to select our storage account and then our TFS state file, the container name. I will mention here demo dot terraform dot tfs state. I will click on add. See, it has all the details which is required for Terraform init. The second command which we are going to run, it would be my Terraform plan. I will say Terraform plan service connection. It would be Azure-SC. I'll click on add. So Terraform plan is also added. And the next command which we are going to have, it is Terraform apply. If you want to add other commands like Terraform validate, Terraform output, we are good to use it. Okay. But in this example, I want to use a minimum command to run this pipeline configuration. So I'll click on apply. Again, the provider service connection it is going to ask. I'll click yes. So let me do a quick recall what we have done till now. So for trigger, I mentioned I do not want to run this pipeline. That's why I mentioned at none. Pool, the virtual machine image which we are going to use for this project, it is Ubuntu. Then we are having a multiple hierarchy. I would say stages are there. Then we are having jobs. Then we are having steps. And then we are having task. So this is the hierarchy which we need to learn while writing our YAML file. So in current example, what we are having only a single stage. So I mentioned Terraform hyphen demo. The display name is Terra hyphen demo. Then inside this stage, the job name is Terraform implementation. The first thing which we are doing, we are installing this Terraform inside this Ubuntu hyphen latest. The second thing which I'm doing, the Terraform init command. The third thing which I'm doing, which is our Terraform plan. And finally, I'm doing Terraform apply. Okay. Let me quickly update the display name so that we can easily explore it more while running the pipeline. Terraform display name, I would say Terraform hyphen install. Then the second thing which I'm going to mention, it would be for Terraform init. Then we are going to have Terraform plan. And finally, we are going to have Terraform apply. So I'm going to click on save and run. So what it is going to do, it will create a new file name called as azure-pipelines.yaml inside our main branch. Okay. So let me click on save and run. See, we are getting an error. Stage Terraform hyphen demo has invalid name. The valid name only contains alphanumeric character and underscore, may not start with a number. So we are getting an error in our YAML file. So what I have to do, I have to click on three dots and then edit pipeline. So let me replace Terraform hyphen with Terraform underscore, and this one also with hyphen with underscore. Let me click on validate and save. I will click on save. Then I'm going to click on run.
Again, click on run. See, it is showing our job name as Terraform implementation. If you see here, all the process has been completed. So the first step is Terraform installation. This Terraform version has been installed in our Linux machine. Then our Terraform init. If you see, Terraform has been successfully initialized. Then our Terraform plan, if you see what are the resources it is going to create, it is providing a list of 6 resources. One, it is our virtual network, then our subnet, our resource group, our public IP, our NIC card, and our Linux virtual machine. And finally, it is going to implement the apply. If you see here, all the 6 resource has been created. Let me quickly verify from the Azure portal. We click on resource group. See, demo hyphen hyphen RG resource group has been created and it has all the 6 resources. Let me check the storage account resource group also. There should be one state file. So we do click on containers. Then on TF state, this is the state file which is created. So what we have done till now, when we were running the things from our local machine, we have implemented a version control system. We stored our code inside the Azure repos. The second thing which we did is remote state management. We stored our code inside the Azure storage account. And this part what we have done, Terraform init, Terraform plan, and Terraform apply, we did it through manual process. But in terms of CI/CD part, what we have done, the version control system is same like we have used Azure repos, while in the case of remote state management, still it is same like we have used Azure storage account. But in the case of running the code, what we have done, we have written a YAML file. Okay, and in this YAML file, we mentioned the first thing about Terraform installation part, then Terraform init, then Terraform plan, and Terraform apply. If you see, the end result is what? To create a infra and Azure account. This part is same, but while running a CI/CD part, we don't need to run the things from our local machine. We are good to run the things using pipeline. So till now, whatever the pipeline I do have implemented, it is a very basic pipeline. Like we in the YAML file, we mentioned install, init, plan, and apply. In my next video, we are going to have a very detailed discussion how are we going to more customize this YAML file in terms of running the whole thing in 2 stages, stage 1 and stage 2. In stage 1, it would be all about Terraform plan phase complete, and in stage 2, we are going to have Terraform apply stage. And before moving from Terraform plan to Terraform apply, we need to take approvals. Okay, so in the next video, I'm going to update the YAML file with more customization. Okay, so with this, we have completed this demo. So in the last video, we had a very detailed discussion regarding the pipeline configuration. So in this video, we are going to enhance it. If you remember, in the YAML file which we have created in a single stage, what we were doing, we were running the Terraform init command, then Terraform plan and Terraform apply. Okay, but in real-time scenario, we are not going to follow this approach. In real-time scenario, we are going to have one stage which is going to be dedicated for my plan. Then in the next stage, what we are going to do, we are going to apply it. Before implementing the apply, what we need to get? We need to get the approval. Okay.
if your manager approves the configuration, if it looks good to him, then only you're good to apply. You can't bluntly run the Terraform init plan apply in a single stage. Okay. And one more thing which we are going to do, we are going to customize our YAML file using variable group. Okay. So let's start the demo. So I'm going to click on new pipeline. My source code is present inside the Azure repository, then Terraform demo. So I'm going to click on existing Azure pipelines YAML file. My YAML file name is multi-stage.yaml, and then I'm going to click on continue. So if you see here, the whole code is divided into two stages. One, it is for my plan, and then second stage, it is for apply. And for plan and apply, we are going to get the approval. For this one, what we have created environment, and then inside the environment, we have mentioned the user who's going to approve it. So it is a demo environment, so it would be done by me, but in real time scenario, it would be your team lead or manager who's going to approve the code. Let me click on environments. See, this is the environment which is created, and the approval name is my only. Okay, let me cancel it. Trigger, it would be none because we do not want to initiate the pipeline for any changes. This should be manually run. Again, we are going to use Ubuntu-latest to run my pipeline. So we have created a variable group for this implementation, and the variable group name is Terraform-VG. And the whole process is divided into two stages. One stage is demo-plan, and the another one is demo-apply. So if you see here on demo-plan, the first thing which we are doing for installation of our Terraform, once the Terraform is installed, we are running Terraform in it, then doing a validation, and finally doing our Terraform plan. But if you see, rather than hard coding a value, what I have done, I have created a variable for it. And all these variables value are declared inside the Terraform-VG. And this is the variable group name, and see all the values I have updated here. So rather than hard coding the value in our YAML file, it is always recommended to create a variable for them, and all the variables will be called from the variable group. And if you see in the Terraform in demo-plan stage, we are only implementing the plan. But in the case of demo-apply, we are doing the Terraform init, then validation, then plan, and finally we are doing apply. Okay. While implementing the Terraform plan command, we discussed if you are going to mention -out and with a file name, so all the configuration it would be saved in this file name. So whenever we are going to run Terraform apply with a file name, all the configuration it would be implemented. The same thing we are doing here. If you notice the Terraform plan we are creating, and then this Terraform plan we are saving inside demo-plan, and Terraform apply at Terraform apply time we are just calling this command file name called demo-plan, and then we are running the configuration. So let me run this YAML file. So it is asking for permission. Basically, it is asking for variable group permission. I will click on permit. See, demo-plan should be started. So the first thing, Terraform installation, then Terraform init, then Terraform task, I would say, then Terraform plan. This Terraform task is basically responsible for Terraform validate command. See, it has not started Terraform apply. If I'm going to click on back, it is asking for approval. Pipeline needs permission to access a resource before this can continue to demo-apply. So permission for this environment I'm giving. Before giving the permission, what I have to do, I have to click here and then I have to click on plan and to see How many resources are going to be created? 6 of the resources are going to be created. So we are good with the plan. I'll click on back and click here. I'll permit it, move it. So then my Terraform apply task is going to be initiated. See, Terraform apply part initiated, Terraform minute, the Terraform task, which is our Terraform validate part, again the Terraform plan. See, our implementation is started. If you see here, our Terraform apply has been completed. So what is the exact meaning? It means like finally it has initiated a command as a Terraform init plan apply inside the resources, and all the 6 resource has been created inside my Azure account. So let me quickly verify it. See, this is my state file, and then let me click on resource group. It should reflect one more resource group name called as demo-rg. We are able to see demo-rg, and then in this demo-rg we are able to see all the required resources. Okay, so with this we have completed this demo video. What we have done, we have created 2 stages, one dedicated for plan and another stage dedicated for apply. Okay, and before moving from plan to apply, what we have taken, we have taken an approval, and also we have created a variable group to customize more our YAML file. Okay, so in the next video what we are going to do, we are not going to create any plan here. We are going to create a plan in plan stage only. Then we are going to create an artifact. Okay, and then this artifact is going to be downloaded here, and then it is going to run the apply. When I'm mentioning it creating an artifact, so the plan will create, I would say, using out option and the file underscore name, I would say we will use, and while running our apply in apply stage, it is not going to run any plan. It is going to use Terraform apply, and whatever the file name we have mentioned in our plan, it is going to run. Okay. Hi everyone, in this video we are going to implement CI/CD pipeline using artifacts. Let's firstly discuss what we have implemented in last 2 videos. So in the first video, what we have discussed regarding the CI/CD implementation. So we created a single stage only. And in this stage, we have implemented Terraform init, Terraform plan, and Terraform apply. So for learning purpose, it is really good. But in real time scenario, we do not implement the things in a single stage. What we need multiple stages. So what are the options we have? Stage 1 and stage 2. In stage 1, what we have done? We have done Terraform init and Terraform plan. Then we wait for approval, and once our plan was approved, then we move to the second stage. But in second stage, we were implementing Terraform init, Terraform plan, and then using out option, we, we were saving the plan in file name, in file, and then we were implementing the Terraform apply with the file. If you see here, in the second stage, we have done Terraform init and plan, and then we are working on Terraform plan hyphen out option, then Terraform apply the file name whatever we have created. As we do have discussed, the main benefit of Terraform hyphen out option is to create a file, and then at the apply time we are going to implement the same plan. But if you see here, what we have done in stage 1, we have done Terraform init and plan, but in second stage we are again creating a Terraform plan. This is not recommended in real time scenario. Why? Because chances are there whatever the plan was approved, it is not going to match 100% with the new Terraform plan in stage 2. So to overcome this challenge, what we have to do, we have to use hyphen out option here only, and whatever the file underscore name we have created, the same Terraform apply should be done using the same plan. Okay. In this case, we are going to create a plan in stage 1 only, and in stage 2, we are going to apply that plan. So in this case, we are going to see whatever the things are approved, the same things will be implemented while running Terraform apply. To achieve this one, what we have to create? We have to create an artifact. We have to create an artifact from the stage 1. Okay, stage 1 is going to create an artifact, download in stage 2, and then we are going to implement Terraform apply with the same file name. Okay, as I do have mentioned, in this case, after the approval, the 100% whatever the things we have planned, it is going to match. Okay, so let's discuss about the YAML file for this one. So I'm going to run a new pipeline. My source code is present in Azure repos git. The branch name is terraform-demo. Then existing Azure pipelines YAML file. I have already created a YAML file, and the name of the file is artifact multi-stages.yaml. As I do have discussed, the trigger is none, so we do not want to initiate this pipeline. Then we are having the pool. We are using Ubuntu-latest, and then we have created a variable group name called as terraform-vg. And if you see here, we are having the same two stage, one for demo plan again, and the next one is for demo apply. This steps Terraform installation, it is same. Then Terraform init, it is same. And we have created a variable, and this variables values are saved inside this one. We already have a detailed discussion in last video. Then we are having Terraform validate. And if you see here, what are the changes we have done in Terraform in demo plan stage? We have created a plan, and this plan is going to be saved inside demo-plan. Okay. As I do have discussed, this one is my stage 1, and this one it would be my stage 2, and this one is going to create Terraform plan and output hyphen out, which I do have mentioned in a file name called as demo-plan. Then second thing which we are going to do, we are going to create an artifact. So this is what we are doing. We are creating an artifact, and once this artifact is created, we are publishing a plan artifact. Okay, so we have created an artifact, we have published artifact. So stage 1 is completed. In stage 2, what we are going to notice, it will directly implement the apply with a file name called demo underscore plan. The first thing we have done, it is downloading an artifact, and once this artifact is downloaded, we are going to extract the files. Then our Terraform init we have done, then Terraform apply. If you see here in Terraform apply, what we have used, command option demo-plan. So whatever the plan we created in stage 1, it is going to be implemented in stage 2, and it would match 100% with our configuration. So the next thing which I'm going to do, I'm going to click on run, and see demo-plan has been started. The first command is Terraform installation. Terraform installation done. So Terraform init is started. Then Terraform task. Then Terraform plan. And Terraform plan, I would say, it is going to create a 6 resources. See, 6 to add. Then create a plan artifact. So publish and plan artifact. So Terraform plan has been completed. All the steps has been done. It has published an artifact. So it is showing job is pending. See, I need to give the permission. Good to approve it. So in demo apply, the first thing it would be initiated, the apply stage, which it has done. It has downloaded the artifact. Then it is going to extract the files. Then our Terraform init part. And finally the Terraform apply. And in Terraform apply, if you see, it is using the same plan which we have generated in stage 1. Okay. And this resource group creation started. If you see here, all the 6 resource has been created. So let me quickly check inside my portal. Let me refresh from the top. See, demo -rg has been created. And in this rg, how many resources we are having? We are having 5 resources and plus our resource group. In this demo, what we have done, we have created one stage. Then we are having one more stage. I would say stage 2. In stage 1, we have created an artifact. And this artifact is having a Terraform plan out in the file name called as demo underscore plan. Okay. In stage 2, what we have downloaded the artifact. And once this artifact is downloaded, what we have done, we have initiated a Terraform init and directly the Terraform apply with a file name of, I would say, demo underscore plan. So what is the benefit in this case? In this case, whatever the plan was generated in stage 1 and it was approved, we have implemented the same plan. We are not going to run Terraform plan again in the second stage. So it in real time scenario, it really helps to match the configuration whatever we have approved in stage 1. So with this, we have completed this demo. So thanks a lot for watching the video. Hello everyone. In this video, I'm going to discuss about the Terraform Cloud. Terraform Cloud implementation options. We have successfully implemented Terraform CLI for infrastructure management and explored its integration with Azure DevOps for DevOps workflow. In addition to these two options, we also have the alternative of using Terraform Cloud and HashiCorp Cloud Platform. The implementation of this solution offers two primary workflows. So, initially, we discuss about the Terraform CLI options, okay, where we were running the Terraform commands from our terminal. The second option which we discuss about the CI/CD implementation. Okay, we implemented CI/CD in Azure DevOps. As I do have mentioned, apart from these two options, we do have one more options which is called as Terraform Cloud, or I would say HashiCorp Cloud Platform. Initially, it is used to be called as Terraform Cloud. Right now, HashiCorp is saying it as HashiCorp Cloud Platform. So, for implementation of these Terraform Cloud or HashiCorp Cloud Platform, we do have two options. First is called version control workflow, and second is called CLI driven workflow. Leveraging version control system for automated infrastructure provisioning and collaboration. If you see in this diagram, the Terraform VCS driven workflow, left hand side is developer who's going to update the code where in my GitHub. Okay, and once he's going to update the code in GitHub, then our Terraform cloud is going to task for it. It can be our creation of the resource or deletion of the resource. But the source code will be present inside my GitHub account. Okay. The second option is CLI driven workflow, utilizing the Terraform CLI for manual and automated infrastructure management directly from the command line. So in this case, what we are going to do, our code will not be present inside the GitHub. Rather than the GitHub, it would be present in my local desktop. And from local desktop, I'm going to run the Terraform commands and then the changes will be implemented in Terraform Cloud. So in the upcoming videos, we are going to focus on Terraform VCS driven workflow. Then once this is done, then we will move on the implementation of Terraform CLI driven workflow. Key features of Terraform Cloud.
going forward, I'm not going to mention HashiCorp Cloud Platform. Okay, I'm going to mention Terraform Cloud only. Fully managed SaaS solution. No need to manage infrastructure or worry about scaling. So, what is the exact meaning of it? So, it is a software as a service. So, in this case, we did not need to do any kind of hardware management in terms of installing our Terraform or managing it. It would be done by Terraform Cloud only. State management, remote state storage with automatic backups and versioning. As we do have discussed in our remote state management, we are responsible for managing our state file. So we discussed we do have n number of option in Azure cloud, AWS cloud, or I would say Google cloud to store our state file. But in Terraform cloud, it would be managed by them only. VCS integration, integrate with GitHub, GitLab, Bitbucket, and other to trigger run on code changes. In the last slide, we took an example of GitHub. So our source code was present in GitHub. Whenever we are doing any changes in our source code, automatically it triggers Terraform part. But apart from GitHub, we are having n number of options: GitLab, Bitbucket, or I would say Azure Repo 2. And then whenever we are going to do changes in our code configuration, automatically it is going to trigger the things. Workspaces. Organize your infrastructure code by environment or project with isolated state and variables. So Terraform Cloud, we do have hierarchy like this: organization. Then within an organization, we are going to have the project, and within a project, we are going to have the workspace. And this workspace is nothing a dedicated folder to run our code. We are going to have very detailed discussion regarding this one in our upcoming video. Plan and apply automation. Automatically run Terraform plan and Terraform apply based on code changes or manual approval. So we do not need to run Terraform plan or Terraform apply in VCS part. We only need to select the option if you want to run Terraform plan or Terraform apply. And we do have one more thing, like automatically it will run if there would be any kind of changes in the source code. Policy as code. Enforce compliance and governance policies using Sentinel. So what is the exact meaning of it? I would say I'm creating a virtual machine. My all my users, to have a restriction, they can only create a virtual machine of this specific size D version only. Okay. To implement this one, we are good to use the Sentinel policy. If we are going to create a virtual machine from different size, I would say E series, then we are going to get the error. Or I would say if you are creating any resource in Azure, the tag should be present. If tag is not present in your code, automatically you're going to get the error. To achieve this one, we are good to use Sentinel. Secure secrets management. Integration with HashiCorp Vault and other secret management tools to securely store sensitive data. So it supports n number of secret management where we are good to store our sensitive data. Free and paid plans. A free tier with limited features, with paid plans offering advanced features like team management, enhanced security, and policy enforcement. So basically, we are having n number of plans for our Terraform cloud. Okay, so in the next slide, we will discuss about it. If you see the Terraform pricing options, one it is free, the other one is a standard, then plus, then enterprise. So it depends upon the kind of workload and requirement the organization choose between the standard, plus, and enterprise. We are going to use the free version. In free version, we are good to upgrade it to a standard one to do some of our labs. So we'll do it. You're good to explore this site for a detailed description. Okay. Terraform VCS implementation steps. So basically the first step which we have to do, we have to sign up on Terraform Cloud. Once you sign up, we need to create an organization. I would say we are working in Wipro. So we'll create an organization on a name of called Wipro. Okay. Then create a new project and workspace. In Wipro, I would say there would be n number of teams. One team, it would be for security. Another team, it would be for Python development. Then for Java development. So for each of them, what we are going to do in the Wipro organization, we are going to create a different project. Okay. One project for my security team, one for Python development, one for Java development. And within this project, we are good to create n number of workspace. Means one for dev environment, one for QA environment, one for prod. The same thing for my Python development, one for dev, one for QA, and one for prod. So this thing can be achieved using workspace concept. Okay. Once my workspace is created, what we need to mention, we need to connect to VCS. VCS means version control system. So where we have pushed our Terraform code. As I do have mentioned in the last slide, it can be your Azure repos, Bitbucket, or GitHub. Once it is done, eventually what we have to do, whatever the Terraform is going to do the operation in cloud only. Okay, so in this case, we need to integrate our Azure cloud with our Terraform cloud. For this part, we need to create an authentication part. And once it is done, we are good to run the Terraform apply in our code. In our upcoming videos, I'm going to do a demo on each and every step. So with this, we have completed this Terraform intro video. Hello everyone. In this video, we are going to create an organization. But before creating an organization, we need to have Terraform Cloud account. So I'm going to click on create your free account. Then I need to mention my username. I will mention here Akash Kumar, some random number, and will update my email ID, password for it. Then I'll click on terms of use and privacy policy, then create account. See, it has sent mail to my email ID. I need to confirm. I have already logged in my email ID. So see, this is the mail which I have received. I'm going to click on this verification link. So our email ID has been verified. So for the first thing which we have to do to create an organization, I'll click on create organization. I'll mention the organization name as Wipro and some random number to make it unique. And then I'm going to click on create organization. So it create a default project to start our work, but we will create a dedicated project for our implementation. I'll mention this project as VCS workflow hyphen demo hyphen project. I'll click on create. So our project has been created, and inside the project we need to create a workspace. It has three workflow: version control workflow, CLI driven workflow, and API driven workflow. So in this video, we are going to discuss about the version control workflow. So I'm going to click on my version control workflow. It is asking me to connect to version control provider. So I'm going to click on GitHub and then github.com. I've already logged in my GitHub account. That's why it has not asked for any verification. But for you, maybe it will ask. So you need to mention your username and password. So it is showing my repo name. Then I'm going to click. So the workspace name I want VCS workflow hyphen workspace. I'm going to click on advanced option. It is asking for Terraform working directory. The directory that Terraform will execute within this default to the root of your repository and is typically set to subdirectory matching the environment when multiple environment exist within the same directory. So what is the exact meaning of it? If you see what we have mentioned our repo. But inside this repo, we are going to have n number of subfolder. So it is asking which dedicated folder you want to mention at work directory. If I'm going to mention this working directory, so whatever the Terraform file it is present inside this folder will be executed. So in my example, what I have done, I do have dedicated folder name called as day-10. In this one, I'm having main.tf. So this is the module Linux VM, the module which is present inside my ak-edu organization, and we are passing the values day-10. So it is going to execute all the Terraform commands inside this day-10 only. So it is going to create my virtual machine and the other configuration. So it is asking for other option auto apply. Set this workspace to automatically apply changes for successful run. If disabled, run require operator approvals. We're good to ignore this one. I want a branch based rather than a tag. And then I'm going to click on create. What we have done till now, we have signed up to Terraform Cloud. Then we have created an organization, and within the organization, we have created a project. And inside the project, we have created a workspace. And then the workspace is connected to my GitHub. And inside this GitHub, we do have dedicated folder of day 10 in which our Terraform configurations files are present. So in the next video, what we are going to do, eventually all the resources are going to be created inside my Azure account. So I need to do the authentication between the Terraform cloud and Azure. So we are going to create the service principal for it and will provide the required access. Everyone, in this video, we are going to do the authentication part. So what is the requirement of authentication? If you see this Terraform cloud, and this Terraform cloud need to connect with my Azure to create the resources. So to create the resources, we need to do the authentication part. And for the authentication, we are going to use a service principal. So the command to create a service principal is this one. It will create a service principal and then it will assign a contributor access at subscription level. And we need to update 4 environment variables in our workspace. We already have the tenant ID and the subscription ID. We only need to update the client ID and client secret. So let me run this command. So this is my account. I'm going to click on Cloud Shell. Then I'm going to paste the command. I will click on enter. So service principal has been created and it has the contributor access at subscription level. I will copy this value and I'll paste it here. See, the first thing which I need is it my ARM client ID, which is my app ID, and it is asking for the client secret, which is my password. As we do have discussed, I need to update all these 4 values in environment variable. So I'm going to click on add variables. Then we are having a two option Terraform variable and environment variable. These variables are available in the Terraform runtime environment. Let me click on environment variable. And I will copy the first value, which is my ARM client ID. Will mention here key and the value is this one. We'll paste here. Then the second value is ARM client secret. I'm going to copy it. And then I will click on add variable. Then I will select environment variable. Then update the key. And then I'll copy the value. I'll paste here. This is sensitive. So I'll click on sensitive option. We have updated this ARM client secret as sensitive. So if I'm going to click here and then I'm going to click on edit variable, I won't be able to see the value. I would be only able to update it. While in the case of normal variable, if I'm going to click on edit variable, I'm good to see the value also. So the third one is tenant ID. And the value is this one. I will click on add variable. And finally, my subscription ID and then update the value. I'll click on add variable. So in this video, what we have done, we have created a connection between my Terraform cloud and the my Azure account. In the next video, I'm going to do a demo regarding the implementation steps. So thanks a lot for watching the video. Hello everyone, in this video I'm going to do a demo on VCS implementation. So what we have done till now, we have created an organization. Once the organization was created, we have created a dedicated project, and inside this project we have created workspace, and this workspace is connected to my GitHub account where my source code is present. And then we have connected this workspace to a dedicated Azure subscription. To Azure subscription. So what would be the next implementation? The next implementation it would be to run the Terraform lifecycle command from our dedicated workspace. As we do have discussed from our local machine, what we are doing? We are doing the same thing like running the Terraform init, Terraform plan and Terraform apply or Terraform destroy. And our state file was present either locally or inside our remote state management. But when we are going to run our VCS workflow, our state file will be stored inside our dedicated workspace. So let's start our demo. So this is the workspace I have created, name called VCS workflow hyphen demo hyphen project. In this workflow, I'm going to click on plus new run, and then the run type it would be plan and apply. Firstly, the planning phase will be implemented, then the apply. We'll click on start. The plan is in queue stage. It is waiting for change summary. See, the plan has been started, and the Terraform version which is using Terraform 1.10.2. See, these resources are going to be created. One, it is my virtual network. The second one is my subnet. The third one is my resource group. Fourth one is public IP. Fifth one is my NIC. And sixth one is my virtual machine. It is asking, please review the plan output. I'm, I'm going to click on the review the plan output. It will show me again about all the 6 resources which are going to be created. If there would be any kind of change, it would have showed here one change or two change or one or two destroy. Currently, we are only creating the 6 resources. That's why it is showing 6. I'll click on confirm and apply. See, then I will say looks good. Then again, I will click on confirm plan. Apply is started. It is waiting for resources. See, all the 6 resources are going to be created. So the first thing it would be resource group. The status is creating. See, our virtual machine has been also created. Let me quickly check inside my portal. I'll click on resource group, and the demo-rg has been created. And inside this one, we are having all the 5 resources. If you see here, it is showing state version created. So our state file has been created and it is present here. Let me click over it. So our state file is present here. And if you want to download the state file, we are good to click on this download tab. And our state file has been downloaded. If you see here what we have done, we have used Terraform Cloud, and this Terraform Cloud is good to create the resources inside my Azure. And from Terraform Cloud, what we have done, we have only initiated Terraform plan and Terraform apply. And all these things are running inside my Terraform Cloud dedicated workspace. And where my state file is stored, it is stored inside my workspace. So this is a benefit of using version control workflow. Okay, so in the next video, we are going to discuss about the CLI driven workflow. Here we are going to discuss about the CLI driven workflow. So what we have discussed till now. In Terraform Cloud, we do have 2 options. The first option is VCS driven workflow, and second one is CLI driven workflow. Okay, so in CLI driven workflow, we are going to run the Terraform commands from our local machine, and our source code will present inside our source code will present inside our local machine only. So But in terms of the implementation, Terraform plan or Terraform apply, it would be done in Terraform cloud, and all the state files will be stored inside our dedicated workspace. So the first thing which we have to do is to create a dedicated workspace. The second thing which we have to do is the authentication part. The third thing which we have to do to update the provider for cloud configuration. In the cloud configuration, we are going to mention our organization name and our dedicated workspace name. And the fourth thing which we are going to do before running the command called Terraform init, we are going to run a command called Terraform login. And in this command, we are going to connect our local machine with Terraform cloud. And to do this, we are going to use a PAT token. And once this task is done, the fifth step, it would be run our Terraform plan and Terraform apply. Okay, and eventually once the resource is created, the state file will be stored inside our dedicated workspace. Okay, so let's start our implementation part. So the first thing which I have to do is to create a project inside this organization. I'll click on new, then project. The project name it would be CLI driven hyphen workflow. Then I will click on create. I'm going to click on new to create the workspace. So it is asking where choose your workflow. My workflow for this implementation is CLI driven workflow. So it is asking for workspace name. I would mention CLI driven hyphen workflow hyphen workspace, and the project it would be CLI driven hyphen workflow. Then I'm going to click on create. So our workspace has been created. The first thing which we have to do, we have to update the environment variables. So I'm going to click on add variable, and the variable is environment variable. I'm going to copy this ARM client ID, and the value is this one. We'll paste it here. Then I will click on add variable. The second thing which I'm going to do, ARM client secret. Then I'm going to paste on value, then on add variable. And finally my tenant ID I'm going to copy. The value is this one. Then I will click on add variable. The last value is subscription ID. I'll click on add variable, then click on environment variable and then key. And then I will copy the value and then the add variable. So what we have done till now, we have created our workspace. We have updated the environment variable for authentication. The third thing which we have to do, we have to update our providers for the Terraform cloud configuration. Let me click on overview. If you see here, this is the code which we need to add in our provider configuration. I'll copy it and then I'm going to paste it inside. If you see, this is the same code which I have implemented in VCS driven workflow. The first thing, it is all about Terraform configuration, then our provider, the subscription ID, and it is going to create my virtual machine. And here we have created a variable for it. These are the variables and we are passing a value using demo.auto.tfvars file. So let me copy the path. So the first command I need to run, Terraform login. So it is asking, do you want to proceed? Only yes will be accepted to confirm. Yes, I want to proceed. It is asking me to create the token, and by default the token will be valid for 30 days, but I want a token only for 1 hour. So I'm going to click on 1 hour. So this is a token which is created and it is valid for only 1 hour. So let me copy it. Then here I need to paste it. I paste the value, we'll click on enter. See, welcome to SCP Terraform. It is mentioned about the documentation and currently our local machine is connected to the Terraform cloud. So the first command I'm going to run, Terraform init. See, our Terraform init has been completed. So I'm going to run Terraform plan. See, 6 of the resources are going to be created, and at the bottom there's one cost estimation. So it would be around $90 per month. I'm going to run Terraform apply. It is asking for confirmation. I'll type yes. See, our 6 resources has been created. Let me quickly check inside the portal. So we are having a resource group name called as demo-rg, and inside this one we are having the 5 resources. If you see here, we are only able to see .terraform and .terraform log.scl file. Both these files are created when we initiated a command called terraform init. But we have implemented terraform apply also. And in this apply will create a state file. So are you able to see this state file in the local machine? The answer is no. And have we configured anything in terms of remote state management? No, we haven't mentioned anything, but we have implemented this cloud block. So let me quickly check inside the Terraform. This is my organization. And inside this organization, this CLI driven workflow. And inside this CLI driven workflow, if you see view all runs, so we have initiated 2 runs. The first one is it is for my plan only run, and the second one it is for my implementation, and both of them are successful. If I'm going to do any changes in my local machine, I would say from demo-rg to demo-rg1, and if I'm going to run again the Terraform plan, we have updated the resource group name. That's why it is saying 6 to add and 6 to destroy. So what is the end-to-end workflow of CLI driven workflow? Our source code will be present inside my local machine. We are going to run the Terraform commands. I would say TF commands from my local machine, but all the commands and the state file, our state file will be present inside my Terraform cloud. And if you noticed, while running the Terraform plan or Terraform apply, it is not running from my local machine. All these things are running inside my Terraform cloud. The first step it is showing connected to the remote state. Let me show you in CLI. See, I have implemented Terraform plan. In Terraform plan, what is saying? Terraform plan in SCP Terraform output will stream here. Press Ctrl plus C will stop streaming the logs, but will not stop the plan running remotely. Preparing the remote plan to view this run in browser. This is the thing. Like I have to click on this one, and automatically my space will be opened. See, it is showing my 6 to create and 6 to destroy. And for the Terraform apply also, we have received the same thing. Running apply in SCP Terraform output will stream here. Press Ctrl-C will cancel the remote apply if it is still pending. If the apply is started, it will stop streaming the logs but will not stop the apply running remotely. Preparing the remote apply, and this is the blog which has mentioned. So this is the Terraform version it has used. So whatever the things we are seeing on our terminal in local machine, it is only logs. And the end-to-end deployment is happening inside my dedicated workspace. Okay, so this is the benefit of using Terraform CLI. Okay, so with this we have completed this demo. So in the next video we are going to discuss about the Sentinel policy. This video we are going to discuss about the Terraform Sentinel. So overview of the Sentinel. Sentinel is a policy as code framework integrated with the HashiCorp enterprise products. It enables fine-grained logic-based policy decisions and can be extended to use information from external sources. So what is the exact meaning of it? As it is mentioned, it is enables fine-grained logic-based policy decisions. Let's take example. We are creating a resource group in our Azure, but in my organization, it is compulsory to create a tax while creating any resource. Okay, so to achieve this one in Terraform, we do have the Sentinel concept. What Sentinel is? Sentinel is a logic based policy decision. So we are going to create a policy for it. If any resource we are going to create and tags are not present, it will give us an error. Okay, once we are going to run our Terraform plan, the Sentinel policy is going to be checked, is it up to the mark or not. If the Sentinel policy is saying okay, then we are good to apply it. If the Sentinel policy is saying like whatever the resources you do have created and tags are not present, at that time it is going to give us the error. If you see at the bottom, the overall result after a Terraform plan, it failed. Why? Because policy set one of them is failed. And the third thing, Sentinel policies are paid feature. Yeah. To use the Sentinel, we need to have the enterprise account. But in free account, we are good to create one Sentinel policy. High level structure. So the first thing which we are going to do, we are going to create a Sentinel policy. Okay. In the Sentinel policy, we are going to mention block virtual machine without tags. So if we are going to create any virtual machine without any tags, it is going to block it. It will give us an error. Then we are going to add this Sentinel policy to our policy, and then this policy will be connected to my policy set. So in policy sets, we can have n number of policy. The first one, it would be regarding the tags. The second policy, I would say it is regarding the specific virtual machine size we can only use. The third one, I would say only one data disk should be present in our virtual machine. If you're going to add two data disks, in this case, we are going to get the error. And finally, the policy set is going to be connected with my workspace. In the workspace, we are going to run our Terraform commands. Okay, if you want to have a detailed information regarding Sentinel policy creations and step, you're good to explore this HashiCorp documentation. So in the next video, I'm going to do a demo on this topic. So hello everyone, in this video, we are going to do a quick demo on Sentinel policy. So the first thing which we have to do, we have to write our Sentinel policy. And what is our requirement? I want all the resources should have tags. Okay. So once this Sentinel policy is written, we need to attach with our policy. Okay. And once this policy is created, we are good to attach this policy with policy sets. Okay. And finally, this policy set will be connected to my, and from the workspace, we are going to run our Terraform configuration. If the things are not matching to our policy, it will give us the error. If it is matching, then it will go ahead and apply the configuration. Okay, we do have some option in policy in terms of restriction, which we are going to discuss in our implementation steps. Okay, so let's firstly create the Sentinel policy. To create a Sentinel policy, we are good to explore the official documentation. Okay, and I have already created the Sentinel policy for this implementation. I'm going to click on settings. Then I'm going to click on create a new policy. The name of this one is demo hyphen policy. So in terms of the implementation of policy, we do have advisory, soft mandatory and hard mandatory. If it is advisory, we are not going to get any kind of error while running the Terraform plan. Soft mandatory means we are going to get the error, but we are good to override it. And hard mandatory, it means like we are going to get the error and then we have to resolve it. Then we are good to move to the Terraform apply stage. Okay. Then I'm going to paste my policy code, and it is clearly mentioned like all the resources should have tags. If they do not have the tags, we are going to get the error. Then I'm going to click on create policy. So our policy has been created, and then I'm going to click on policy sets. Then I'm going to click on connect a new policy set. I'm going to select on individually managed policies. Then the name I'm going to mention as demo hyphen policy sets. I want to select as policy enforced on selected project and workspaces. So I'm going to select projects and I want to select VCS workflow demo project, and my workspace is VCS workflow demo project. Then with runtime I'm good, and then I'm going to click on next. So it is asking for my policies, and this is the policy which I do have created, demo hyphen policy, and inside this policy I'm having my Sentinel policy detail. Then I'm going to click on connect to policy sets. So it has been implemented on my VCS workflow demo project. So let me quickly show you inside my source code. If you see here, I haven't created any tags for my resource group name, for my virtual machine, or for my virtual network configuration. So, so let me run and check whether it is going to give me any error or not. So I'm going to click on plus new run. I will say plan and apply. We'll click on start. So plan is in queue stage. See, after the Terraform plan, we are getting an error. The error is Sentinel policies errored a few seconds ago. It means like we are getting this error because in our source code we do not have any tag. So what we have to do, if I'm going to update my source code with a tag, then this Sentinel policy will be good. So this is the basic implementation of Sentinel policy.